attention, please. I request all of you to please have your seats. We are shortly going to commence the function. Namaskar and a very good morning to all of you. With immense pride and gratitude, I, Priya Pachori, Senior Geologist, welcome you all to the National Conference on Critical Minerals, Exploration and Exploitation, organized by Geological Survey of India's Central Region here at Jabalpur, also known as the Sanskar Dhani or the cultural capital of Madhya Pradesh. Powering the technologies of tomorrow starts with the minerals we explore today. From solar panels to EV batteries, critical minerals are the backbone of modern technologies and energy solutions. So, as we come together for this national conference, we hope to set the stage for sharing meaningful insights and deliberations on the ever-growing importance and utility of critical minerals. आप सभी के सामने यहाँ खड़े होते हुए मुझे ये बताते हुए अत्यंत हर्ष हो रहा है कि इस वर्ष हम भारतीय भूवैज्ञानिक सर्वेक्षण की 175वीं वर्षगांठ भी मना रहे हैं। पिछले 175 वर्षों से जीएसआई राष्ट्रीय विकास में सक्रिय रहा है और हमारे देश की भूवैज्ञानिक और आर्थिक संपदा की समृद्धि में इस संस्थान की महत्वपूर्ण भूमिका रही है। कार्यक्रम को आगे बढ़ाने से पहले मैं यहाँ उपस्थित हमारे सभी प्रतिष्ठित गणमान्य को मंच पर बुलाना चाहूँगी। सबसे पहले मैं हमारे कॉन्फ्रेंस चेयरमैन एंड विभागाध्यक्ष श्री दिनेश वी गणवीर सर से अनुरोध करूँगी कि वो हमारे चीफ गेस्ट प्रोफेसर राजेश कुमार वर्मा, ऑनरेबल वाइस चांसलर रानी दुर्गावती विश्वविद्यालय के साथ यहाँ मंच पर आए और अपना स्थान ग्रहण करें। Now I request our organizing secretary, Dr. Shruti Ranjan Mishra, Superintending Geologist, to please accompany our guest of honor, Shri Dheeraj Pandey, Director, Atomic Mineral Directorate, to the dais. I would once again request our organizing secretary, Dr. Shruti Ranjan Mishra, to please accompany Shri I.D. Narayan, Chairman and Managing Director, MECL, to the dais. अब मैं हमारे कन्वेनर डॉक्टर एस.आर. बशीर, डिप्यूटी डायरेक्टर जनरल नेशनल मिशन 2 से आग्रह करूंगी कि वे हमारे पेट्रन एंड डायरेक्टर जनरल जियोलॉजिकल सर्वे ऑफ इंडिया श्री असित साहा सर के साथ यहाँ मंच पर आएँ और अपना स्थान ग्रहण करें। Thank you all. Now let us take a moment to express our heartfelt gratitude and honor our esteemed dignitaries on the dais, whose presence today adds immense value and grace to this national conference. First of all, I request Shri Dinesh V. Ganveer, ADG and HOD, Central Region GSI, and the chairman of this national conference to kindly felicitate our chief guest, Professor Rajesh Kumar Verma, Honorable Vice Chancellor Rani Durgavati Vishwavidyalaya, with plant sapling, shawl, and memento. अब मैं हमारे कॉन्फ्रेंस चेयरमैन एवं विभागाध्यक्ष श्री दिनेश वी गणवीर सर से फिर से अनुरोध करूंगी कि वह आज के विशिष्ट अतिथि श्री धीरज पांडे, डायरेक्टर एटॉमिक मिनरल डायरेक्टोरेट का अभिनंदन करें।
The Bhimbetka rock shelters are evidences of perfect symbiosis between Mother Nature and the onset of human civilization in India. Natural forces like rain,
Thank you, sir. I once again request Shri Dinesh V. Ganvi, sir, to kindly felicitate our guest of honor, Shri I.D. Narayan, Chairman and Managing Director, MECL. I now request our conference convener, Dr. S.R. Bashir, Deputy Director General, National Mission 2, to please welcome and honor our patron and Director General, Shri Asid Saha, sir. अब मैं अनुरोध करती हूँ श्री राजेश जोशी सर, डिप्यूटी डायरेक्टर जनरल स्टेट यूनिट मध्य प्रदेश से, कि वह मंच पर आएं और यहाँ उपस्थित हमारे कॉन्फ्रेंस चेयरमैन एवं विभागाध्यक्ष श्री दिनेश वी गणवीर सर का सम्मान करें। I now request Shri Benudar Behra, Director and Head of Office, State Unit Madhya Pradesh, Jabalpur, to kindly felicitate our conference convener, Dr. S.R. Bashir, Deputy Director General, National Mission 2. Thank you all the esteemed dignitaries. We are truly privileged by your presence and guidance. आइए अब हम इस पावन अवसर का शुभारंभ दीप प्रज्वलन से करें। तमसो मा ज्योतिर्गमय अर्थात अंधकार से प्रकाश की ओर। ये मंत्र न केवल शब्द हैं बल्कि ज्ञान, स्पष्टता और चेतना की ओर हमारे सामूहिक प्रयाण की अभिव्यक्ति भी है। मैं मंच पर उपस्थित हमारे सभी माननीय अतिथियों से सादर अनुरोध करती हूँ कि वे कृपया मंच के समक्ष पधारें और दीप प्रज्वलित कर इस राष्ट्रीय सम्मेलन का औपचारिक उद्घाटन करें। मैं मृणालिनी मैडम से भी आग्रह करती हूं कि वह इस अवसर पर सरस्वती वंदना प्रस्तुत करें।
नी रे सा रे रे पा मा पा नी धा नी सा नी पा मा पा ग ग मा रे सा। जयति जय जय माता सरस्वती विद्यादानी सुंदरी। जयति जय जय माता सरस्वती विद्यादानी सुंदरी। नाचती तत था थई थई घुंघरू की झनकारिणी। धा तिरकट धूम तिरकट मृदंग बाजे वीणा सुर झंकारिणी। जयति जय जय माता सरस्वती विद्यादानी सुंदरी। जयति पद्मासिनी माता जयति शुभ वरदायिनी। जयति पद्मासिनी माता जयति शुभ वरदायिनी। भक्तों की तुम बिनती सुन लो देवी बुद्धि ज्ञान दी। जयति जय जय माता सरस्वती विद्यादानी सुंदरी। विद्यादानी सुंदरी विद्यादानी सुंदरी। धन्यवाद।
बहुत बहुत धन्यवाद मैडम। I now invite Dr. S.R. Bashir, DDG, National Mission 2 and the convener of this conference to deliver the welcome address and outline the scope of this conference.
Thank you, ma'am. A very good morning to everyone. It is with immense pleasure and great honor that I welcome you all to the National Conference on Critical Minerals, Exploration and Exploitation. I also welcome to the people who have joined online. It is a timely and significant gathering that brings together key stakeholders from across the country to deliberate on one of the most vital aspects of our nation's strategic and economic future. This conference holds special significance as it not only aligns with India's growing need for sustainable and strategic mineral development, but also marks the 175-year journey of GSI unparalleled contribution to earth science and national development. We are truly privileged to have with us today a distinguished lineup of dignitaries and experts whose presence adds immense value to this conference. Let me begin by extending a warm and heartfelt welcome to our most revered chief guest, Professor Rajesh Kumar Verma, Honorable Vice Chancellor of Rani Durgavati University, Jabalpur. Sir, your esteemed presence here today is a great source of inspiration to all of us. So we are truly honored to have you with us, sir. We are equally delighted to welcome our guest of honor, Sri Dheeraj Pandey Saab, Director AMD, whose dedication and contribution to the field of minerals and natural resources are widely respected. Thank you, sir, for joining us today and gracing this occasion with your kind presence, sir. It is our great pleasure to welcome our guest of honor, Sri Indradev Narayan Sir, CMD, MECL at this national conference. His presence inspires and elevates the significance of this gathering. We are truly privileged to have you, sir, with us today. We extend a profound gratitude and respectful welcome to our lovable and honorable Director General and patron of this conference, Sri Asit Sahasab, under whose guidance and support this event has taken the shape. Sir, your unwavering encouragement and strategic direction have been pivotal in realizing the vision behind this national level dialogue. I am equally pleased to welcome our chairman of the conference, Sri Dinesh V. Ganvi sir, Additional Director General and Head of the Department, Geological Survey of India, Central Region Nagpur, whose stewardship and thoughtful insights have provided the foundation for the structure and scope of this conference. Sir, your leadership has been instrumental in aligning our efforts with national priorities, sir. We are also deeply honored to welcome Srimati Barsha Ashok Algawa Madam, Additional Director General and Head of the Department, Geological Survey of India, Eastern Region. We are equally honored to welcome our esteemed Deputy Director Generals of Central Headquarters, National Mission 2, different regions and state units of GSI, whose knowledge, diverse experiences, and engagement in this field will greatly enrich the deliberations during this conference. It is both an honor and privilege to extend a warm and respectful welcome to our distinguished keynote speakers, namely Professor Sali Bahan, Director, IIP Visakhapatnam, Professor Alok Parwal, IIT Bombay, Professor P.R. Sahu, IIT ISM Dhanbad, Dr. Satadru Bhattacharya, Principal Scientist, ISRO, Sri M.B. Barma Saab, former Director, AMD, and presently at National Security Council Secretariat of India, New Delhi. Sirs, your presence at this gathering is a matter of great pride for us and reflects the deep commitment shared by the leading national institutions towards fostering sustainable development, technological advancement, and strategic resource management in the field of mineral and mining sector. We are extremely privileged to extend a heartfelt welcome to Sri Srikant R. Manthanwar Saab, Regional Director, AMD Nagpur, Sri S.K. Adhikari Saab, Chief Mining Geologist, IBM Nagpur, and other eminent dignitaries from the geoscience and mining fraternity. We are honored to have you, sirs, in this event. A heartfelt welcome also goes to our respected retired officers whose legacy of service and depth of expertise to continue to be a source of strength and wisdom for the current and future generations. We are honored by your continued presence and involvement in this national cause, sirs. At last, but by no means least, I extend a warm welcome to our all participants, including policymakers, scientists, researchers, industry partners, academicians, students, and of course, the media persons. Your active engagement and ideas are the backbone of this conference, and we look forward to fruitful interaction ahead. Together, let us use this platform to foster knowledge sharing, collaboration, and concrete action towards securing and sustainably managing our nation's critical mineral resources. Thank you again for being here. I wish you all an insightful, productive, and inspiring conference. Thank you. Thank you very much.
बहुत बहुत धन्यवाद सर अपने विचार हमारे सामने रखने के लिए। अब मैं श्री दिनेश वी गणवीर सर, एडीजी एंड एचओडी नेशनल मिशन 2 एवं सेंट्रल रीजन से अनुरोध करती हूं कि वे हमारे समक्ष आएं और अपने विचार रखें।
Dignitaries on the dais, Professor Rajesh Verma Vice Chancellor,
was 23rd March.
श्रीमान धीरज पांडे जी, डायरेक्टर एटॉमिक मिनरल डिवीजन, श्रीमान ID नारायण साहब, CMD MECL, हमारे डायरेक्टर जनरल श्री अशित शाह साहब, बशीर साहब, ऑफ द डायस, respected dignitaries, officers, students, my colleagues, my fellows from the industry, the students, and the officers and staff from GSI Jabalpur office. I, Dinesh Ganvir, welcome you all in this critical mineral conference, national conference on critical minerals, exploration and exploitation. महोदय, किसी भी जगह का आइडेंटिफिकेशन करना किसी कार्यक्रम के लिए, उसे वहाँ सफल बनाना एक बहुत महत्वपूर्ण काम होता है, जिसके लिए हम सतत, मेरी टीम, हम लोग सतत प्रयत्नशील रहे हैं लगभग 1-2 महीने से। जिस जगह हम आज बैठे हुए हैं, जबलपुर, it is a historical and cultural place. Not only that, but geologically भी इस जगह का अपना एक महत्व है। जबलपुर, जिसके पास से एक नदी जिसका नाम नर्मदा है, और भारतवर्ष में इस नदी को माँ नर्मदा के नाम से हम जानते हैं। हमारे कल्चर में किसी नदी को महत्व देना, माँ का महत्व देना, हम समझते हैं कि किस तरह महत्वपूर्ण है। एक माँ जो अपने बच्चों को छोटे से बड़ा बना करके अपने पैरों पे खड़ा करती है, और हम एक नदी को क्यों माँ कह रहे हैं, माँ नर्मदा। सोचने वाली बात है कि जिस तरह से एक शरीर में तत्वों से बना होता है, 5 तत्वों से बना होता है, जिसमें कि एक पानी एक तत्व है। ये पानी जो इस धरती को सींचता है, पूजनीय है। इस जगह को हम लोगों ने आइडेंटिफाई किया क्योंकि धुआंधार फॉल्स है, यहाँ पर लमेटा बेड्स है, जहाँ की हमें डायनासोर के अवशेष मिले हैं। इस जगह का एक अपना महत्व है, इसीलिए इस जगह पर हमने आज का जो एक नीड है, भारतवर्ष को एक नीड है क्रिटिकल मिनरल्स। हम सब जानते हैं कि किसी भी कंट्री की इकोनॉमी, फर्स्ट इज द इकोनॉमी, then is the self-reliance, sustainability. हम लोग सभी जितने क्रिटिकल मिनरल्स हैं जो आज दैनंदिन कार्य में हमें उपयोग में लाना पड़ता है, मोबाइल से लीजिए, एटॉमिक पावर प्लांट लीजिए, डिफेंस में लीजिए, मेडिकल इंस्ट्रूमेंट्स लीजिए, इन एनी फील्ड इफ यू गो, critical minerals are the need. And we thought that almost we are 100% dependent on the critical minerals in import. Government of India, Ministry of Mines thought we should identify the critical minerals for India in August 2023. 30 critical minerals आइडेंटिफाई हुए। उसके बाद Ministry of Mines, Government of India has launched tranche-wise auctioning of these critical minerals. Almost 54 blocks we had launched, and out of those, the success is auctioning of 28 blocks. The theme which we had identified for this critical mineral national conference, it is not only related to the exploration, the techniques, the technology, but also with the introduction, recognition of these identified resources, how we should move ahead with the extraction, exploitation technologies. And that is why this huge gathering of our strength, the roots which holds any tree to be strong in the storms. Our retired, right from the Director Generals to the Additional Director Generals to the Deputy Director Generals, the industry, दो हाथ के बगैर काम नहीं होता, एक हाथ से आप कुछ नहीं कर सकते. अगर आप ब्लॉक्स आइडेंटिफाई करके रिसोर्सेज आइडेंटिफाई कर रहे तो उसको आपको एक मकाम तक पहुंचाना है, एक्सट्रैक्शन, एक्सप्लॉयटेशन एंड द एंड यूज, एंड फॉर दैट industry's presence is very much required. We had got the industry with us, not only the industry, but the students, the new brains, the new thinkings. We had also identified the students, we had called them, and the academia also. Because what the government organizations, they are working in certain orientation, but the academic institutions, they have their thinkings, they have their research, and with the themes and the officials or the presenters which we had identified, with these 2 days, you love to see the presentations. We are not far behind. The goal, I think, will soon be achieving in the extraction and the exploitation, the recycling technologies. Government of India, Ministry of Mines had taken a call in 2023, and it is now 25. Number of meetings, number of workshops. Ministry of Mines, headed by our respected Minister Sahab, Secretary Sahab, Additional Secretary Sahab. Number of meetings, workshops are there, and we are trying hard. They are trying hard how the resources can be converted into reserves. Industry is being called, academia is being called, and the new thinkings, the new thoughts, how we can move ahead with the inbuilt technology. This is the theme. Not only that, one research scholar will be joining us from US tomorrow online, and our topic is studying of surface of Mars. She is at NASA. She belongs to Nagpur, but seeing our themes, our conference for these critical minerals, at my request, she'll be joining tomorrow, and would be happy to see how the NASA is taking up the programs, not only on the surface of the earth, but in the outer space. Once again, I thank you for being here for this critical mineral national conference, and hope your presence, your interactions, your discussions, your new thinkings will put way forward. Thank you. Thank you all.
Thank you so much, sir, for sharing such kind words with us. Now, with a big round of applause, I now invite Shri Asad Saha, Director General, Geological Survey of India, and patron of the conference, to address the gathering.
Very good morning. Okay, so this is Nice occasion to meet you all. And I'm personally elated to see our ex-DG, Sri Kutumburao Saab here. And Sarolkar Saab, who has been dealing with all technical matters, sitting at CHQ at some point of time. We have the CMD MECL, Indra Narayan Dev here. We have Director AMD, Dhiraj Pandeji, and of course our chief guest, Professor Rajesh Kumar Verma, who is the Vice Chancellor of Rani Durgavati Vishwavidyalaya. Ganveer ji, who is taking care of this, arranging this workshop along with his deputies, Dr. Bashir, Sandeep and Deepak, all my colleagues and friends. Very good morning once again. And I must say that I am very happy to be here because, you know, this workshop, this conference, whatever you call it, this is a celebration of 175 years of our existence. And what an existence it has been. If you just reflect on the work which we have done so far, starting from coal exploration to today talking about critical minerals, it has been a long, arduous journey, but a glorious one. As I said, we started with coal exploration at some point of time, 175 years ago, just because of the fact that there was demand of coal at that point of time. The Britishers who were running our country at that point of time, they decided that we should have railways, we should have communication through waterways. So all those steamers and rails, they needed coal as the fuel to run those engines. While searching for coal, the geologist understood that there need to be a sort of systematic understanding of the geology of this country. And then we spent the next 50 years in mapping the country systematically. Today, I am proud to say that India is the only country to have mapped the whole length and breadth of its mass at 1:50,000 scale in this great detail. And we have not stopped there. We have then completed the geochemical mapping of the country at the same scale once again. And this geochemical mapping has given us this wonderful database consisting of 62 elements data, primary dispersion data, which today we are using extensively for defining and delineating and formulating our current and future projects. And it is not only GSI. If you are privy to the data dissemination efforts of ours through Bhukosh and NGDR, you will be knowing that all the players in this mineral ecosystem are using our data. In fact, without the data from GSI, no exploration project can be formulated, whether it is GSI or it is an NPA. Today, we have a big challenge. We have got all the data. We have got exploration geologists in GSI and in non-GSI, government and private companies. We have a task cut out for us. We need to search and find critical minerals. Now, this is something which is in everybody's lips for the last 2-3 years. And it gained momentum when Ministry of Mines took an initiative to declare 30 minerals as critical minerals. And coincidentally, there was an find in Jammu and Kashmir for a lithium, which is a coveted commodity at this point of time. All these things created a lot of furor in the media, and people started talking about critical minerals. By this time, all of us, I consider everybody who is present over here, they are all connected with geoscience exploration, research. You all know why critical minerals are needed. The situation which we as a country are now, we are facing great challenges. The challenges are not only technical or geological, the challenges are political also. And it is not confined only within our country, but it is a global disaster scenario. Why so? Because even though we have started talking about critical minerals and all these things for the last 1 decade or so, some countries, we all know what I'm talking about, they have started this journey 40 years back. Because of their foresight or their planning, they are today in a position that they can dictate and they can arm twist other countries. So we as a country are at a receiving end. We depend on some other countries for the critical mineral resources. The technologies which we are in vogue today or in the futuristic technologies, they all need clean energy transitions. And to achieve that, we need these critical minerals badly. The targets which we have set for ourselves, becoming a net zero country by 2070, the Viksit Bharat target, all these are dependent on we becoming self-sufficient as far as critical minerals are concerned. So what is GSI doing in this respect? We are not sitting idle. Simple statistics will tell you that how serious we are about this. 10 years back, we had only 40 projects for critical minerals. And today, in 2025-26, we have 230 projects. It's an astronomical jump over these years. We know the importance, we know the significance of doing this work. But the story doesn't end here. What GSI does is exploration. Even MECL, AMD, our siblings, they also do exploration. And what we do is, after this exploration is over, our output in the form of reports are handed over to the concerned agencies. In some cases, it is Ministry of Mines. In some cases, it is the state government or some other government agency where we give our output. What is to be done after that? Well, that has to be realized through an operational mine. And there lies the challenge at this moment. We as a country do not have the industry scale expertise to extract and process most of the critical minerals, especially RE, which is in talks right now. The EV industry is in doldrums because there is a setback in getting rare earth magnets, without which the EV batteries cannot run. We do not have the processing technology with us. The processing technology is controlled by China, 90% of it. And one must understand that it's not so easy to find these type of deposits. A lot of work, a lot of research is needed. And our officers are doing that in every corner of the country. At some point of time, it was thought that RE is found only in beach sand deposits. No, it's not like that. They are found elsewhere also. And at this moment, we have got very promising projects in Rajasthan, Gujarat, Assam, West Bengal. But what will happen after we hand over these reports? Will we be able to extract these REs? Will we be able to produce magnets as a country? This whole value chain, whole midstream and downstream sector is at a nascent stage. It may require a lot of effort, lot of funding, lot of good intent, and lot of policy backing to become robust. And Ministry of Mines, understanding fully well that this is needed, National Critical Mineral Mission, NCMM, has been promulgated by them. The second year of NCMM, and very recently through NCMM, 7 institutes, including 4 IITs, has been declared as Center of Excellence. What will these Center of Excellences do? They will focus on this very aspect of extraction, processing of critical minerals. Because all of the wise minds have understood, acknowledged this issue, that this is an area where we must put all our efforts. So these Center of Excellences are going to do research funded by the industry as well as the government to find out technologies, fine-tune technologies, which are existing in lab scale, maybe in pilot scale, but not in industry scale. And not only with the primary resources, but also with the secondary and tertiary resources. What do I mean by secondary resources? The mine dumps, the tailings, the gangs, the slags, which are byproducts from extraction activities for some other commodity. They will also be, we have found incidences of critical minerals in those leftovers. So they need to be processed to find out, to extract these critical minerals. At the same time, you all must have heard about urban mining, circular economy. So that is where, what do we talk about these tertiary resources, the e-waste in particular. E-waste is an area which is very, little bit confusing because it is guided by a lot of policies. It's an interministerial thing. And India is in a very nascent stage in this aspect of circular economy. Europe is much ahead. So you can understand there are a lot of challenges in this sector. We need to find out new areas where we want to explore. We need to find out avenues, technologies through which we can extract and exploit these resources which we have found. And we need to find out ways and means of organizing the sector for circular economy. And each of these challenges actually put forward lot of avenues for working, research, innovation, and out-of-the-box thinking. So having a critical mineral exploration and exploitation conference today is just to discuss about, deliberate about all these challenges and the opportunities which they provide. So all these great minds who are sitting here, it's my request to all of you, please ponder on these thoughts. There are interesting presentations lined up all throughout these 2 days, ranging from classical discourses on geological milieus, then thinking about the outer space, the planetary insights, extraterrestrial insights, thinking about how we can develop this platform of circular economy. All aspects are dealt in this conference, and there are interesting speakers from different corners of the country and even from abroad. I personally is very much excited to be here, and I'm sure you all are equally excited. And I am also definite that this we will, at the end of this workshop, we will go back home with a lot of takeaways, something which will provide us fodder for the next few days. We can think over them, and we can maybe do some course correction in the work which we are doing. We will gain new knowledge. In fact, that is the motto, that is the objective of this workshop. We do exchange of ideas, we learn from each other, and ultimately we put our effort so that our country becomes self-sufficient in the sector of critical minerals. Thank you very much. Best wishes.
Thank you so much, sir, for sharing your vision with us and guiding us in this endeavor. It is with great pleasure to inform you that on this platform today, we are unveiling a number of key publications. For this, I would request Shri Dinesh Toed sir, Deputy Director General and Regional Mission Head 3, Central Region, Srimati Shipra Mishra Madam, Director Publication Division, and Dr. Seema Devalkar, Director Map and Cartography Division, to kindly come on the stage and along with the esteemed dignitaries, come forward for the release of these publications. I request Shri Dinesh Toed sir to please come on the stage. Srimati Shipra Mishra Madam. I request all the esteemed delegates present here to welcome our dignitaries and guests with a big round of applause. Firstly, we are glad to release the abstract volume of the National Conference. It encapsulates the essence of presentation and posters that are being delivered today and tomorrow. धन्यवाद सर। अब मैं डॉक्टर पीके सिंह, डिप्टी डायरेक्टर जनरल मिशन 3C एवं राजभाषा अधिकारी केंद्र मुख्यालय कोलकाता एवं श्रीमती मोहिनी साठे मैडम, डायरेक्टर एवं राजभाषा अधिकारी मध्य क्षेत्र से आग्रह करूंगी कि वह मंच पर आएँ और हमारी हिंदी पत्रिका नर्मदा का यहाँ पे हमारे एस्टीम्ड गेस्ट के साथ विमोचन करें। we now present the compendium on critical mineral blocks. And then we will have the unveiling of the compendium on auctionable blocks handed over by GSI. I request all the dignitaries to kindly release these publications as well. अब हमारे पास compendium on auctionable blocks that have been handed over by GSI का रिलीज़ है. मैं रिक्वेस्ट करूँगी शिप्रा मिश्रा मैडम से कि वह यहाँ पे आए और ये compendium सभी dignitaries के साथ में रिलीज़ करें. Thank you so much, sir. We now unveil the mineral belt map of graphite deposits, Betul belt of Betul district in Madhya Pradesh. We also have the mineral belt map of phosphorite deposits of Jhabua belt, Jhabua district of Madhya Pradesh. थैंक यू सर. अब हम प्रस्तुत कर रहे हैं रिकॉर्ड्स ऑफ द जियोलॉजिकल सर्वे ऑफ इंडिया के 3 संस्करण वॉल्यूम 156, वॉल्यूम 157 एंड वॉल्यूम 158 का, जो कार्य सत्र 2021-22, 2022-23 और 2023-24 के फील्ड कार्यों को समाहित करता है. This is the volume 157, part 6, Central Region, that briefly describes the fieldwork that was carried out in FS 22-23. Thank you so much, sir. Now we have volume 158 of the Records of Geological Survey of India that encapsulates the extended abstracts of FS 23-24. Thank you all. Lastly, we have the digital release of 10 district resource maps of Madhya Pradesh that aim to promote easy access to geoscientific data for stakeholders and planners. I request all the dignitaries to kindly come forward for the digital release. The 10 districts whose DRMs we are releasing today are Damoh, next is the district resource map of Hoshangabad, next we have the district resource map of Mandala, DRM of Morena, Raisen, next we have the district resource map of Mandsaur, district resource map of Ratlam, DRM of Indore, district resource map Khargon, and lastly district resource map of Khandwa district, Madhya Pradesh. Thank you so much, sir, and all of you for joining us in the release of these publications. With a big round of applause, I would like to invite our esteemed guest of honor, Shri I.D. Narayan, Chairman and Managing Director, MECL, to please, sir, come on the dais and address the audience.
Very good morning. Dignitaries on the dais, dignitaries of the dais, Shri Rajesh Kumar Verma, VC Rani Durgavati University, Honorable Shri Asit Shah, DG GSI, Honorable Shri Dheeraj Pandey Sahab, Director AMD, Honorable Shri Ganveer Sahab, Bashir Sahab, Madam Varsha Aglave, Shri M.B. Verma, Manthanwar Sahab, and all other luminaries present here in this hall. First of all, I thank the organizer to give me this chance to be present here in this august gathering. And a big thank to DG Sahab, who has made my life easy. His address was so comprehensive, nothing else is left to be said. This conference is very apt and it is need of the hour. The exploration and the exploitation, these two subjects go hand in hand and they complement each other. We have our own targets, as DG Saab has told. By 2070 we have to be net zero. There was another goal that by 2030 we will have more than 50% of the non-fossil fuel energy generation, and it is very happy to note that we have achieved this goal. A few days back on 14th of July, the total installed capacity of non-fossil fuel has increased more than 50%. So we are 5 years ahead of the our target, committed target. This shows that we are on the right track and we have our commitments in the right place. We are doing the right things, but a lot of the things still has to be done. The critical minerals, these are the new oils. They will drive the future. To accelerate this transition, the Government of India has introduced a dedicated auction mechanism under MMDR Act. And as mid of 2025, we have 34 critical mineral blocks successfully auctioned, and in the 5 tranches of auction launched by Government of India. Very soon we will have the 6th tranche of critical mineral auction, and GSI is playing exemplary roles in this auction process, and I am happy to share that MECL is also contributing as a technical consultant to Ministry of Mines for this critical mineral auction. Recently launched exploration regime. 13 blocks have been, NIT for 13 blocks have been launched, and there has been a very good response. For 7 blocks, there are multiple agencies bidding for that. I would like to reiterate that this is the time of technology, and MECL is continuing with modernizing its exploration capabilities, employing the latest technologies such as remote sensing, hyperspectral imaging, AI-driven technologies for the exploration. And I'm again happy to share that very soon we will have India's first hyperspectral core scanner in MECL. Very recently a team of MECL and GSI has visited Canada for the pre-dispatch inspection of this instrument, and we have target of December 2025 for installation of this machine, but I think this equipment will be there by end of October, will ahead of schedule. Again, as DG Sahab has told, that National Critical Mineral Mission is going to play a major role in the future for the exploration and exploitation of critical minerals. and there are expected to be investment around rupees 34,000 crores, more than 34,000 crores. This mission strengthens the India's strategic autonomy in the mineral sector. India's mineral policy is not about mining more, but mining smarter, cleaner, and responsibly. Techniques such as hydrometallurgy, bioleaching, membrane separations are being adopted for efficient, low-impact extraction, and simultaneously the urban mining, that extraction of minerals from the e-waste, tailing, fly ashes. So nothing is waste these days. There is a couplet in Urdu that goes like this: Rakh kadam phoonk phoonk kar zahid, zarre zarre mein jaan hai pyare. Every zarra what is present on this earth has got something to offer for the mankind. To ensure the sustainable growth, we must invest not only in technology but also in people. As the resources go deeper and mining becomes complex, reskilling, upskilling is going to play a major role. We have to invest on that also. I am pleased that this conference also addresses policy innovations, international cooperations, both critical and long-term successes. The reforms in FDI norms, custom duties, and streamlining auction process are making India's globally attractive destination for critical mineral investment. MECL, on their part, we are part of a joint venture group along with Hindustan Copper and NALCO. We have started a project in Argentina and for the exploration of lithium. And first phase of that has been successfully completed. That report of first phase has been reanalyzed by GSI also. I am thankful for that. And very soon we will be launching second phase of that exploration. That includes the physical drilling and testing of that. So we hope that within couple of years we will have some good news from Argentina also. MECL has signed a standalone MOU with Catamarca province of Argentina. We are also part of a team of GSI which is looking for minerals in Zambia. There is NCCM also supports this kind of expeditions. Of course, the challenges remains. Geological complexities, environmental sensitive, and global dependencies. But collaborations, innovations, and the strong institutional coordination, we can overcome that. To the young scientists, young geologists, engineers present here, I urge to treat this not just as a profession, but also a mission. The mission to power India's future, uphold climatic commitments, and ensure the mineral development aligns with sustainability and equity. And everyone who is on this earth is an explorer. सभी कोई कुछ ना कुछ खोज रहे हैं, कुछ सत्य की तलाश में हैं, कुछ आध्यात्म की तलाश में हैं, ईश्वर की तलाश में हैं, हम खनिज की तलाश में हैं। तो हम सब जो यहाँ मौजूद हैं, मैं सबका धन्यवाद करता हूँ कि आपने अपने बहुमूल्य समय में से समय निकाला, आप यहाँ आए और इस कार्यक्रम का हिस्सा बने और अगले 2 दिनों तक आपका जो ज्ञान है, आपका जो अनुभव है, वो आप हम सब के साथ बांटेंगे। मैं इस कार्यक्रम के जो आयोजक हैं उनका हृदय से आभार मानता हूँ। इन कार्यक्रमों का आयोजन बहुत सरल नहीं होता। तो गनवीर साहब, बशीर साहब और उनकी पूरी टीम को मैं धन्यवाद देता हूँ कि उन्होंने इस आयोजन को साकार किया और हम सब लोगों को मौका दिया कि हम अपने ज्ञान में कुछ वृद्धि कर सकें। बहुत बहुत धन्यवाद। थैंक यू सो मच।
Thank you so much, sir, for sharing your kind words with us, and we hope that MECL and GSI will work hand in hand for critical mineral exploration in the country. अब मैं हमारे गेस्ट ऑफ ऑनर श्री धीरज पांडे सर, निदेशक एटॉमिक मिनरल डायरेक्टरेट से अनुरोध करती हूँ कि वह मंच पर आएं और अपने विचार साझा करें। कृपया जोरदार तालियों के साथ उनका स्वागत करें।
Namaskar, good morning. Honorable dignitaries on the dais, eminent geoscientists and researchers in the audience, a very good morning to you all. At the outset, I would like to thank the Additional Director General and HOD Central Region Nagpur, Sri Ganveer ji, for giving me this opportunity to participate in this National Conference on Critical Minerals. In fact, I would like to acknowledge and appreciate the sincere efforts that have been put in by his team, the organizers of this event, because this particular conference on critical minerals has come at the right time, and if you look at the world scenario right now, the kind of geopolitics that is emerging in this era. So now, in the recently held BRICS summit, also our Prime Minister, Honorable Prime Minister, he said that this critical minerals are now being used as weapons of economic warfare. So very true, these words, they sound very true. And that is why I say that this has come at the right juncture. And GSI being the primary agency in the forefront of exploration of minerals, and especially critical minerals now, has taken the lead. And over the years, GSI, it has a long history, perhaps it is the oldest geological survey organization in the world. It has taken the lead in developing the mineral sector of the country. And now, for the past few years, it has now come up in the forefront of exploring critical minerals and deep-seated minerals. And under the present leadership of Saha ji, it is progressing leaps and bounds in this particular sector. And AMD as such is also not far behind. In this league, we are also performing, we are also coming up with development and conservation of our indigenous resources. In fact, many of you may not be aware that AMD emerged out of GSI way back during the Second World War, the latter half of Second World War, as a rare metal survey unit. That was known as RMSU that time. It so happened that the British government of India at that time, it appointed a task force to look for beryl, a mineral of beryllium, you are all aware, because primarily the need for beryl arose at that time because it was felt that beryl, the mineral beryl, which produces beryllium, that was a critical mineral at that time for production of war machinery like gyroscopes and fighter aircrafts. It was used in marine diesel engines, and of course as a strengthening material with the copper, as a copper beryllium alloy. So sudden need arose at that time, and the primary task of RMSU was to look for beryl. So if you see the history of critical minerals in India, it is a long history. I mean, during the Second World War, the criticality was exposed. It was at this juncture that the very organization which you know by name of AMD today, that was created, and the mandate of AMD post-independence was, besides exploring for the nuclear raw materials, also to explore for so-called critical minerals like niobium, tantalum, beryllium, zirconium, titanium. So in fact, we also celebrated our 75th anniversary last year, and during the past 7.5 decades, AMD has also gained an experience. It has that capability of developing and augmenting resources of these critical minerals. You are aware that earlier there are 6 atomic minerals that we have now been put in the critical mineral list post amendment of MMDR Act in 23. These are all part of atomic minerals. So that kind of capability does exist with AMD, and it is now playing a major role in exploring these resources. Then as Saha said, I also second his thoughts that we need to develop the midstream and downstream sectors
of this value chain, critical mineral value chain. We have indigenous resources, we are capable of exploring, we are capable of mining, but when it comes to beneficiation and processing and further refining of these critical minerals, that expertise is still, we are in a nascent stage. We have to develop that, we have to fast track that technologies. And of course, we should also now try to recycle the end life products like mobile phones and magnets available, because that again is a good source, secondary source for recovery of these critical minerals. So with this particular background, I feel this conference, it will provide a good platform for interaction between different agencies. And the need of the hour is collaboration between the government agencies, the exploration agencies, the industry and the academia. And we should now be working together so that we have a synergistic kind of an approach in this critical mineral sector. And our dream of self-reliance in this particular sector, or Atmanirbharta in this critical mineral sector, we can only achieve it once we start working together and not in silos. So with these few words, I once again thank all of you, present here, especially the organizers. Thank you. Jai Hind.
Thank you so much, sir, for your kind words. AMD had always been a pioneer in exploration of atomic minerals, and we hope that this quest continues for critical minerals as well. Now, with a big round of applause, we would like to invite our chief guest, Professor Rajesh Kumar Verma, Vice Chancellor, Rani Durgavati Vishwavidyalaya, to share his valuable insights with us.
सभी को नमस्कार। आज के इस कार्यक्रम में मंच पर उपस्थित श्री SR साबिर जी, गणवीर जी, आशीष साहा सर, नारायणा जी, धीरज पांडे जी और सामने उपस्थित सभी जो इस फील्ड से संबंधित और विद्यार्थी हैं। ऐसे ये विषय मेरा नहीं है, लेकिन जहाँ से ये विषय समाप्त होता है वहाँ से मेरा विषय शुरू होता है, क्योंकि जब आप खनिज निकाल लेंगे और भारत सरकार को सौंपेंगे, किसी कंपनी को सौंपेंगे और उसके बाद जो वाणिज्य की प्रक्रिया शुरू होगी, कॉमर्स के विद्यार्थी के नाते जैसे अभी मैं सर से बात कर रहा था, उस समय हमारा काम शुरू होता है एज ए चार्टर्ड अकाउंटेंट। 94 में CA कंप्लीट किया, तो जैसे ही आप निकाल के बाहर रखेंगे उसके बाद हमारा कॉस्टिंग, प्रॉफिट, इंपोर्ट, एक्सपोर्ट का काम शुरू होगा। तो विषय थोड़ा अलग है, लेकिन चूंकि भारतीय ज्ञान परंपरा और उन सब विषयों में मेरा इंटरेस्ट रहा है और चूंकि आपने इस विषय पर आमंत्रित किया है, और मैं अगर मेरे से पूछा जाए कि आज के इस कार्यक्रम में आने का मुझे क्या लाभ हुआ, बुलाने वालों का लाभ के बारे में तो वो आप लोग तय करेंगे, लेकिन मेरा लाभ ये हुआ, मेरा बहुत ज्ञान बढ़ गया। मैंने अभी बैठे बैठे जो आपके साहा सर से बहुत सारी चीज़ें जो डिस्कस की, कई चीज़ें मुझे नहीं पता, वाणिज्य के विद्यार्थी को पता ही नहीं होता कि ये विभाग क्या काम कर रहा है, और ऐसा लगता है कि पेट्रोल का काम भी यही कर रहे हैं, गैस का काम भी यही कर रहे हैं, माइनिंग का काम भी यही कर रहे हैं, क्योंकि उस नाते मुझे अभी बहुत सारी चीज़ सीखने को मिली। और सबसे बड़ी बात जो सर ने मुझे बताई है और अभी उनके भाषण में भी कहा कि हम 65 साल में केवल 40 प्रोजेक्ट पे काम कर रहे थे और पिछले 10 सालों में 190 प्रोजेक्ट नए शुरू करते हुए हम 230 प्रोजेक्ट पर पहुंचे। एक बार विभाग के इस काम के लिए तालियां होना चाहिए। दूसरी जो मुझे बैठे बैठे मंच पे जानकारी में आया, और जो मैंने कई बार कॉमर्स के विद्यार्थी होने के नाते इंपोर्ट एक्सपोर्ट की बात सर से कई बार करता रहता हूँ, तो ऐसा जो जानकारी में कि कई मिनरल्स जो हैं हम आप लोग की तरफ से आता है और सरकार को दी जाते, कंपनी को दी जाते हैं, तो हमारे यहाँ उनके प्रोडक्ट करने के लिए, उसको एक फिनिश प्रोडक्ट बनाने के लिए हमारा कई टेक्नोलॉजी नहीं है। सर ने मुझे बताया कि यहाँ से एक्सपोर्ट होता है और फिर वहाँ प्रोसेस होकर वापस इंपोर्ट करता है। और जो कल ट्रंप ने हमारे साथ एक जो किया है, आपने देखा होगा आज 25% टैरिफ, ऐसे लोगों को जवाब देने के लिए और उल्टा टैरिफ हमारी तरफ से लगाने के लिए हमको इतना स्ट्रांग होना पड़ेगा कि हम इन मिनरल्स का आउटपुट और रॉ मटेरियल नहीं, किसी को दे के वहाँ से फाइनल प्रोडक्ट लेके फिर हमारे यहाँ यूज़ करने का करें, इसमें हमारी एक्सपोर्ट ड्यूटी लगी, इंपोर्ट ड्यूटी लगी, उनका प्रॉफिट जोड़ के हमारे पास वापस वो प्रोडक्ट आ रहा है। तो इन चीज़ों से बचने के लिए जो पिछले 10-11 साल में आपने काम किया है और सरकार इन चीज़ों पे अगर काम करेगी तो मुझे लगता है कि हम अगली बार प्रोडक्ट घूम के हमारे लिए फिनिश गुड्स बन के नहीं आएगा, इसी देश में जो हम जिस टेक्नोलॉजी के साथ आगे बढ़ रहे हैं प्रोडक्ट बन के हमारे सामने आना चाहिए। इन चीज़ों पे सरकार को आपकी तरफ से जो सुझाव जाएंगे या बाकी जो अलग एजेंसियां काम कर रही हैं वो सब चीज़ काम करेंगी। और वास्तव में जो भारतीय ज्ञान परंपरा की अगर बात है, मैंने कैसे गहराई तक जाते हैं, कैसे काम करते हैं, बैठे बैठे मैंने सर से बहुत सारी चीज़ सीखी है और सुना है, उनके बारे में जानकारी ली और कैसे काम हो रहा है, इन कामों में हमारे लोग क्या कर रहे हैं और 10 साल के काम और पिछले 65 साल के कामों का अंतर दिख रहा है। और अगर 10 साल के काम और 65 साल के कामों का अंतर दिख रहा है तो 2025 में हम अभी हैं, 22 साल बाद हम 2047 में विकसित भारत और आत्मनिर्भर भारत की बात करें तो मुझे लगता है, और मैंने कई मेरे भाषणों में कहा है कि हम 2047 का टारगेट रखे हुए हैं, लेकिन जिस स्पीड से आगे बढ़ रहे हैं उस स्पीड से मुझे लगता है कि 2047 के पहले ही हम विकसित हो जाएंगे। और आज अगर आप देखते हैं आज के पेपर का फ्रंट पेज तो ऐसा लगता है कि कई बार आज भास्कर में लेफ्ट हैंड पे कॉर्नर पे आज के सुविचार लिखा है और उसको अगर ट्रम्प की न्यूज़ के साथ आप मैच करेंगे कि कई बार तूफान ऐसी जगह ले जाके आपको छोड़ता है जहां पर आप जाना चाहते थे। तो मुझे लगता है कि ट्रम्प हमको ऐसी जगह ले जाना चाह रहे हैं जहां हम नहीं जा पा रहे थे और अब हमको लगेगा कि आप हमारे ऊपर इस तरह के चीज़ें लगा रहे हैं तो हम ठीक है, हम स्वदेशी की बात करेंगे और हम आत्मनिर्भर भारत की बात करेंगे और 2047 तो बहुत दूर की बात है, हम उसके पहले विकसित राष्ट्र होकर बताएंगे। और आपने ये 2 दिन का जो कॉन्फ्रेंस है इसमें जो सब लोगों के प्रेजेंटेशन होंगे और उस प्रेजेंटेशन के साथ 2 दिन में बहुत अच्छी चीज़ निकल के आएंगे जो देश के लिए और विकसित भारत जो 2047 का हम सपना देखे हुए हैं तो उसके लिए बहुत काम आएंगे। तो आयोजकों को बहुत बहुत धन्यवाद और मुझे बुलाया इसके लिए आभार। जय हिंद, जय भारत।
बहुत बहुत धन्यवाद सर, आपके शब्द हमारे लिए काफ़ी प्रेरणादायी हैं। अब मैं श्री दीपक हाजरा उप महानिदेशक नेशनल मिशन 2 से अनुरोध करती हूं कि वह यहां मंच पर आएं और धन्यवाद ज्ञापन प्रस्तुत करें।
थैंक यू मैडम। आप सभी को मेरा नमस्कार। एस्टीम्ड चीफ गेस्ट प्रोफेसर राजेश कुमार वर्मा जी, वाइस चांसलर रानी दुर्गावती विश्वविद्यालय, डिस्टिंग्विश्ड गेस्ट ऑफ ऑनर श्री धीरज पांडे जी, डायरेक्टर AMD श्री इंद्रदेव नारायण जी, CMD MECL, respected Director General Geological Survey of India Shri Ashit Shah ji, respected Shri D.V. Ganvir ji, Additional Director General and HOD Central Region, National Mission Head 2, distinguished and eminent professionals from the geoscience fraternity, from industry and academia, officials from central and state government, invited speakers, ladies and gentlemen, very good morning to all of you. It is indeed a great privilege and honor for me to propose the vote of thanks on this momentous occasion. Today marks not just the beginning of a significant dialogue, but a collaborative step forward in shaping the future of mineral exploration, particularly in the domain of critical minerals and strategic resource security in our country. First and foremost, we extend our deepest gratitude to our esteemed chief guest, Professor Rajesh Kumar Verma-ji, Vice Chancellor, Rani Durgavati Vishwavidyalaya, for graciously inaugurating the ceremony, this conference. Sir, your simplicity and insights on critical minerals have set an inspiring tone for the sessions to follow. We are deeply honored by your valued presence and sincerely thank you for sharing your visions with us. We are delighted and honored to have the inspiring presence of renowned scientist Sri Dheeraj Pandeyji, Director AMD, Sri Indradev Narayanji, CMD MECL. Gentlemen, your participation has elevated the conference, underscores relevance of this event, and emphasizes importance and the strength of interinstitutional collaboration. We thank you for your valued presence and sharing your thoughts with us. We extend our sincere gratitude to Sri Ashit Sahaji, Director General, Geological Survey of India, and the patron of this conference. Sir, your visionary leadership and enduring support have been the cornerstone of this national conference. Your commitment to India's self-reliance in critical minerals, introduction of cutting-edge technologies in mineral exploration and geoscientific research, and your unwavering dedication to institutional excellence continue to inspire the entire geoscience community. Next, we convey our heartfelt thanks to Sri Dinesh Vittal Rao Ganbirji, Additional Director General and HOD Central Region and National Mission Head 2. Sir, your pivotal role in organizing this conference will always be remembered. Your inspiring leadership, vision, and guidance have shaped this conference to its finality. We remain truly grateful for your support and patronage. A special thanks to all the retired GSI luminaries who are present here, to all the eminent speakers from academia and industries, and our enthusiastic participants from across the academia, industry, and government for their valued participations in this conference. This conference would not have been possible without the hard work and support of our organizing committee, technical partners, supporting staffs. Our sincere appreciation goes to our dear colleague, Dr. S.R. Basi, Deputy Director General, National Mission Head 2, and his dedicated team for their relentless effort and meticulous planning. As we proceed through the coming sessions, let us carry forward the spirit of today's discussion into meaningful action. We look forward to fruitful deliberations and lasting partnership that will emerge from this platform. Once again, we thank each and every one of you for your participation, support, and shared commitment to this national initiative. Jai Hind.
Thank you, sir. As we conclude this inaugural session, ladies and gentlemen, may I now request everyone to kindly rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मागे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Thank you, everyone. You can now take your seats. I now request our esteemed dignitaries on the dais to kindly move to the stall gallery for the inauguration of the GSI stall. Attention to all the presenters. I request you to kindly submit your presentations to the organizing committee as soon as possible. I also request our esteemed guests present here to kindly proceed for the high tea on the right hand side of the gallery. Thank you. Attention please. Our next session will commence at 11:30 a.m. So I request all of you to please come back and take your seats at 11:30. Thank you. Sorry, I request all of you to please come back here at 12:15 sharp. Our next session, technical session, will commence henceforth.
कहाँ पे लगानी है? हेलो हेलो
I request all the delegates to kindly reassemble in the conference hall and occupy their respective seats. We are about to begin the technical sessions shortly. Ladies and gentlemen, I hope you had a refreshing break. Now I request you to please kindly be seated so that we can begin our first technical session. A very good afternoon to one and all, and a warm welcome to all of you to this national conference on critical minerals, exploration and exploitation, hosted by the Geological Survey of India at Jabalpur, Madhya Pradesh. We are truly honored to have each one of you with us here. Let us now give you a brief overview of the technical sessions. Today we shall be covering 3 technical sessions. Technical session 1 on critical minerals in the Indian scenario, present status, future prospects and policy amendments. Technical session 2 on geological framework conducive to host critical mineral deposits with focus on mineral system models. Technical session 3, it will be on geophysical exploration strategies employed for various deposit types. We are excited to host 17 expert speakers including 3 keynote addresses. The time allotted for keynote address is 20 minutes and the time allotted for each presentation is 10 minutes, which shall be followed by a panel discussion and question answer session of 5 minutes. I request all the speakers to kindly adhere to the allotted time. This will help us ensure the smooth running of the sessions. Let's now begin with the first technical session. With due respect, I invite on dais Shri P.B. Sarolkar, retired Deputy Director General GSI, to chair the session. With a big round of applause, ladies and gentlemen, please welcome our first chairman. Sir is a seasoned geoscientist with over 35 years at the Geological Survey of India, has led mineral and coal exploration across Eastern Ghats and Godavari Valley, and later directed major geotechnical and geothermal projects across India. Sir has played a key role in geothermal energy research, policy and development with MNRE, ONGC and CSRI NGRI. Sir has published and presented extensively in national and international forums and served as expert reviewer, editor and technical advisor in energy and geoscience sector. We welcome you, sir. To co-chair this session, we are honored to welcome on the dais Shri R.L. Sarkar, Deputy Director General and Regional Mission Head to GSI NER. Shri Sarkar is a senior geoscientist currently serving as Deputy Director General in the Geological Survey of India, Northeastern Region, Shillong. He joined GSI in January 2001 and has held key positions across various regions, including Central Headquarters, Eastern Region and Northeastern Region. He holds an MSc in Geology from Jadavpur University and has over 2 decades of experience in geological mapping, exploration, planning, and mission monitoring. Mr. Sarkar has contributed significantly to the limestone exploration in Meghalaya and has also served in strategic planning and parliamentary affairs at GSI's Central Secretariat. We also welcome you, sir. Now it's time to hear from our keynote speaker. So, the keynote speaker for today's first technical session is none other than Shri Dinesh Ganveer, Additional Director General and HOD GSI Central Region, and also the Head National Mission 2. The sir will be delivering his address on GSI's role in policy reforms and contribution in exploration and resource augmentation towards critical minerals. Sir has had an illustrious career since joining GSI in 1994. With expertise in mineral exploration, engineering, geology, and heritage site conservation, he has led major national programs including over 400 plus exploration projects and played a key role in India's critical mineral auctioning regime. Sir's techno-administrative leadership spans across field execution, finance, offshore mining, and international representation, with significant contributions to the preservation of UNESCO sites and geotechnical advancements in GSA. Please join me in welcoming Ganveer sir with a big round of applause.
Thank you, madam. my keynote address will be focused on the policy reforms and contribution in exploration and resource augmentation towards critical minerals. The accelerating global transition towards renewable energy technologies, electric vehicles, and cutting-edge electronics has created. Please hold the presentation, because after keynote address, my presentation is there. So please hold the presentation. And cutting-edge electronics has created unprecedented demand for critical minerals, thereby posing complex strategic and economic challenges. These challenges simultaneously present remarkable opportunities to calibrate exploration and mining policies. Recognizing this strategic importance, the Ministry of Mines, Government of India has implemented a series of impactful reforms in one last decade to revitalize the exploration and mining ecosystem in the country. These reforms are not just amendments to regulations, they are strong statements of intent, a move towards greater transparency, sustainability, and self-sufficiency. As we know, the mining sector, the mineral sector, it is governed by the MMDR Act. The MMDR Act, which was the biggest turning point in 2015, which has amendment in MMDR Act, where the first come first serve allocation of mining leases, that was amended, and it was the transparency in auction that was brought in that amendment. Not only the auctioning of the blocks, the transparency, but the mineral auction rules 2015, they were also amended. In my presentation in the policy reforms, I'll brief about the mineral auction rules right from 2015, 2017, 2020, 2021, how the reforms had been carried out in auction rules. The next amendment, this is the policy amendment in 2021. This amendment again has to allow for composite license, a progressive step that combined the prospecting license and with the mining lease. Auctions at the G4 and G3 stages of exploration were introduced to bring in greater private participation. After the amendment in 2015, the Act, GSI in phase manner during mining conclaves till date, and after the amendment 2021 to auction the as a composite license 650 blocks till date. After this amendment in phase-wise manner, Geological Survey of India has handed over to the state governments through Ministry of Mines. These reforms not only stopped here. In 2023, Government of India, Ministry of Mines had amended and identified 30 critical minerals. 30 critical minerals, and another amendment where the exploration license blocks, that amendment has been introduced. And with the amendment, identification of critical mineral blocks, GSI had given 161 critical mineral blocks after this amendment, which has put it in auction tranche-wise. You can see a brief details in my presentation. And introduction of exploration license, that has a task given to GSI, where GSI had handed over 34 exploration license blocks. With the glorious services contribution of GSI since last 175 years, we do have a strong data repository, the baseline geoscience data, which are catering to take up the projects apart from critical minerals in bauxite, limestone, iron ore. That is the baseline data which we are using to formulate the programs. And I would like to say that this last 5 years, if we see towards the critical minerals, in 2021, the figure was 65. 65 were the critical minerals investigations, but in 2025, we are having 227 projects we had focused towards critical minerals. If I tell about the last 5 years data, the projects, what mineral exploration projects, what GSI is taking, it was around 150 projects. I'm not talking about the critical minerals, I'm talking about the projects, the lead which GSI is taking. But in 2025, there are almost 449 projects in which critical minerals had taken a lead. Almost 200 projects we are taking right now as a critical minerals. The critical minerals, as we know, the graphite, the vanadium, tungsten, Re potash, the 24 identified critical minerals for which GSI is thrusting hard to take these projects and giving the blocks every year as per the commitment, taking up the investigations, and every mining conclave, not only the critical mineral blocks, for the other commodity also. It is not only to the land, not only to the onshore, but Geological Survey of India is also carrying out its exploration activities in offshore also. Last 40-45 years, GSI is carrying out these offshore activities, not only the territorial waters, but the EEZ also. The 12 nautical miles and the 200 nautical miles, that is the EEZ. The bathymetric surveys, other investigations, out of which GSI till date had handed over 35 offshore mineral blocks. But prior to that, Government of India, Ministry of Mines had taken a call, and the Offshore Act 2002 and the Auction Rules 2006, which has been amended, and the base to go for auctioning of these blocks. These, out of these 35 critical mineral blocks, where the 16 mineral blocks of heavies pertains to the states of Kerala, Tamil Nadu, Andhra Pradesh and Odisha. We do have the 9 mineral blocks of construction grade sand offshore of Kerala, 3 mineral blocks for lime mud, and 7 mineral blocks for polymetallic nodules and crust in offshore. So this is the contribution of GSI on onshore as well as offshore. Building upon these strategic reforms and tangible outcomes, GSI remains at the forefront of advancing its mineral exploration techniques by integrating its traditional approaches with next generation geophysical techniques, DSRS surveys, aeromagnetic through airborne, gravity magnetic through drones, for creation of high resolution 3D surface models. In parallel, GSI is incorporating artificial intelligence and machine learning algorithms to analyze vast volumes of baseline geoscience data which we are having, for targeting the deep-seated and concealed deposits through collaboration with international organizations like USGS. In particular, GSI is undertaking mineral system studies in collaboration with Geoscience Australia to develop a deeper understanding of ore forming processes in diverse geological settings in the country. These initiatives by GSI signify a paradigm shift in India's mineral exploration strategy in securing the country's critical and strategic mineral future. Thank you. Caller mic.
Thank you very much, sir, for that insightful keynote address. Now I request you to present a talk on auction policies and reforms in mineral exploration.
So, after the keynote address, continuing with my presentation on auction policies and reforms in mineral exploration. As I had told, the policy reforms, the amendment in MMDR Act 1957, if you see 2015, with the amendment, National Mineral Exploration Trust was formed, the DMF was formed, the amendment in Mineral Auction Rules 2015. It was an end to the old system of allocating mining lease on a first come, first served basis. Then in 17, there was an amendment in MMDR Act where the auction rules were amended. And regarding the value of estimated resources, the upfront payments and other things, I'll be sharing with you in the next slides. Again in 2020, there was an amendment in auction rule. Regarding the amendment in auction rules right from 2015, 17, 20, 21, I do have a presentation in the next slides where you can see what was the need, how it was amended. This is what I told in 2015 in the amendment of in the MMDR Act. The DMF was formed. And so far in 626 districts in 23 states in the country, DMF has been formed. Coming to 2021, in this amendment, composite license PL-ML that was amended, and based on that, Geological Survey of India till date had handed over more than 300 geological memorandums put up for auction through various state governments, through Ministry of Mines. After that, there was an amendment in 2023 where Ministry of Mines, Government of India had identified 30 critical minerals, and after identification had put up the critical mineral blocks for auction frontier-wise. Not only the identification of critical mineral blocks, putting it for auction, but the exploration license for deep-seated and critical minerals, that amendment also introduced. Based on this amendment, Geological Survey of India had handed over 34 exploration license blocks, out of which in first tranche 13 EL blocks had been put up for auction. Amendment in 2024, that is to implement the provision of EL. This is what, just in one go, how the amendment from 2015 to 2024, Ministry of Mines, Government of India, the need of the industry to need for auctioning of blocks, these amendments in auction rules and provisions were made. Now coming to the auction rules right from 2015 up to 21, I will be presenting, and these are the key features: the value of estimated resource, the value of mineral dispatched, the sale price, reserve price, auction prerequisites, bidding process, upfront payment, performance security, and mine development and production agreement. For us, in Geological Survey of India, we do take up the investigation exploration projects to explore and identify the resources. But after identification of resources, putting up these blocks for auction, during auctioning process, the rules, the act which governs, these are the auction rules, where these are the key features. Now coming to the mineral auction rule of 2015. You can see the amendment, what was the need for each and every left-hand column you see. The execution of mining lease, it shall be executed within 30 days. That was there. Upfront payment, it is 0.5% of the value of estimated resource, but in 3 installments, 10%, 10%, and 80%. But if you see in the relinquish the entire area, there you have to pay 10% of upfront payment. That is a clause. After completion of prospecting operations and apply of ML with first installment, that upfront payment of 10% you have to pay. Then for the period of execution of composite license, the preferred bidder has to submit the performance security, that is 0.25% of the value of estimated resource. Now during auction, the bidder, it needs to have net worth. The net worth for mining lease and the composite license, it is separate. If you see the VER, it is more than 25 crores, it is 4%. It is less than 25 crores, it is 2%. For CL, it is 1%. In the bidding process, under Rule 9, you see, if technically qualified bidders is less than 3, the blocks gets annulled. This is there. I'll give the comparison also. At one go, it will be difficult to understand. Now coming to the amendment in 2017 in the auction rules. This is all about the auction rules. Execution of mining lease, there it was a period of 30 days. Now you see, no mining lease shall be executed on expiry period of 3 years from the date of letter of intent, LOI. And 2 years relaxation period may be granted by the state government. There we are having the 30 days. Here that 30 days is not there, but the expiry period of 3 years is recorded. Upfront payment, period of execution, relinquish of area, there was no amendment. But coming to the net worth, if you see the net worth, now there was more than 25 crores, less than 25 crores. Here if you see, it is more than 1 crore, it is 2%, less than 1 crore, it is 1%. There it was more than 25 crores, 4%, less than 25 crores, this was 2%. You see the variation. And for composite license, it is more than 100 crores, 1%, less than 100 crores, it is 0.5%, that should be the net worth of the bidder. In bidding process, under Rule 9, you see on annulment of first attempt of auction, the state government will conduct the second attempt of auction. It is there. It was annulled. If 3 bidders are not there, earlier it was getting annulled. Coming to the amendment in 2020, the execution of mining lease, that is the only amendment. Here you see, earlier it was 30 days period, then it was a 3 years period. Now here you see the mining lease auctioned shall be executed within 15 days of the date of LOI. Earlier it was 30, then 3 years. Here the restriction is of 15 days. And with the another 15 days with the approval of state government. That is 30 days. But here the conditions are there. If the holder of the LOI failed to comply to execute the ML within 15 days, then it is going to be revoked, and performance security and upfront payment. The upfront payment, that is 0.5% into installments, that is 60, and the performance security 0.25% of the value of estimated resource, that is to be forfeited, and such preferred or successful bidder may be debarred by the state government for participating in future. Coming to the amendment in 2021, there is no amendment in execution of mining lease, but the upfront payment, the 0.5% of the value of estimated resource, you see now it is 20-20-60. There was 10-10-80, now it is 20-20-60. And this upfront payment, it is correlated with the relinquishment of the area where we have to pay the first installment. Again, the period of execution of CL, the performance security, what I told, 0.25% within 15 days, another 15 days they are getting. We come to the net worth. Now you see, earlier it was more than 25 crores, less than 25 crores, then it was restricted to 1, 2 and 1%, earlier it was 4 and 2%, then 1% for CL. In the next amendment, it was for ML it was 2%, 1%, 0.5% for CL. Here if you see, there is no debar in the percentage, but the higher limit is given for the net worth. For ML, it is should not exceed 200 crores. But for CL, it is 100 crores. In bidding process, there is no amendment. This already had covered in the G4 level, that is in 2021, that amendment was there, and based on that, the G4 level investigations and the geological memorandums are supposed to be put up for auction. And this is the power of the central government for auctioning of the mining lease, where the state government has time to time submit all the details to the central government, and if the central government deemed fit, may conduct auction of such terminated mining lease or lapse mines. This is regarding the composite license, where the central government is empowered to auction them lease. What separately the amendment in auction rules right from 2015 up to 21, I'd put it here. We'll come to the average sale price. If you see the next one, the average sale price. The average sale price per metric ton of such mineral as published by IBM for the relevant state for the period of 12 months immediately preceding the month of computation of the value of estimated resource. It was in 2015. But in 2017 it was amended. If the average sale price in the respect of relevant state is not published, then all India ASP published by IBM shall be considered. In 2020 there is no amendment, but if we come in 2021, both these amendments are put it here. The bidding process. What I told, if there are no technically qualified 3 bidders, you see the first one, the auction process gets annulled. But in the amendment in 2017, on annulment of first attempt of auction, the state government will conduct the second attempt. Conduct of auction by mining lease by central government, I had already told. Upfront payment, if you see the upfront payment, it is 0.5% of the value of estimated resource and it is 1080. Whereas if you see, there is no amendment, but in the 2021, if you see the amendment, it is 20-20-60. And already what I told, this upfront payment is related with the relinquish of the area, where after payment of first installment, the bidder can move for the mining lease. Conduct of auction by composite license. Again, the central government is empowered for performance security. Net worth. Net worth I had already briefed about. The VER 4%, less than 20, more than 25 crores, less than 25 crores at 2%. We can see the comparison how the amendment has moved. There were the limits about the in crores and the percentage to the net worth. First one, second one, and here if you see, it is having the upper limit, 200 crores or the 100 crores for ML and CL. These amendments had led, right, in 2023 and 24, the introduction of identification of critical minerals, where Government of India, Ministry of Mines had identified 30 critical minerals. In 2023, 6 minerals, lithium, beryllium, titanium, niobium, tantalum and zirconium were removed from the list of atomic minerals. Then introduction to the exploration license scheme for deep-seated critical minerals, and the exercise of power for relaxation of maximum area limits in respect of critical minerals. That is area of PL 100 square kilometer and area for ML, that is 50 square kilometer. Coming to the critical mineral demand. As we know, it is a need, the critical minerals, electronic industry, the defense, everywhere. We do need the critical minerals. Where? These are the requirements, the need. In the left hand corner, if you see the need of these critical minerals, lithium, copper, cobalt, nickel, chromium, etc. And most important, if you see, this is the database of unlocking Australia-India critical minerals partnership potential by Australian Trade and Investment Commission. The dependency, you see at the left hand corner the critical minerals and the dependency, the import we go, the India import. And these are the countries from which we import these critical minerals. Identification of critical minerals. It was not like that India was not having the critical minerals. There were several agencies including CSEP, CTEMPO, CEE, CEW. They had identified right from 2012 to 2022 different critical minerals, but for India as such we were not having the critical minerals. Government of India, Ministry of Mines had taken a call in 2021, 22 rather, identification of critical minerals, where committees were constituted and the methodologies which was adopted, it was the interministerial consultations with the different ministries. In the right corner you can see the comparative study of the global critical minerals which the US, Australia, other countries, what methodologies they had identified in identifying the critical minerals for their countries. It depends upon the import of the critical minerals as well as the export, the dependency. Here, the committee has also taken a call we were having the NMI database of Indian Bureau of Mines, where we were having the import and export data. Import and export data that represents the resources we are having, the reserves which we are having towards the critical minerals. And where is the need for India as such? Which are the critical minerals which we are depending upon and importing? That was also one of the major contribution of NMI database. August 2023, these were the 24 critical minerals notified by Ministry of Mines, Government of India. What I told the USA, we had studied the global also, how they had identified the critical minerals for their countries. And you see, it was based upon the disruption potential for US and the economic vulnerability. For US, they had taken a call, and 50 minerals for USA they had identified as a critical minerals. But they are not forever. Every country does identify their critical minerals, but every 3 years they will be revisiting the requirement, the need, the import and the export of these critical minerals. This is about the Australia, and these are the 2 factors essential for functioning modern technologies, economies and national security. That was one factor. And other factor, risk that its supply chains could be disrupted. So almost 23 critical minerals Australia has identified for their country. UK, it was based on the global supply risk and UK economic vulnerability. 18 elements were identified by UK. This was the global scenario. Now coming to the Indian scenario. What I told earlier, if you see right from 2012 to 2022, we were having the identified critical mineral by C-Tempo, CEW, CE, CSEP, then IDSA, defense also. That does identify the critical minerals, but for India as a whole, the list of critical minerals, there was a need. And if you see these 4 agencies, they had identified the critical minerals. You can see the data source, the modules which they had identified, and the analysis. The data source is USGS, IBM, Planning Commission. Modules, if you see the European commercial module they had used, and in the analysis you can see the various projections, including the Porter force analysis and Likert scale analysis by IDSA for identifying these critical minerals. All these reports were studied in detail, available reports within India and the global studies also. The interministerial interactions and the 24 critical minerals which were identified, and the contribution from Geological Survey of India. In the next slides, I'll put it before you. And the exploration license, which was introduced again in 2023, where it is a full range of exploration, where reconnaissance operations and prospecting operations or both can be carried out. The exploration license, this is restricted to this 7th schedule, the 29 mineral commodities. Whereas for the critical minerals, we do have the 24 critical minerals, they are overlapping. Now, just a comparison between the amendment in 2021 and 23, but that liberty is given in exploration license. Regarding area for prospecting license and mining lease, for prospecting license it was 25 square kilometer, reconnaissance permit 10,000 square kilometer. But here it is in total 5,000 square kilometers, But in a single exploration license, it is restricted to 1,000 square kilometer. These are the area restrictions. Then coming to the extension, it is 3+2 at both the side. 1 year is in the left part. If you see in the amendment 2021, it is a renewal. Here it is extension. Now the impact of this policy amendment, right from 2015 to 24, GSI has taken a call, and what I told earlier, the number of blocks which GSI had identified in the phase manner, right from phase 1 onwards in the mining conclaves, till date, you see the G2 and G3 reports for the certain commodities from zinc to andalusite. You can see we had handed over 307, and if you see Madhya Pradesh, it will come later. These are the commodities. Regarding the geological memorandums in the amendment 2021, where G4 and G3 level was supposed to put up for auction, GSI has handed over 343 geological memorandums, and these are the commodities from vanadium to andalusite. And the number of geological memorandums, you can see max 46 for gold. Another 5 minutes. Coming to the critical minerals, the thrust which GSI has given in taking up the programs, you see in 2021 it was 63, now it is raised up to 227. This is the thrust by Geological Survey of India taking up the critical mineral programs, the investigations. Till date, what I had told, it is 161 total blocks which we had handed over for auction, the critical mineral blocks. Here the reports are 83 for critical minerals, and the geological memorandums, they are 78. You can see the commodities and the states. Madhya Pradesh, 19 geological memorandums had given, as well as if you come to reports, they are 7 in number. 7 and 19, Madhya Pradesh contribution is 26. The blocks given for auction. These are the tranches. The Joint Secretary Designated Officer, Ministry of Mines, who is empowered with the auctioning. And tranche wise, right from tranche 1 to tranche 5, these blocks are put up for auction. In auctioning process, MSTC, SBI CAPS, MECL, and GSI, they do contribute from Geological Survey of India, the technical part in our blocks, whatever the technical content is to be revisited or explained during the road shows or the pre-bid meetings, we do take care at the NMS2 office level. These are the blocks of G2, G3, which had been put up for auction, the commodities. These are the 16 number which had been successfully auctioned till date. Total, if I see the figure, 54 put up for auction. After that, 28 are auctioned. In 28, if you see the reports, 16 are auctioned. These are the 12, the geological memorandums, which had been auctioned, successfully auctioned. And you can see the commodities also, the critical mineral commodities, which has been successfully auctioned. This is the total 28, what I told earlier. Coming to Madhya Pradesh, now I think the media and other people of Madhya Pradesh, they can see in the Madhya Pradesh map the commodities where you can identify glauconite, graphite, molybdenum, nickel, where are the projects we had taken, and you see these 7 geological reports which we had handed over, and these are the 19 for these commodities: glauconite, graphite, potash. These are the reports. These are the occurrences within Madhya Pradesh, and these are the total 19 geological memorandums for graphite, molybdenum, nickel, phosphorate, and PG, which has been handed over, and out of which 7 has been successfully auctioned. So coming to the reports, this is Golighat, a G2 ML, Bahera Goriara graphite G3, Surajpura for phosphorite again G4, and Khatali Choti graphite G4. You can see with the resource estimated, and these are the reports successfully auctioned of Madhya Pradesh. Coming to the exploration license, already I told 34 critical exploration license blocks which had been handed over by Geological Survey of India, and in tranche 1, 13 had been launched for auction, and what I had come to know, our response is excellent. So with that, I conclude my talk. Thank you. Thank you all. निकाल दे।
Okay. Thank you very much, sir, for this elaborative and very informative presentation. It's time to felicitate our distinguished speaker, and I request Shri P.B. Sarolkar, sir, chairman of this session, to do the honors. And I again invite Ganvi, sir, for this on the dais. थोड़ा सेंटर में हो जाएगा। Thank you very much, sirs. Let us now move forward with the technical session. Now I would like to invite Ms. Kankana, geologist GSI, to the dais to deliver the next presentation on international collaborations and strategic alliances, a pathway to critical mineral security. Ms. Kankana, please.
Hello. Honorable dignitaries, respected delegates, dear colleagues and friends, Namaskar and good afternoon. It is a privilege to present on the growing national and international matter India's strategic pathway to achieving the critical mineral supply chain. For India, its ambitious development trajectory and clean energy transition goals requires a secure and stable supply of critical minerals, without which there'll be disruptions in the supply. The presentation highlights a comprehensive outline of how India is moving towards achieving this goal by international collaborations, global partnerships, bilateral engagements, as well as domestic initiatives. India is projected to become the third largest economy and aims to meet 50% of its energy requirements from the renewable resources by 2030. Also, on the long-term achievements, we are set to reaching the net zero emission by 2070. To achieve this, a secure and stable supply of critical minerals is indispensable. Without that, our clean energy transition goal and digital growth could face severe bottlenecks. Now, what are critical minerals? A mineral is labeled as critical when the supply chain risk and the associated impact in the economy is relatively at a higher risk compared to other raw materials. Now, this risk factor actually attracts import dependency, recycling concerns, and also substitutability for other minerals. Out of the 30 critical minerals identified, 24 critical minerals are included in the list of critical and strategic minerals in the MMDR Act. Now, these critical minerals are essential for emerging technologies, electric vehicles, renewable energy infrastructure, semiconductors, and advanced defense systems. Minerals like lithium, cobalt, nickel, rare earth elements, and various others, and graphite as integral part to the batteries, solar panels, and electronics. And hence, these are very important. Now, speaking of the risk factors, India currently imports nearly all of its critical minerals. Now, this poses a vulnerability to the global market fluctuations, to the supply chain disruptions, and geopolitical risks. Countries like China dominate the processing and the recycling and the export factors of several critical minerals. That actually raises concerns on the overdependence. To overcome this and reduce the import dependency, securing the supply of critical minerals is not only a matter of energy security, but is actually a matter of national security as well. A stable and diversified critical mineral supply chain is very central to achieving what we say is Atmanirbhar Bharat, or self-reliant India. The table here is a report based on the International Energy Agency, a Paris Autonomous Intergovernmental Organization, a report of 2024, which actually says that the minerals which are exposed to geopolitical risks, and out of which we can see graphite, nickel, cobalt, rare earths, lithium, copper, the minerals which are essential for the electric manufacturing industry, the batteries, and defense systems as well. Now, the government of India has proactively responded to these challenges. India, the Ministry of Mines is engaged in several multilateral platforms, is engaged in several bilateral strategic platforms, and also is into a lot of bilateral memorandum of understandings for arranging and securing this global supply of critical minerals. I'm now going to highlight the multilateral strategies and the multilateral forums in which India is a part. Firstly, comes the Mineral Security Partnership. A US-led initiative, the Mineral Security Partnership is a collaboration of 14 countries and the EU for investment responsible critical mineral supply chain. India became a part of the Mineral Security Partnership in the year 2023. And the principles The principles lie under around 4 pillars. We have information sharing and cooperation to build transparency in supply chain. We have investment mobilization for critical mineral assets. And we have upholding the environmental, social, and governance standards in ensuring the minerals as sourcing responsibility. Mineral Security Partnership is completely like, it's going to adhere rigorously to these ESG standards. Now, through this Mineral Security Partnership, India gains to access to the critical knowledge, investment flows, and aligned standards, making it a milestone in our mineral diplomacy. Moving to the next slide, it is about Indo-Pacific economic framework for prosperity. This again comprises of the 14 countries and is based on 4 pillars. The number 1 comes trade, then comes supply chain, we have clean economy, and then we have fair economy. India is a part of 3 pillars, pillar 2, 3, and 4. For the trade pillar, India is acting as an observer because of its own regulations and all. For in the supply chains pillar, India will be focusing on how to secure the supply chains. In the fair economy pillar, it is about having anti-corruption, having tax redemptions and all. Now, this Indo-Pacific framework promotes regional cooperation in building secure and transparent supply chain. Talking about the quadrilateral security dialogue, the member countries are India, USA, Australia, and Japan. The Quad countries, as you can see, it actually forms a quadrilateral figure. This Quad is all about having an inclusive supply of critical minerals. It was launched initially in 2007 and often termed as the Asian NATO, but then it's an informal strategic forum to address to the needs in the maritime security across the entire Indo-Pacific region. We are now going to come to the bilateral strategic engagements. This bilateral strategic engagement, it was launched in February 2025 and is a part of the Trust Initiative between India and USA. This initiative not only facilitates technology transfer, but also deepens industrial collaborations. It complements the broader strategy effort by anchoring the mineral strategy with larger tech diplomacy framework between the 2 nations. Under the trust is the SMRI, Securing Strategic Mineral Recovery Initiative. In this SMRI, we have progressed, and Ministry of Mines is in talking terms with the US agencies to finalize certain projects. Given the bilateral strategic cooperations and the multilateral strategic cooperations, the Ministry of Mines is also engaged in having the Memorandum of Understandings, that is the government-to-government or business-to-business engagements with the resource-rich countries or the countries which are rich in technology. The common areas of cooperation includes allocation of mineral blocks. It includes cooperation in the field of critical minerals and rare earth minerals, and exchange of knowledge and technology transfer. the R&D projects, and also capacity building between the countries. Talking about the domestic initiative, the launch of National Critical Mineral Mission is towards securing India's critical mineral supply chain by ensuring the mineral availability from domestic and foreign sources. The National Critical Mineral Mission has several components which are the domestic, which are going to focus on the domestic production. It's going to focus on the overseas acquisition of foreign assets and recycling. Then comes the trade, the research and development factor, the capacity building and skilling, upskilling, and also on the fiscal incentives. Apart from this strong momentum, which the government of India is having in securing the supply of critical minerals, there are several factors which are posing as the challenges, under which comes the geopolitical risks, including the resource nationalism and trade restrictions. That is, the concentrated supply of critical minerals increases the vulnerability and in acquiring them. Then comes the global competition in the limited mineral assets, which are confined to either a particular geographical domain or is being tried to confine to that. And also, amongst the challenges, we have compliance with global ESG standards, which require significant capacity building. And then we have financing and long lead times in exploration and development that poses economic hurdles. Addressing to these challenges require coordinated policy efforts, enhanced private sector participation, and international supports. The domestic processing and refining structure also remains underdeveloped as on date. But then again, the roadmap and to sustain its progress, India must strengthen its role in various national platforms, in various multilateral platforms, and then fully operationalize the NCMM and empower Kabul. We can also broaden the scope of National Mineral Exploration Trust to support the overseas projects, promote the research and development, and foster circular economy approach. To conclude, India's approach in securing critical mineral supply chain is a strategic blend of international collaborations, domestic initiatives, key establishments such as Khanij Videsh India Limited, the missions like National Critical Mineral Mission, which are groundwork, which lay the foundation of India's long-term resilience for this critical minerals. Now, and also I feel that this is not about just securing the critical minerals. It's about building green, reliant, and globally sustainable future. Thank you so much. Yes, sir. Sir, I can hear you and the entire hall can.
It's a very good presentation.
Thank you so much, sir.
And equally too by a young officer.
Sir.
And discussing about national security. I was very happy.
Sir.
But very sorry, I was looking for one slide. In
Yes,
your
sir.
presentation, that slide was missing. The slide was out of the 30 critical minerals, how many critical minerals can be produced, explored in India based on GSI efforts?
All right. Sir, I will try to incorporate that in my next presentation. Yes, thank you, sir.
Thank you.
Thank you.
Shall I give my comment? At the inaugural of this seminar and conference on critical minerals related all the matters, I am very that way impressed and happy that the initial two lectures, they have given the whole glimpse of the critical minerals, the rules, regulations, and the national and international scenario. Silence, please. The presentation by Sri Ganvir was a vivid presentation, giving the right from the beginning the definition, the necessity and the requirement of the critical minerals in India presently, then how various missions were formed, how committees were formed to identify the critical minerals, and how what is the present situation and present exploration activities taken by the GSI to identify the critical minerals, to have their resource potential, possible resource potential, and ultimate, we can say, exploration auction for the exploration and further development of these critical minerals. It was a very vivid step-by-step description, which I think even a layman can understand. This is very useful, particularly for the entrepreneurs or people who are not of this particular subject, to get information about this and get involvement in the sort of activity for further, we can say, mining lease or prospecting license, etc., if they are interested particularly in mining or exploration related activities. He has even dealt with some of the exploration activities which are required for these critical minerals. Then second most important aspect he has given is the requirement and changes which were adopted by the MMRD Act from 2015 onwards, in continuation of the present geopolitical, geo-economical, geographical and mineral sector situation. That is very useful because particularly this MMRD Act, there are so many changes are coming up. Even the persons related with this, like a geologist or some of the officers of IBM, and particularly I had some interaction with the mining people, they don't understand the exact implication of all these changes. He has very, very specifically given the changes, the outcome of it, and the utility of these changes to the, not only to the entrepreneur, but for the development of the sector, whether it's a mineral sector or whether it is a requirement of the development of the critical sector. So it is a very useful presentation, though actually personally I speak, his presentation should have been in the two different aspects. He has combined it to shorten the period, I think, but we shall certainly congratulate him for giving such a vivid, in-depth description regarding the mineral activities, auction, mineral rules, and present status of the critical minerals in India. So thank you, Ganvir Sahab. The second presentation is also useful. The second presentation by Ms. Kankana, geologist DGCO, it's related the policy decisions, we can say, and the present status of critical minerals. And we know the present status of critical minerals is really critical, particularly in India presently. But what are the other developments we are taking up for easing out the situation, including the, we can say, substitutes possible, then important dependence of the minerals. She has given good description of this. Then government policy regarding the import and of the critical minerals, and the multilateral discussions, multilateral MOUs form, and then in bilateral discussions, bilateral groups who are dealing with the solving the situation then Government of India's Mineral Security Partnership and its benefits, then Indo-Pacific Economic Forum, supply chain pricing and the geopolitical situation regarding the international critical mineral trade. She has very vividly and very clearly and very, I can say, simply described it. This is there as different MOUs with the bilateral countries we are going up, and the National Mineral Critical Mineral Mission also is taking up. It would be addition to her presentation and to our knowledge to give some more details regarding the availability of the critical minerals and the present import export, rather I can say import because there is no export as such, from the various countries, and their possibility of sustaining sustenance continuous availability. If that part is also added, her presentation will be excellent. Thank you very much for calling me here and giving me this opportunity to chair this session.
You had to cover something.
I'm very much thankful to the... Haan sir, boliye please.
Sarah is requested to say his session. So already Sarolkar sir has summed up the whole presentation, where the whole gamut of mineral exploration followed by mineral exploitation, the present reforms happened in the last 10 years was very vividly presented by Ganvi sir, which was followed by the India's initiative to boost the mineral exploration as well as acquisition from abroad. The different initiatives of the government have been presented by the Kangana very well. But in a nutshell, if I sum up the whole presentation to I can say that 2015 is a landmark in the field of mineral exploration and exploitation in the country India. Why? Because from that time, GSI has also a paradigm shift in their exploration strategy, where in addition to the initial PL and ML, GSI also started doing G2 level exploration, which has directly now qualifying for different mineral mining leases also. So with that, the boosting of exploration in more G3 and G2 level, you can see with a culmination of more than 300 reports which have been handed over, and out of which 54 are on the critical mineral, out of which 28 are auctioned. This is due to the amendment in different phases. Another landmark decision in the Indian field of mineral exploration was the introduction of CL, ML, and then by EL, but simultaneously the formation of National Mineral Exploration Trust, which now is boosting the domestic exploration to a more exponentially, because you can see more than 28 notified private agencies are also doing exploration in equal pace with the government and PSU organization, with an ultimate objective to reach our goal of set in the National Mineral Critical Mission, where we are supposed to complete more than 1,200 projects on critical mineral by 2030. And with this domestic effort, the international effort has also gone to a very high level with the recent initiatives of Ministry of Mines, where you can see our Kabil has also taken a very good initiative for the critical mineral outside our country. Even NMET is also boosting all the GSI as well as PSUs to take up foreign doing exploration in the foreign countries. And within this vibrant environment, all we are very much rejuvenated with the modern technologies. Now you can see there are a lot of hackathons are also where the new ideas from the researchers, from the academicians are also coming up. So with effort from all end, we think we will be able to reach our goal in near future. Thank you.
Thank you very much, sir, for chairing and co-chairing this technical session 1 and sharing the concluding remarks. With the successful completion of this enlightening technical session, it is now time to express our heartfelt gratitude. I request Shri Dinesh P. Ganvir, sir, ADG and HOD GSI Central Region and Chairman of this conference, to felicitate our esteemed speakers, Chairman and Co-Chairman for this insightful session. Sir, please. हाँ sir, उनका ही first. So, for the felicitation, I would like to invite on dais Ms. Kankana. Please join us on the dais. Ladies and gentlemen, a big round of applause for Ms. Kankana for her enlightening presentation, and we appreciate her valuable perspectives and the roadmap she has outlined for India's strategic engagement on the global stage. Shri R.L. Sarkar, sir, please. Thank you very much, sir, for being here with us today. Ladies and gentlemen, with a big round of applause, I invite on dais Ms. Kankana. Thank you, sir. Thank you, Kankana. Ladies and gentlemen, we have 2 more technical sessions lined up today. However, it's now time to break for lunch. We hope you enjoy your meal and take this time to relax and connect with fellow delegates and speakers. We request you to kindly rejoin us in the conference hall after lunch by 2:30 p.m. so that we can continue with the remaining sessions. Thank you.
Gwalior, city of legends, where history meets modernity. Known for its architectural grandeur and cultural richness, the city has now embraced a new dimension. A state-of-the-art GSI Geoscience Museum. Nestled in the heart of Gwalior, the GSI Geoscience Museum is a beacon of scientific curiosity and educational excellence. Developed by the Geological Survey of India, this museum is a testament to the organization's commitment to making geoscience accessible to all. The museum was inaugurated on 15th December 2024 by the Honorable Vice President Shri Jagdeep Dhankar. Honorable Minister of State Shri Satish Chandra Dubey issued the inaugural ticket, symbolizing the museum's new chapter with its visitors. With state-of-the-art facilities and interactive exhibits, the museum invites visitors to embark on a journey through Earth's rich geological history. This iconic project aims to make geoscience accessible, engaging, and inspiring for everyone. Welcome to the GSI Geoscience Museum. Witness the extraordinary phenomena that stimulates curiosity about historical narratives and evokes hope for the future. Here are two skillfully curated galleries, each providing a fresh insight into our planet. Gallery 1 showcases planet Earth, its uniqueness in diversity. A stunning gallery with 7 distinct themes featuring volcanic landscapes, celestial meteorites, and intricate geological structures. It displays meteorites that traveled through the cosmos. This gallery shines with rare Antarctic rocks as its treasures. The Gallery 2 presents evolution of life on Earth, showcasing ancient ecosystems and mass extinction while highlighting resilience. There's a nicely articulated section highlighting the extraordinary volcanic history, beautiful yet terrifying forces that have significantly altered Earth's landscape. We are now in the earthquake tremor zone, offering an interactive experience of seismic activity and Earth's dynamic qualities. Next, we enter the fossils section, showcasing the resilience and adaptability of life over billions of years, highlighting the evolution of species. In the marine section, we uncover the relationship between oceanic elements, geosciences, and technological developments. The GSI Geoscience Museum stands as a monument to knowledge and inspiration, unveiling the marvels of Earth in harmony with visitor aspirations. While we treasure the geological wonders of Earth, the museum serves as an essential reminder of our shared responsibility to nurture and preserve our home. This museum illustrates the vast history of Earth, showcasing the evolution from early land plants to mass extinctions, integrated with modern scientific knowledge. From the Jurassic era to the modern day and across oceanic and aerial landscapes, this museum is a vital monument for students and aspiring geologists. Highlighting the milestones of life's evolution on Earth, we are thrilled to create a monument that will continue to inspire future generations. Let's celebrate the blend of geoscience and aesthetic charm. Visit the GSI Geoscience Museum in Gwalior to discover the extraordinary story of Earth. The treasures of our planet await you. Gwalior, city of legends, where history meets modernity. Known for its architectural grandeur and cultural richness, the city has now embraced a new dimension. A state-of-the-art GSI Geoscience Museum. Nestled in the heart of Gwalior, the GSI Geoscience Museum is a beacon of scientific curiosity and educational excellence. Developed by the Geological Survey of India, this museum is a testament to the organization's commitment to making geoscience accessible to all. The museum was inaugurated on 15th December 2024 by the Honorable Vice President Shri Jagdeep Dhankar. Honorable Minister of State Shri Satish Chandra Dubey issued the inaugural ticket, symbolizing the museum's new chapter with its visitors. With state-of-the-art facilities and interactive exhibits, the museum invites visitors to embark on a journey through Earth's rich geological history. This iconic project aims to make geoscience accessible, engaging, and inspiring for everyone. Welcome to the GSI Geoscience Museum. Witness the extraordinary phenomena that stimulates curiosity about historical narratives and evokes hope for the future. Here are two skillfully curated galleries, each providing a fresh insight into our planet. Gallery 1 showcases planet Earth, its uniqueness in diversity. A stunning gallery with 7 distinct themes featuring volcanic landscapes, celestial meteorites, and intricate geological structures. It displays meteorites that traveled through the cosmos. This gallery shines with rare Antarctic rocks as its treasures. The gallery too presents evolution of life on Earth, showcasing ancient ecosystems and mass extinction while highlighting resilience. There's a nicely articulated section highlighting the extraordinary volcanic history, beautiful yet terrifying forces that have significantly altered Earth's landscape. We are now in the earthquake tremor zone, offering an interactive experience of seismic activity and Earth's dynamic qualities. Next, we enter the fossils section, showcasing the resilience and adaptability of life over billions of years, highlighting the evolution of species. In the marine section, we uncover the relationship between oceanic elements, geosciences, and technological developments. The GSI Geoscience Museum stands as a monument to knowledge and inspiration, unveiling the marvels of Earth in harmony with visitor aspirations. While we treasure the geological wonders of Earth, the museum serves as an essential reminder of our shared responsibility to nurture and preserve our home. This museum illustrates the vast history of Earth, showcasing the evolution from early land plants to mass extinctions, integrated with modern scientific knowledge. From the Jurassic era to the modern day and across oceanic and aerial landscapes, this museum is a vital monument for students and aspiring geologists. Highlighting the milestones of life's evolution on Earth, we are thrilled to create a monument that will continue to inspire future generations. Let's celebrate the blend of geoscience and aesthetic charm. Visit the GSI Geoscience Museum in Gwalior to discover the extraordinary story of Earth. The treasures of our planet await you. Gwalior, city of legends, where history meets modernity. Known for its architectural grandeur and cultural richness, the city has now embraced a new dimension. a state-of-the-art GSI Geoscience Museum. Nestled in the heart of Gwalior, the GSI Geoscience Museum is a beacon of scientific curiosity and educational excellence. Developed by the Geological Survey of India, this museum is a testament to the organization's commitment to making geoscience accessible to all. The museum was inaugurated on 15th December 2024 by the Honorable Vice President Shri Jagdeep Dhankar. Honorable Minister of State Shri Satish Chandra Dubey issued the inaugural ticket, symbolizing the museum's new chapter with its visitors. With state-of-the-art facilities and interactive exhibits, the museum invites visitors to embark on a journey through Earth's rich geological history. This iconic project aims to make geoscience accessible, engaging, and inspiring for everyone. Welcome to the GSI Geoscience Museum. Witness the extraordinary phenomena that stimulates curiosity about historical narratives and evokes hope for the future. Here are two skillfully curated galleries, each providing a fresh insight into our planet. Gallery 1 showcases planet Earth, its uniqueness in diversity. A stunning gallery with 7 distinct themes featuring volcanic landscapes, celestial meteorites, and intricate geological structures. It displays meteorites that traveled through the cosmos. This gallery shines with rare Antarctic rocks as its treasures. The Gallery 2 presents evolution of life on Earth, showcasing ancient ecosystems and mass extinction while highlighting resilience. There's a nicely articulated section highlighting the extraordinary volcanic history, beautiful yet terrifying forces that have significantly altered Earth's landscape. We are now in the earthquake tremor zone, offering an interactive experience of seismic activity and Earth's dynamic qualities. Next, we enter the fossils section, showcasing the resilience and adaptability of life over billions of years, highlighting the evolution of species. In the marine section, we uncover the relationship between oceanic elements, geosciences, and technological developments. The GSI Geoscience Museum stands as a monument to knowledge and inspiration, unveiling the marvels of Earth in harmony with visitor aspirations. While we treasure the geological wonders of Earth, the museum serves as an essential reminder of our shared responsibility to nurture and preserve our home. This museum illustrates the vast history of Earth, showcasing the evolution from early land plants to mass extinctions, integrated with modern scientific knowledge. From the Jurassic era to the modern day and across oceanic and aerial landscapes, this museum is a vital monument for students and aspiring geologists. Highlighting the milestones of life's evolution on Earth, we are thrilled to create a monument that will continue to inspire future generations. Let's celebrate the blend of geoscience and aesthetic charm. Visit the GSI Geoscience Museum in Gwalior to discover the extraordinary story of Earth. The treasures of our planet await you. Gwalior, city of legends, where history meets modernity. Known for its architectural grandeur and cultural richness, the city has now embraced a new dimension. A state-of-the-art GSI Geoscience Museum. Nestled in the heart of Gwalior, the GSI Geoscience Museum is a beacon of scientific curiosity and educational excellence. Developed by the Geological Survey of India, this museum is a testament to the organization's commitment to making geoscience accessible to all. The museum was inaugurated on 15th December 2024 by the Honorable Vice President Shri Jagdeep Dhankar. Honorable Minister of State Shri Satish Chandra Dubey issued the inaugural ticket, symbolizing the museum's new chapter with its visitors. With state-of-the-art facilities and interactive exhibits, the museum invites visitors to embark on a journey through Earth's rich geological history. This iconic project aims to make geoscience accessible, engaging, and inspiring for everyone. Welcome to the GSI Geoscience Museum. Witness the extraordinary phenomena that stimulates curiosity about historical narratives and evokes hope for the future. Here are two skillfully curated galleries, each providing a fresh insight into our planet. Gallery 1 showcases planet Earth, its uniqueness in diversity. A stunning gallery with 7 distinct themes featuring volcanic landscapes, celestial meteorites, and intricate geological structures. It displays meteorites that traveled through the cosmos. This gallery shines with rare Antarctic rocks as its treasures. The gallery too presents evolution of life on Earth, showcasing ancient ecosystems and mass extinction while highlighting resilience. There's a nicely articulated section highlighting the extraordinary volcanic history, beautiful yet terrifying forces that have significantly altered Earth's landscape. We are now in the earthquake tremor zone, offering an interactive experience of seismic activity and Earth's dynamic qualities. Next, we enter the fossils section, showcasing the resilience and adaptability of life over billions of years, highlighting the evolution of species. In the marine section, we uncover the relationship between oceanic elements, geosciences, and technological developments. The GSI Geoscience Museum stands as a monument to knowledge and inspiration, unveiling the marvels of Earth in harmony with visitor aspirations. While we treasure the geological wonders of Earth, the museum serves as an essential reminder of our shared responsibility to nurture and preserve our home. This museum illustrates the vast history of Earth, showcasing the evolution from early land plants to mass extinctions, integrated with modern scientific knowledge. From the Jurassic era to the modern day and across oceanic and aerial landscapes, this museum is a vital monument for students and aspiring geologists. Highlighting the milestones of life's evolution on Earth, we are thrilled to create a monument that will continue to inspire future generations. Let's celebrate the blend of geoscience and aesthetic charm. Visit the GSI Geoscience Museum in Gwalior to discover the extraordinary story of Earth. The treasures of our planet await you. Gwalior, city of legends, where history meets modernity. Known for its architectural grandeur and cultural richness, the city has now embraced a new dimension. A state-of-the-art GSI Geoscience Museum. Nestled in the heart of Gwalior, the GSI Geoscience Museum is a beacon of scientific curiosity and educational excellence. Developed by the Geological Survey of India, this museum is a testament to the organization's commitment to making geoscience accessible to all. The museum was inaugurated on 15th December 2024 by the Honorable Vice President Shri Jagdeep Dhankar. Honorable Minister of State Shri Satish Chandra Dubey issued the inaugural ticket, symbolizing the museum's new chapter with its visitors. With state-of-the-art facilities and interactive exhibits, the museum invites visitors to embark on a journey through Earth's rich geological history. This iconic project aims to make geoscience accessible, engaging, and inspiring for everyone. Welcome to the GSI Geoscience Museum. Witness the extraordinary phenomena that stimulates curiosity about historical narratives and evokes hope for the future. Here are two skillfully curated galleries, each providing a fresh insight into our planet. Gallery 1 showcases planet Earth, its uniqueness in diversity. A stunning gallery with 7 distinct themes featuring volcanic landscapes, celestial meteorites, and intricate geological structures. It displays meteorites that traveled through the cosmos. This gallery shines with rare Antarctic rocks as its treasures. The Gallery 2 presents evolution of life on Earth, showcasing ancient ecosystems and mass extinction while highlighting resilience. There's a nicely articulated section highlighting the extraordinary volcanic history, beautiful yet terrifying forces that have significantly altered Earth's landscape. We are now in the earthquake tremor zone, offering an interactive experience of seismic activity and Earth's dynamic qualities. Next, we enter the fossils section, showcasing the resilience and adaptability of life over billions of years, highlighting the evolution of species. In the marine section, we uncover the relationship between oceanic elements, geosciences, and technological developments. The GSI Geoscience Museum stands as a monument to knowledge and inspiration, unveiling the marvels of Earth in harmony with visitor aspirations. While we treasure the geological wonders of Earth, the museum serves as an essential reminder of our shared responsibility to nurture and preserve our home. This museum illustrates the vast history of Earth, showcasing the evolution from early land plants to mass extinctions, integrated with modern scientific knowledge. from the Jurassic era to the modern day and across oceanic and aerial landscapes. This museum is a vital monument for students and aspiring geologists. Highlighting the milestones of life's evolution on Earth, we are thrilled to create a monument that will continue to inspire future generations. Let's celebrate the blend of geoscience and aesthetic charm. Visit the GSI Geoscience Museum in Gwalior to discover the extraordinary story of Earth. The treasures of our planet await you. Gwalior, City of Legends.
As
Where
Deputy
history
Director General,
meets
GSI
modernity.
Central Region, Nagpur, and currently overseeing Regional Mission 1 and holding additional charge of DYDG State Unit, Madhya Pradesh. We welcome you, sir. To co-chair the session, I invite on dais Dr. Bibhas Sen, Deputy Director General, GSI Pune. I request all of you to welcome our chair and co-chair with a big round of applause. Bibhas Sen, sir, is a postgraduate from IIT Roorkee, joined GSI in 2000 and has over 25 years of experience in geological mapping, mineral exploration and volcanological research. He currently serves as Deputy Director General heading GSI State Unit Maharashtra from Pune, overseeing around 50 geological and research projects including academic collaborations. We also welcome you, sir. Now it's time to hear from our keynote speaker for this session. I invite on dais Dr. Prabodh Ranjan Sahu, Associate Professor, IIT ISM Dhanbad. Please. Dr. Sahu specializes in ore and exploration geology with a focus on mineral deposit genesis and critical mineral assessment. A recipient of the National Geoscience Award 2013, he has published over 27 research articles and guided numerous PhD and postgraduate students. His research also includes mineral characterization, beneficiation studies, and project consultancy. Ladies and gentlemen, with a big round of applause, please welcome Dr. Sahu on dais. Please, sir.
Okay, good afternoon to everybody, all the dignitaries of the dais and on the dais. It is my privilege to speak on this huge gathering, and the most fortunate thing is I served GSI from 2010 to 2013. Then I went to IITSM Dhanbad, so I got a platform at GSI, and I got many things from, I learned many things from my seniors in GSI who are serving, or many of them have already retired. So again, I am coming to this academic part. I have come across many challenges while dealing with the recent that is study on critical minerals. That's why I have chosen a topic where you can face the challenges and how to remove the challenges or to minimize the challenges so that we'll get a huge success in the near future in terms of the critical mineral. So my topic, that is critical mineral exploration potential in India and this appraisal from the global context. So basically it is a theoretical concept which minimizes the risk in exploration, because the exploration activities covers that means take a long time, and it also involves a lot of cost. So unless we understand the basics or we understand the intricacies regarding the pathogenesis or genetic aspects, so it is very difficult to achieve the success in terms of mineral exploration. So I start with already from the morning session, DG sir already explained a lot of things. All the speakers have mentioned about the critical minerals, and we are truly in a nascent stage in critical mineral research. So here I have only focused some elements or some minerals which are now in a priority list, that is lithium, all the rare earths, some cobalt, nickel, and vanadium. And we have some hope. Although we have some resources we have established, but in terms of the resources we can get some hope if you go for a detailed study or analysis of the geodynamic setting of the total Indian subcontinent from the global context or global overview. So everybody know the challenges or mineral exploration is challenging, and what are the uncertainties that lies in the mineral exploration? First is why all the favorable host rocks do not carry the mineral. That is the first point, because we target as a concept. If somebody asks me which rocks you are going to target for nickel, definitely somebody will ask or answer that is ultramafic rocks. But whether all these ultramafic rocks are potential for any nickel or cobalt, so that is a big question. So that's why understanding the thing will be make our task easy. Then second thing is why a mineralizing body is not translated into a mineral deposit. That is the second point, because in many cases what we find, although we analyze the samples, get the data that is encouraging, but sometimes it cannot be translated into a deposit scale because of many factors that is the uncertainties. And third is why lateral and vertical continuity of the ore zone are not established or disturbed. Again, that is related to the concept and the nature which guides the mobilization of the mineral or this mineral setting, and we don't get either a lateral continuity or a vertical continuity. Then what is the uniqueness of the deposit? Basically, the fundamental difference, the concept is each mineral is having a set of features or figures. I can say it is geological concept, or they are geological or geochemical constants, or sometimes they can be established by geophysical signatures whenever they are not visible, they are blind. That's why it is very essential to understand all these things in a step-by-step mode, so that we can minimize the risk and restrict a smaller area or prospect to go ahead with our exploration for success. So fundamental difference involves a typical environment of mineral deposit. All this mineral deposit, they have strict mineral deposit setting. Second thing is local or site-specific geological variations, a time relationship, then spatial distribution. All these things again the guide the geological system. And third is the most important. Now it is the a new concept. So mineral system dynamics. Since that the earth processes are dynamic processes, so one continent which is blessed with mineral deposit at a particular time, if you find the similar setting in the other continent, you may not find it because of the dynamic nature of the earth. So that may get disturbed, or some of the features get eroded, or you can say it is completely vanished because of the dynamic system and multiple events of deformation or metamorphism. Sometimes these are also favorable. Like the shear zones, although in many of the shear zones over the globe, they are considered to be very potential for many minerals, but in some of the cases they are not fertile. So what lies or what is the intricacies behind this mechanism or mobilization of the fluid or mobilization of the mineral content, that is a crucial point to discuss. Then another point is major ore forming systems. They basically found in a very narrow range. If you see the global history from the Hadean to the recent past, that means we have come across the different metallogenic setups or metallogenic periods in a very short span of time. I'll be showing that. It is taken from a research paper. So these critical time horizons must reflect unusual regional variation or regional scale occurrence of any mineralization over the time period. That is our point of discussion on today. So before coming to like whenever we go for exploration, so what we try to do, we go ahead with the proposition like I'll be targeting this area for these metals. But whether this concept will valid or will work over there, that lies within this system or these three critical points. One is, this is called as the critical mineral system that was proposed by McQuaig and Rensky. So what it says, there are three components. One is the source. Unless we have a fertile source, we will not have any mineral deposit. That will never lead to any mineral system. That is number one. Second thing is a lithospheric architecture, from where this fluid or this mineralizing source is coming. That is most crucial. So once there is a fertile magma or fertile rich fluid that is coming through a lithospheric horizon or region which preserves or which is favorable for the precipitation. So that's why that is the third point is tectonic criteria for this setting. We know like all these mineral deposits more or less they are controlled by the tectonic criteria or concept. That's why understanding the tectonic concepts will make our job easy. That is the first point. So integrating all these three, and the last one is how they are getting preserved. That is the point. So unless suppose we have all these 3 points that is validating or that is favorable, but the fourth point, they are not, there is no preservation mechanism. Or if that is once upon a time that was preserved, but somehow it is getting disturbed, that is leached or that is remobilized, and the concentration we are expecting that is not found. So there we are falling behind or falling below the threshold limit. So that's why although we have all this favorable setting, but the preservation mechanism is not met or the threshold limits we are not attending, then it is not translating into a deposit scale. Though we will get some mineral occurrences or mineral body, but that is not going to give any good results in terms of mineral deposit form. That's why that is crucial. Then this is very common. Just I'll give some highlight. Like you know, what are the sources of different metals, some of the critical minerals that is mentioned. Here, the mantle reservoir, we have that is nickel, cobalt and platinum group elements, including the chromium. Then the oceanic crust, that is copper, lead, zinc, manganese, cobalt, all these things. Then third one is the lower continental crust, all Re. Then thorium. So these are the resources. Then in the upper continental crust, we have huge number of that is metals. Mostly they are critical minerals. And so once you understand what is the sourcing, if you see that previous slide, compare that, then it will resolve many things. So that is conceptual thing will be applied in the mineral science or mineral exploration science. So next one is, what is the strategy to be followed? I have made some points over here. Here the strategies are starting from the exploration to characterization and up to the extraction. So first we understand the basic concepts to find a successful project completion or maximum chance of getting or intersecting mineralization. Then second is defining the threshold values. Nowadays, although we are very, sometimes we are overwhelmed with some results, a few results, but ultimately it may not be very encouraging whenever you compare the threshold limits. Again, it is guided by many factors, whether they will be in which form they are occurring and how they will be extracted, what will be the price of this product, whether we are getting, suppose, RE. If we are getting all these RE oxides, then that will be beneficial. But if you are it is difficult to extract all these metals or REs from the mineral, then it is not of no use. That's why the threshold limits are very crucial. Nowadays, we have to introspect and define the threshold values for all these critical minerals first. That is the utmost importance for now. Then third is characterization of the mineral. Again, which mineral bears this critical mineral, whether they are in the mineral form or they are in the adsorbent form, so that need to be confirmed. So unless we do this, it is again not translating into a mineral deposit, and nobody will be happy, or nobody will be taking this risk to venture into this business. Then fourth is developing the flow sheet. Of course, it is not our job. As a geoscientist, we will go for the exploration, and if we get some sufficient resources and it is translated into reserve, so that is the headache of the mineral engineer or process engineer or metallurgist to think about that. That is the metal extraction, and lastly, the industry users. Here, just it is very common diagram. So two things I have, that is empirical model and conceptual model. So empirical model for, in Indian context, if you look at, for critical minerals, now it is almost not valid because we do not have much critical mineral resources, except a few. But whereas the conceptual model can work, and we can target the locations of the mineralization of importance. So here, in a conceptual model, we go ahead with the genetic concept or genetic modeling, that is understanding the source mechanism, how they are transported, and finally the trapping condition or trapping environment, where they are getting trapped. Just like people believe that it is very common for petroleum system, but it is not exactly fitting to the petroleum system. It is also valid for the mineral system. Everything should have the source, again the transportation mechanism, and finally the dipping or the trapping conditions. Then if you understand this, resolve this issue, then success will be there. Here, again the previous slides, we compare the previous slide, how do we approach the exploration targets? The first picture, that is primary fluid source. Everything is coming from a source, whether it is a deep mantle or upper crust or SCLM. So the source should be there. So that is the large target. And whenever it is coming up during the tectonic processes or diving forces, so that is forming some mineral enrichment or occurrences in the camp scale, that is slightly larger, smaller. And finally, that is, so we'll be working on this camp scale, and finally it will be translated into the deposit scale. And this is the way how we start with from a large data sets and ending with the exploration ideas. That means how to define the prospect. So that is mentioned from this diagram. So usually we'll identify all this, we'll consider all this concept, then gradually we'll be rejecting some criteria and accepting some criteria. Ultimately we'll be reaching one point where the maximum chance will be there for occurrence of any mineral prospect. Yes, this is the same thing. Just I mentioned this fluid throttle to deposition setting at a different steps, and that is the critical processes involved in the mineral dynamics or mineral deposit setting. Because we are relying broadly on the primary deposit, this slide is related to the mineral occurrences which we can look for as a byproduct. Like many deposit setting we have, and if you look at, even we are going for the zinc deposit, we can expect the other associated elements or minerals to recover as a byproduct. So our target should not be like getting the germanium or indium independently, but we should see the occurrences of different mineral in this particular systematics. So that is a detailed discussion, a detailed slide regarding the association of different element in different geotechnic setup or mineral deposit setup. Yes, this is taken from Groups and Santos, and I will consider this as a lookup table. We have another table that is Indian context that is proposed by Professor Mihir Dev. Here, if you look at the giant and supergiant deposits, they have in different continents, they have a spatial as well as a time relationship. And if you correlate, suppose I am going ahead with the Ilgan Craton, Archean Ilgan Craton. So what are the mineral association in Ilgan Craton? Because that is well established, thoroughly studied, so we can have a look at that deposit, what controls the mineralization, and will apply in our system. So from a global to a local, from a global context to the Indian context, we'll be trying all this mineral association that is found over this system, and whether this evidences or any indications are there in our country or different parts or different cratons in India. So that we have to look for. So there are some local interests are there and some global interests are there. I can say it is the giant and supergiant deposits. Just I'll mention this point. So depending on the deposit types, we have magmatic, magmatogenic or hydrothermal deposits and some sedimentary deposits. Now, since we have the huge land mass which can have or which bears a lot of mineral, and we have to assess whether they are fitting within this field or not. That means they are correlatable with the time and space relationship or not, that we have to define first. If there are some indications, similarities, then we will go ahead. That means that will restrict our risk, because we are simulating, we are correlating the mineral system which is having a very high potential to host this mineral. Yes, this is regarding, I was telling about the time relationship, different tectonic events that has happened, that has reshaped the continents, is also very important, crucial in defining or deciding which area to be taken for which commodity or which mineral. So that is, everything is given, it is because of the time restriction, I cannot elaborate all these things, but still, some of the event you can see, there is a huge mineralizing episode, whether it is for lead and zinc, or it is iron, or it is uranium, or it is basically for rare earths. So that is defined from this field. So first we have to think about the basic research within that particular craton or region which favors the precipitation or deposition of this mineral. That is the point that is discussed from the slide. So here different deposit types starting from the IOCG, VMS, then SEDEX deposit. There is a link, global, that is supergiant deposits are listed over here. Now we have to correlate, like what lacks in our system and what is there. For example, if we compare the Chilean copper deposit, that is we do not have that kind of setting. But if you compare the age constant and the geodynamic setting, that is more or less similar to our Kodappa basin. But why we are not getting so much of mineral potential? So that is again the point, because of a lot of recycling and tectonic activities has reshaped the Chilean or Andean belt for mineral occurrences, that is copper mineralization. Yes, I was talking about a lookup table here, that is from Professor Mihirdev's paper in 2014, and here he has mentioned, he has clearly mentioned the timing, and that is time-space distribution of this mineral deposits in India, that is Precambrian silt. So you know the Precambrian silt in India, they are more or less favorable for many deposits, and we have to target those. We are targeting those, of course, by different agencies, including GSI and some private exploration agencies. So these areas should be on our priority list. So whenever you go, you have to assess whether this area is matching because of the huge land mass. So it is very difficult, but still we have to look at these conditions, features, whether that is matching for any such mineralization which we are looking for. In addition to that, you have to look for the byproduct relationship, whether it is VMS, then I can think about the byproducts, or if it is SEDEX, I can think about the byproducts. Sir, I have 2 minutes, please. It is slightly away from the topic, because I have discussed the Indian context versus the global context. Now, everybody tells about the China's policy and dominance. The advantage or the typicality of the China policy is they have 4 verticals. First is they have a strong geopolitical strategy, decade-long research, and that has resulted. Suppose they had started 30 years back, they are getting the result now, or 5 years back or 2 years back. Second thing, they have the exploration strategy and technological supremacy. That means they are starting the material, that means from exploration to the fine product, they are able to extract. Even if you compare cobalt, that is China is the leading producer, but where from it is getting? It is getting from Africa. So that's why, so you cannot say if a country will have their own resources, they will be the supreme leader. No, China has disproved that. So we can do that in the near future, like Kavil and many programs by government that is spearheading the program. So you can have these resources for after maybe it may take time, 5 years or 10 years, but it may happen. Then third is integrated supply chain, and fourth is the fine products, market. So they are going for the fine products, selling the products, and that's why they have the dominance, otherwise nothing else. To some extent, Ari already know. Just one point I would like to highlight. Traditionally, we know which rocks are the Ari bearing, or there is a strong chance or high chance of targeting the Aris. For example, we are targeting the coal and fly ash or red mud or overburden telling materials. But as compared to those, the traditional practices, if you follow the traditional practices or concepts, then the other one like carbonatite or it is the pegmatite or granite, they have a fair chance of getting or hosting the Ari minerals. That's why instead of looking at my observation, this is my suggestion, instead of going for a very tricky affair or very complex process, if you go for this, that will be more valid. And just one slide, I have 2 slides I have regarding the vanadium. Recently I was going through some research paper. In India there are some auctions for vanadium and magnetite. So one aspect is the vanadium can come from the
titanium ferrous vanadium magnetite, and second is the carbonaceous material. So carbonaceous material, they're basically locked within these clay minerals, and some of them are translating into a mineral that is basically emitted or adsorbed by the silicate phases. So what is the source? Basically from a carbonaceous material which was basically organic, and later on during the metamorphism, they are evolving into, or they are released from the system and getting adsorbed within the clay mineral, or sometimes they transform into or they convert into silicate phases. So that is one of the causative for vanadium occurrences in carbonaceous phyllite or carbonaceous rock, or including the graphite. So there is a, that's why in some petroliferous basins in petroleum processing, vanadium is used as, vanadium is extracted as a byproduct. So that is the reason. Then a giant, the green giant vanadium deposit, basically that is Madagascar, that is within the quartzo-feldspathic gneiss and lot of calc silicate bands and graphite bands. So that is related to the vanadium system. And this is the mechanism that is published in 1991 by Brett and Wanty, and he has explained how vanadium is incorporated in the clay and in the other minerals in a system. And another, this is my research, my part, just sir. Some of the sulfides, also sulfide deposits, contain valuable metal like cobalt, nickel. Already you know, copper deposits in India that used to be a potential source for nickel, vanadium, molybdenum. Similarly, other deposits, especially I have worked on some polymetallic sulfides in Rajasthan and some other copper deposits in India, and that is giving some valuable metallic concentration including tellurium, selenium, nickel, cobalt, and antimony concentration. So this is another concept is, we think, or it is a concept like zinc ores can host germanium, indium. But in Indian context, the setting is not like that. Zinc, if it is associated, if it is found by scan setting, then indium and germanium will be high. But in Indian context, it is not there. So I analyzed many samples, around 30 to 40 samples, and I have got the result. They are not very encouraging. So Indian context, thinking about extracting germanium or indium may not be a good idea. And these are some of the sulfide bodies, analysis of the sulfide bodies, whole rock analysis, and that gives some idea about the concentration of nickel, cobalt values in the system. Sorry, sir. Sir, this is regarding again, because I am from IIT Dhanbad, it is very close to Koderma. I tried because of this euphoria. So I visited twice to this belt, Koderma mica belt, and collected some samples, hoping I'll get some rare earths or lithium values. But somehow I have not tested the success because of some constant. Started reading the paper, and some of the paper says there is a classification, and even there is a newer classification that is published in 2024, and they say you can have multiple varieties of pegmatite. So unless we identify which pegmatite host or is favorable for lithium or rare earths, it is not wise to go ahead with the exploration program. Otherwise, again, success is not going to happen. That's why these are some of the occurrences, accessory minerals, primary minerals, and geotechnical setting, and how they are linked with the mineral from a very peripheral zone to the intrusive to far away from the intrusive. Yes, sir. These are all related to pegmatites and its fertility parameter for rare earths or lithium. So all these things are explained. That is the latest classification proposed by Simmons in 2024. He has again classified, like again, I thought in a research, whenever I searched the literature, I could found a very limited number of publications from Kodama Microbelt, and it is mentioned like orogenic system and S-type granite will have lot of lithium, but that is added by, that is modified by this Simmons et al., and they have proposed new ideas, and that is listed over here. So which will be fertile or not, that is mentioned in these research papers. So that is the model that is proposed by them, and accordingly you can expect where we are going to get. It is a finer pegmatites or coarser pegmatites from a proximal zone to distal zone. All these things are proposed by them in 2024. Sir, I'll skip this slide.
Please wrap it up.
Then, you know, it is everything is linked to metallurgy, so no need to discuss these things because I'll skip this slide. So metallurgy, as I already in the first part I mentioned, metallurgy plays a crucial role in placing the mineral systematics. So we have to understand the metallurgical systematics first. These are some of the rare earth resources. In India, we don't have any. That is, of course, except the lesser ones, base placers. So far, and carbonatates, we do not have any success, major success. I will not say success, it is a major success. And one of the parameter is nowadays, it is called as the ion adsorption in the clay. So that can be looked at. Apart from that, the LIPs can looked at for vanadium, titanium, along with the rare earths, especially the LIPs, that is the intrusive dikes in the coal system, they are also called as LIPs. They can be looked for any rare earth resources. And preliminary data, some unpublished report says some abnormal rare earth concentration in the intrusive dikes. Yes, sir. I think it's done. Yeah. Thank you, sir. Sorry for the. Yes, sir. Sir, it can be there, sir. Yes, sir. In Canada, they have. It's in pigment. There, sir. Actually, they are getting lithium plus RE. Yes, sir. Yes, sir. Sir, tantalum, niobium, then plus other because. Okay, sir. No, sir. In from because, sir. No, sir, I didn't say like that. I said that all this rare earth in the beach placers and carbonatates, so we do not have good amount of resources. I said that.
No, I don't have to dispute that because as of now, we have already proved 1.1 million tons of rare earth oxide equivalent in Ambadukar, Gujarat.
Yes, sir. Carbonate,
and
sir.
then Rajasthan, one area is coming up for auction now.
Sir,
90,000 tons
yes.
of rare earths. So you cannot say that India
No,
doesn't
sir.
host rare
I didn't say that, sir. I said that except these
in hard
placers and carbonatates.
But in hard rocks also, you cannot say that India doesn't have rare.
Yes, sir. I mentioned that. The carbonatates I mentioned.
Plenty of rare earths are going to come in hard rocks also.
No, sir. I mentioned the word the carbonatates.
I'm Anindra Bhattacharya from GSI Jaipur. I just want to add on two things. First of all, Dr. Sahu, it was a very extensive, it was going back.
Okay. Yeah, go ahead.
I think it was going back to the classrooms again, wonderful presentation. Anyway, there are 2 points. Number one, as said by him, that we have a wonderful and one of the largest deposits of RE. That's from the hard rocks, that's from the Malanis, and that is in the Siwana.
Yes.
In fact, I can just give a small example. One G3 project in GSI has yielded nearly 50 million tons of RE there. And it is one of the deposits in which HRE is much more prevalent over almost equivalent to the LREs. This is one point. And another point is that for germanium and indium, in fact in Zawar mine that we have, this come as a byproduct. So the lead zinc of Zawar contains germanium and indium. So this
Yes,
full
sir.
information.
Sir, germanium and indium is there, but that is, if you look at the threshold values, it is not yet decided. But still, sir.
In fact, they are paying a huge revenue to the government as
sir,
a byproduct.
I think it is still in the debate whether they will be paying it or not. I am not very clear.
They're extracting it. They're extracting it. The main extraction is for lead and zinc with silver, germanium and indium.
Cadmium, sir. Cadmium, and I know, sir, cadmium and silver that is extracted, but germanium and indium, I have no idea.
Thank you. You can continue the discussion afterward, please. Sorry for interrupting. Thank you, Professor Sahu.
Thanks, sir.
Thanks
Thank you,
for wonderful lecture. Next, please. Next, we can have Shivani Kumari, Nayak, geologist, GSI Bhopal. Her topic is post-collisional magmatic processes and their implications for critical mineral deposits in northwestern Betul belt. सुनाई दे रहा है या नहीं दे रहा? Sibani, please restrict your presentation for 10 minutes and 5 minutes of discussion. We are running short of time now.
Good afternoon, everyone. I am so excited and honored that I am going to present a presentation in the National Conference on the Critical Mineral Exploration, Exploitation. ठीक कर दीजिए। हो नहीं रहा। ऑन करना। Good afternoon, everyone. I am so honored and excited to give this presentation on the National Conference on Critical Mineral Exploration, Exploitation. And I am going to brief about that post-collision magmatic process and their implication for the critical mineral deposit in the northwest Betul belt, Madhya Pradesh. So I think the Betul belt may not be familiar to everyone, yes. So I will start with the location map. You can see this left one is the Kraton map of India, and with highlighting the CITZ, that is Central India Tectonic Zone. And you can see that the Betul belt, where is the Betul belt? This right one is, that is the Jum part of the CITZ, and the Betul, that is CITZ, and Betul is like sandwich between the Mahakoshal and the Sosa. And exactly situated on the Son Narmada North Fault in the north, and Gavilgod Tangsier zone on the south. And the larger map is the geological map of Betul belt in the 2,50,000. And here it is resemble like tiger is running position, like, and my study area in the northwest part of the like head of the tiger. Here you here in the Betul belt, mainly you can get the bimodal volcanic, that is basalt, rhyolite. Simultaneously, you will get the ultramafic as well as the granitoids and the metasedimentary rocks. And the next is the large-scale geological map of my study area, Here you can see that the basement is the Amla gneiss, followed by the Betul group of rocks, that is granitoids, different type of granitoids, and the younger intrusive, followed by the Gondwana sediments and the Deccan Trough. Where you just highlight this, my box, that is the black box. Here you can see that is ABC, this is the cyanide, quartzite, and the pegmatites. This, they're previously not reported in this area. So the detailed study of this quartzite, cyanide, and pegmatite is important to know the information about the petrogenesis as well as the importance of the RED mineralization in this area. So here, these are the field photographs and the micro studies of this quartzites. Here the quartzite is quite massive and medium to coarse grain, with mainly composed of the K feldspar, albite, and little bit of quartz, with mafic mineral like hornblende and clinopyroxene or Fe biotites, thus anites. And this quartzite is mainly present in the eastern part of this map and near the Mendakhara Kanjitala village. And that is sometime in the shear zone, near to the shear zone, it get sheared trend of the east-west. This is the field photograph of cyanides. Here you can see this, what is the difference between quartzite and cyanide in the field. That is, there the mafic minerals are little bit less, where here the mafic mineral more. So as mafic mineral are more in the rock, it get easily weathered in the outcrop. So the outcrop are mainly low elevated area and mainly isolated within the quartzites. And you can see this full micro studies also. Here you can get the Fe-rich azurine or maybe clinopyroxene are there in this area. The next is, this is the amazonite pegmatites. Previously I have not identified any amazonite pegmatite field, so I was so excited for that. And the amazonite is a green feldspar. Hello. It is green feldspars, green microcline you can say. It is semi-precious variety. And in this, it is, the pegmatite trend is nearly northeast, southwest, or somewhere northeast, southwest direction. And the size vary from the few cm to few meter. Some place it is quite large also. After literature study, I get to know that NY type of pegmatites are maybe related to the amazonite pegmatites are more related to the NY type pegmatites. In the EPMS study, I identified many important minerals that are more important for RED point of view. You can see the cerite, alunite, monazite, genotime, fergusonite, bastnasite. These all are important for RED point of view. And like alunite, monazite, and cerite, these are more rich in LRED, whereas genotime or fergusonite, these are more rich in HRED. So it is give information about the petrogenesis as well. The next is the same BSc EMS. Here I want to more highlight this, the middle one, that is the fluoroapatite containing RED phase. That fluoroapatites, the fracture plane in the fluoroapatites containing RED phase. That means the fluoroapatite already crystallized. After that, the RED phase come to the exist. That means it's indicate that there is later stage of magmatic process or is the hydrothermal intrusion in this area. As well as you can see that the extremely right one, that is the fluocerite, that also look like there's something replacing something or it's altered product. Whereas you can see this gold also. Gold also indicate that is the later stage of hydrothermal intrusion in this area. So overall, up to that point, we can say there is something that RED or these minerals comes to exist after the post-collision or the later stage of hydrothermal intrusion. The geochemical study of cyanide quartzites The chemical characteristics are low in silica, that is SiO2 range from the 57 to 63, whereas aluminum containing Al2O3 containing from 13 to 16, and MgO P2O5 that containing low concentrate, whereas FeO is little high because due to contain of the mafic minerals. And so this all the TSS diagram R1 R2 plot is indicate that it is a alkaline rocks, or it is undergo the alkaline igneous systems. Whereas then spider plot of iridine chondrite and primordial metal diagram, we can conclude that there is rich in LRED and moderate fractionated LRED, because Ln by YVN range from 0.1 to 11, whereas HRED is range from 0.2 to 3, that is not little bit fractionated with europium negative anomaly, that is 0.1 to 1, and high value of LILE and HFC, and obviously LRED also containing high, that is LAC and D, suggests the more evolved source of granites. Or here the strontium value range from 1 to 96, that is low, so it significantly inform that the plagioclase fractionated during the magma evolution, and the RB contain rubidium also containing low, rubidium by strontium value also little bit low to high. And overall I would like to mention this all the process is informing that it is post collision activities indicate that. And also I would like to, here there is this important slide for my point of view. This is containing RED value. I have collected many sample from out of the 13 value are coming, the total RED falling from 900 to 2000, and 3 value, the total RED of 3 samples coming from 2000 to 2300, and whereas the soil sample also containing 800 to 1500. So overally I would like to say that in this area the RED phase, or the RED, what we are searching for critical mineral coming in the later stage or during the hydrothermal intrusion after the post collision activities. So I would like to say that I have to study more about this area to get to know the evolution or the control of the RED in this area.
Thank you, Sivani. We can take a couple of questions from the audience. Quick questions, please. Okay, if there is no questions from audience, I would like to ask one question. How you plan to scale it up, as Professor Sahu was saying, go from local scale to district scale to regional scale? So have you thought about that? Just, is it possible to follow your suite of analysis of rocks to the entire Betul belt?
Here the cyanides and quartzite of this area is previously not mentioned in this area.
Okay.
So I would like to take it local to vocal or global, but still need to study more.
Yeah.
To where if I should correlate with the Amba Dogar or some CITZ or somewhere else, I have to study.
Thank you. We hope that you scale it up and understand the system as such. Thank you for your attempt. Good presentation. Can we go to the next presentation, please, by Dr. S.K. Dwivedi. Dr. S.K. Dwivedi will deliver the topic on first report of graphite mineralization in metasediments of Delhi supergroup, Delhi Aravalli Craton, Didwana, Rajasthan, implications for critical mineral exploration in covered terrain.
Sir, before that, I would like to have an important announcement. Ladies and gentlemen, we have with us here today Shri Dilip Yadavji, IAS District Magistrate of Katni District, Madhya Pradesh. I request Shri S.K. Bashir sir, DYDG GSI, to welcome Shri Dilip Yadav Sahab. So please, I invite you on the dais, please. Thank you, sirs. Now we may continue with the session. I invite on dais Dr. Dwivedi, sir.
Hello. Very good afternoon to everyone. Today I am presenting the first report of graphite mineralization in metasediments of Delhi supergroup, Delhi Aravali, Cretan, Didwana, Rajasthan, implication for critical mineral exploration in the covered terrain. Though graphite is already reported in many places in Delhi metasediments, but in this part we are reporting first time the graphite in metasediments of Delhi sediments. If we look at the generalized geological map of Rajasthan, we can see that majority of the Rajasthan part is under thick alluvium cover. Even we can say that 50% of the area of Rajasthan is under thick alluvium cover, and that's why we have a constant for mineral exploration, because we have very less geological information, and that's why we have a challenge for exploration. That's why based on this, but now based on now the availability of geophysical data, it become possible to plan our exploration and to understand the subsurface geology of the area. You can see we have taken one project here, that is regional mineral targeting, that is shown in the black color block, and we can see the regional data of airborne data, and we can see we are getting a very high magnetic anomaly, and we are getting two trends, that is trending northeast southwest, and here we are getting northwest southeast trending trend in the aeromagnetic anomaly, and these magnetic anomaly is meeting in the center part of this area, and that's become an interesting point for taking this project. Not only that, the northeast trending anomaly, geophysical anomaly, is well matching with North Delhi and South Delhi fold bed. But beside that, we have some other north-south trending anomaly that is very significant from mineralization point of view. If we look at the geological map of this area, we can see we have very limited outcrop, and majority of the area is under thick soil cover. Around 100 meter thickness of sand is present here. So we have very outcrop of Delhi metasediments near Didwana area and near Degana area, where we have tungsten mineralization in Revat Hill. Beside that, this western part is covered by Marwar sediments, and only we have very few outcrops in the quarry sections. Why this area is very important? If we look at the Google imagery, we can see the Tosam is situated in the north, Balda in the south, and we have Degana in the middle. But we have a gap area, and this area is reported to have a huge granitic activity, which has a contact with the metasediments of Delhi metasediments. So this area has a potential for granite related mineralization, as well as since it has having a contact with metasediments, so it has also have a possibility of ISKCON type of deposit and graphite like deposit we have discovered this time. Now if we focus at the gravity data of this area, we can see we are getting three sets of gravity data, gravity anomaly in the area. One is represented by very low gravity anomaly, and then moderate gravity anomaly, which is represented by green color, and then we have a very high gravity anomaly. So there are two possibilities, that we have a rock or litho package which has a density contrast. Are these are the lithology having some depth variation? So gravity response coming from both. If we have a same material in the shallow depth, it will give a different response, and the same material in the deeper, it will give a different response. And similarly, if we look at the aeromagnetic analytical signal data, we can see that two northwest southeast trending anomaly and northeast trending anomaly, they are meeting here at this center of the area. But sometimes it happens that ground validation for these geophysical anomalies is very important. I would like to say that when we took first time this project, we thought that this area is very potential because it has a very strong magnetic anomaly. And but when we have validated ground validation, we found the Marwar sediments are exposed here, and they are imparting very strong anomaly, and that anomaly is very correlatable with the meta sediments Delhi meta sediments in this part of the area. So ground validation of aeromagnetic data or ground gravity data is very important. Now we can see from this data that we are getting quiescent low magnetic response in this part, eastern part, and we are getting high magnetic, and rest of the area in this part, which is covered by Marwar sediment, have a very low magnetic response. Now if you look at this, we are getting, as I said, we are getting very sharp gravity gradient, northeast south trending gravity gradient, and this low gravity is represented by granites, and this part of this high to low magnetic gravity gradients are represented by meta sediments. And we are also getting some gradient, this northeast south trending gradient. Beyond that, we are having some Marwar sediments. So probably this is the contact between the meta sediments of Delhi sediments and Marwar sediments. We have very limited outcrop in this area, which is northeast southwest trending meta sediments, but having a feel of graphite we have not observed in the first time because of high weathering and wind erosion. And if we correlate in large view, if we see the enlarged view of magnetic response in the area, we can see that we are getting a set of high magnetic, low magnetic, then again high magnetic and low magnetic. So these rocks are very highly deformed. So we are interpreting and reporting first time that this is the shear zone. Now if we see the enlarged view of gravity data here, this blue color is represented by low magnetic, is represented by the granites, and these low to moderate gravity is represented by the meta sediments of Delhi sediments. This outcrop is situated in the western part of this contour. Beyond that, either side of this area, we are having huge thick sand cover. So we don't have any subsurface geological information. If we look at the depth solution, that it is also forming a linear pattern, northeast southwest trending linear pattern, means it is suggesting that there is some structural features. Why it is structural features? Because if this is normal contact between granite and meta sediments, we should have some notching or some zigzag contact. But it is showing sharp contact and having the deformation in the meta sediments, so we are proving this is the shear zone. Similar features we are getting in the analytical signal also, low magnetic and high magnetic, and very feeble malachite staining is also present. So earlier we targeted this area for copper mineralization because we were getting some copper value in the area. Later when we made a channel, we found that some graphitic luster is coming from the graphitic cyst. Then we decided to go for the graphite testing also. Now we have since we were working for copper mineralization, so we planned a detailed geophysical survey in the area, and we can see that we are getting a very linear, this linear SP value, low SP value, and which is very correlatable with the regional data. So this aeromagnetic data is very accurate, and we are getting sets of low to high magnetic area. And this low SP and low to high magnetic area is very congenial for graphite mineralization. So we plan one borehole to drill up to certain depth. Similar signature we are getting in the south of the earlier block, and we can see that we are getting a similar set of magnetic response, high magnetic, low magnetic, then high. So it represents the shear zones. And here also we are getting the low magnetic and high, low gravity and high gravity. This east-west notching is nothing is not because of granitic contact, but it is large-scale lineaments, which is responsible for sulfide mineralization in the area. And we are getting similar pattern. We are getting low SP and high magnetic and low magnetic. So we have also decided to plan one borehole here. Now you can see in the first block we drilled up to 200 meter, and right from starting we are getting this graphitic cyst in the area, and it has sulfide also, and sulfide copper value is not that much encouraging, so we are focusing on graphite. And you can see we are getting a very thick zone of graphite, right from 45 meter to 90 meter, and this like that. Similarly, we have planned one more borehole, and we have drilled up to 281 meter, and we are getting a very good, very thick graphitic cyst in the area. And this is the drilled core hole, and that is from 170 meter, and we are getting a similar type of graphitic cyst in 72 meter also. And this is the enlarged view of this. Now when we have done petrography, this all black color material is nothing but a graphitic content. We are also getting some sulfide also, but which has a perfect shape. So all these content linear veinlets are graphites, and that has been proved from the petrography. We have also done the XRD, and that has also been confirmed from the XRD that this has a graphitic content. Similarly, when we have done the same studies, we can see we are getting some veins of graphite. So there is a possibility that this may be a biogenic, and as well as hydrothermal graphites are present in the area. Then we have same mapping also. We can see from this image that around 60% carbon family is present. And we have a spectra also which confirm the presence of graphite in the area, and we can see from the BSE image also that the carbon threads are present, which is nothing but a graphite. We have done this also, the carbon flags with impurities, these flags with impurities, and we have also shown the carbon flags with only the carbon flags. We have then, finally we have confirmed this from the Raman spectroscopy also, and we got some encouraging value, and the spectra is ranging from 1500 to 1600 that confirm the presence of graphite in the area. And from this analysis, it is proved that in the area vein type of graphite is present. We have done also some fixed carbon that is ranging from 7 to 13%, and average is coming around 8%. Only in 60 samples, and we have submitted around 500 samples, so results are pending. Thank you.
Thank you. We can take one question only. Any questions from the audience? Yep.
Yes. Hello.
Mic दे दीजिए, please.
Yes, sir. In the both sample, because we had a large area, around 4,000 area we have to test with 2,500 meter depth. No, sir. We have taken this area for detail exploration now.
Okay.
Yes,
okay.
sir. Both the block has been taken for detail exploration because we have tested other commodities also, but results are pending, so
But
we
that
are
is not
not
a query.
discussing.
That is my submission to you.
Yes, sir. It
Yeah.
is. It has
Yes,
been
sir.
closed within the graphitic system.
But it should not be.
Yes.
Yeah.
But
Thank you.
because the thickness is it is too much, so we cannot go for 500.
Oh,
so we will.
We should be, sir, because within the graphite, you are doing graphite mineralization.
So we will try
investigation,
in
na?
the next stage of
Yeah,
exploration,
please,
sir.
Please.
Yes.
Right. Thank you.
Thank you, Dr. Dwivedi. One statement that you have made in your abstract that the geochronological age of granite and other higher-end laboratory investigations will help to establish mineral systems. So I would like to have a couple of, what is your plan of action on that?
Yes, sir. As I discuss in the Google imagery that this area is falling in between the Tosam and Balda. And we have carried out monazite dating from the granites because in the surface there is no granite. But we have collected sample from the duck bells.
Okay.
Old duck bells are there, so samples are available at places. So we have done monazite dating, so it is coming around 870 to 900. And this is big chain. So we are interpreting that this granite is having a continuation from Tosam to Balda. But we have collected the zircon also from the granites. That is the results are pending. So I think this will open a new space for critical mineral investigation in the area.
Thank you, Dr. Dwivedi.
Just one question, please. One question from my side. Here.
Oh, yeah, please.
Sir.
Here, sir.
Acha. Actually, what I am seeing, your graphite mineralization is litho-controlled, right?
Yes, sir.
And it has also suffered deformation?
Yes, sir.
So what is the regional structure what you are seeing over here?
Sir?
Regional structure.
Sir, actually, as I said, this is a part of North Delhi fold belt because we are working in junction of North Delhi fold belt and South Delhi fold belt.
Okay.
So this is the only outcrop we have in the area. And entire area is covered by thick alluvium, but this has a trend and shear zone is passing, so it has subvertical dip. Sometime it is dipping easterly, sometime it is trending westerly. So these are northeast, southwest trending.
Oh, that is one side what I could see from your map. It is one side. Eastern side it's northeast, southwest striking.
Yes, sir.
Western side I was seeing almost northwest, southeast.
Yes, sir.
Okay, it's somewhat it is making a closer toward our south.
That is from the geological, but we have a constant because that is very water poor area. So even we could not check the subsurface geology.
Actually, that's right. But if you want to search the extension, you have to follow that strike, right?
Sir, we have taken this project for G4 stage
for
of
that, you
investigation.
need to understand the regional structure, surrounding area, take a larger area, and you will be understanding if you know the regional structure, then only you can show where it is likely to be.
Sir,
okay?
actually we have made a very good predictive geological map that has been validated by drilling also. We have done around 11 boreholes, but our geological report has not been published, so I have not shown the geological map.
Okay.
Thank you.
Must show.
Thank you. Thank you. Many things have been said. Sir, can we? Thank you. Can we have the next speaker? You please continue discussion one-to-one. Can we have Professor Riya Ghosh from NIT Durgapur? Her topic will be magmatic critical mineral enrichment and secondary enhancement in Beldi phosphorite carbonatite.
A very good afternoon to all the dignitaries present here. I I'm very honored to get the opportunity to present in this prestigious platform, a national conference on critical minerals. I will be talking about magmatic critical mineral enrichment and their secondary enhancement in the belty phosphorite carbonatite, implications for primary and secondary resource potential. Now the human civilization can be classified on the basis of the resources they have availed by generations after generations, like copper age, stone age, and now we are passing and enjoying through an age which is being fueled by fossil fuel. But the gradual exhaustion of these non-renewable resources has forced the human brain to think about a substitute of this fossil fuel, which can pave a low carbon green technology mission, and it will be helpful for scientific advancement. So for this reason, a list of elements has been prepared which are termed as critical elements, and the naming is done by various groups of people for various purposes and in different ways. Two basic parameters are if there is scarcity in its availability, and the second one is pivotal role in the scientific advancement of the all over globe. Now here is a periodic table where we can see the listed critical minerals, and that is a pictorial where we can see the deposits of few critical elements, and here is a pie diagram where we can see the major minerals found in the earth crust, and the yellow region is a very thin one, but I have emphasized it because that is showing few accessory mineral, and among which I am choosing apatite from it. Now why I am choosing apatite? These critical, before that I would like to show, this is the 30 listed critical minerals, and among which I have working on rare earth elements, niobium, phosphorus, copper, and few about copper, cobalt and nickel. Now why I am choosing apatite? It's acting as a potential sink of rare earth elements because it's favor exchange of element due to its similar ionic radii with rare earth elements both during cationic substitution and during the fluid assisted alteration. So for primarily it acts as a sink of these critical elements. Second, it can act as a petrogenetic indicator which can decipher the petrogenesis of various mineral deposits, and it can also archive mantle signatures for the minerals. Now in geological context, we can find this rare earth and other critical elements which I have told within few phosphate minerals, which I am taking apatite in this case, and they are further preserved in rocks like nepheline cyanide, phosphorite and carbonatite. This is a global map where we can see several deposits of carbonatite and phosphorite or apatite bearing rocks. This is my study area. Apart from getting carbonatite from several parts in globe and also in India like Amba Dongar, Kamthai, Hogenakkal and Sevathur, we are getting few carbonatite deposits and along with phosphorite, which I am emphasizing on, in Purulia district, West Bengal, within a small village called Beldi, which is my study area. Now this is situated nearby South Purulia shear zone, and it is embedded between Chotanagpur granite gneiss complex to its north and Shingbhum shear zone to its south. Now this terrain consists of various rock types like nepheline cyanide, glimmerite, phosphorite, carbonatite, mica sheets and many more. This is my study area. Now I am choosing two types of rock from this, where we can see the apatite hosted within those. One is phosphorite and another one is calcite apatite bearing ultramafic rock suites. We have pointed out two types of apatite. One is designated as primary one, within which we have divided it as FAP1A and FAP1B. 1A is a type of primary apatite which is being further altered, and 1B is not altered. 1A is preserved within phosphorite and 1B is preserved within calcite bearing ultramafic rock suite, which is shown in figure F. Now FAP2 is secondary type of apatite which is formed after the alteration of the primary one. Other minerals found here are magnetite and few sulfide phases, amphibole, biotite, etc. Now here we can see in the same images the secondary apatite is which is designated as FAP2 as a overgrowth around the primary one, that is FAP1A, which is hosted restricted within phosphorite only. Now we can see monazite rim surrounding the or encircling the primary fluoroapatite. Now here the apatite is as seen in EPMA, it's a fluoroapatite F bearing. We can also see allanite within the boundaries of biotite and amphibole within the second rock type, that is the calcite bearing ultramafic rock suites. Another mineral called crandallite, which is a calcium aluminium phosphate, it is also found as a rim around the primary apatite within the phosphorite. Here is few niobium bearing phase which is also termed as critical within critical elements. Niobium is occurring as columbite and fersmite, and which is associated with monazite also. And here are few minerals which are containing trace elements which are also critically under critical elements list, and those are baddelite, thorite and betaphyte. Those are in a very trace concentration in the terrain. Here are few extra maps where we can see the concentration of several elements which I have already talked about. Now in this graph we can see the concentration of rare earth within the various type of fluoroapatite I have talked, and from these plots I can say that the Re concentration is highest in primary fluoroapatite, that is in the calcite bearing ultramafic rock suite. Secondly coming the second type of primary apatite, that is FAP1A, and lastly in FAP2, that is the secondary apatite which is containing the least amount of Res within it. These are X-ray maps of those niobium phases, and we can see the concentration of various elements present here. Here is a plot showing the Re concentration in the niobium phase, and we can see the columbite, which is a niobium phase formed magmatically, contain less amount of Re compared to the fersmite, which is formed after the alteration of the primary niobium phase, that is the columbite. And trace amounts of sulfides are present over there, and there we can see pentlandite, which are present as inclusion within pyrrhotite, and very less concentration of cobalt and nickel is present over there along with copper. Now coming to phosphogypsum, why I am talking about this? It's a byproduct of phosphoric acid. If we put sulfuric acid in phosphate rocks, here in this case it's apatite, we will be getting phosphogypsum along with phosphoric acid. It's a calcium sulfate, that is a kind of gypsum. Now this phosphogypsum is useful for society because we can use this for agricultural purpose and road construction. But why I am talking about this phosphogypsum? Because it contains some impurities like zinc, lead, Res, copper, cadmium, nickel and chromium. Now these are carcinogenic for human being. So if we can extract these elements, it will be useful in two ways. We are getting critical elements extracted from this phosphogypsum, and secondly we are making this phosphogypsum impurity free, which are not harmful for the society in that case. Now these types of fluoroapatite, both the rock types in phosphorite and carbonatite, this is formed in the process like while the magma is being generated from the mantle, then the carbonatitic magma was already rich in P, phosphorus. So after precipitation or formation of the carbonatite, phosphorite has been formed, which is a fluoroapatite or apatite rich rock. Then the alteration of this primary fluoroapatite by coupled dissolution pre-precipitation process, secondary apatite has been formed, and in this time period only several RE bearing phase, that is monazite, allanite and other critical element bearing phase has been formed. So these are formed during the alteration process. Now all these are being in focus because we are gradually getting exhausted of the fossil fuels and also the primary deposits of the economically important elements. So we should shift our focus to the secondary resources like phosphogypsums and apatite like mineral, which are actually accessory mineral and not in a true sense RE bearing mineral like monazite and allanite. Though these are found in low grade, but we should keep focus on this only to bridge the gap between the supply and the demand. So we could run a low carbon green technology mission. Now zero discharge inculcated with eco-friendly technology is the main challenge for us to march towards a low carbon footprint for sustainability. So although apatite is the concentration of critical elements in these terrain is low, not economically viable, but still we should focus on their extraction. This low grade ore, although it contains greater than 2 parts per million, maybe this waste can be considered as a wealth in some period of time, because we are running in scarcity compared to its availability of these elements. I would like to acknowledge GSI Central Region for giving me this opportunity, Dr. Shakti Sir of IIT Bombay for his fruitful comments, and thank you for listening me patiently.
Thank you, Dr. Ghosh, for honoring time. You finished within 10 minutes. Yeah, and sharing your in-depth understanding with us. The session is open for discussion. Please, can we have a couple of questions from the audience? Yes, mic please. Sir के पास mic दीजिए, सरवलकर सर. Mic वाले इधर ही रहिए please. थोड़ा सा जल्दी आ जाइए.
Hello. Your presentation was good.
Thank you, sir.
I would like to know the exact, we can say quantitative or qualitative, rather quantitative percentage of apatite and related minerals which can host RE, first thing, and what is the economics of it if we go for extraction?
Sir, actually we are running out of these elements, so we are focusing on extracting the low grade ores also.
But what is the grade that exactly I am asking?
If we talk in terms of ppm, then in apatite the RE concentration is up to 1.48. Yes.
So it's quite low that way.
Yes, sir.
Quite low. Second thing, it's my suggestion, because you are working in West Bengal. In Bakreshwar area, we are already getting hydrothermal mineralization and hydrothermal deposits. So it's better to concentrate in that area rather than what you are working in present. That is what I feel personally.
Okay, thank you, sir. Sir, actually this is a part of my research only.
Now you can shift over the research to other area.
Okay, thank you, sir, for your suggestions.
Thank you. We can have one more questions. Okay, thank you, Dr. Ghosh.
Thank you, sir.
Yeah. Can we proceed further? Okay. I think we will go to Shri Avik Ghosh, Senior Geologist, GSI Kolkata. Abhishek Ghosh, sorry, for shear induced lead zinc mineralization in Central Indian Tectonic Zone. नहीं, शक्ति सर तो नहीं आए. शक्ति सर is not available.
Hello. So good evening, one and all. Myself, Abhishek Ghosh, Senior Geologist from Geological Survey of India. And my topic of presentation is shear-induced lead zinc mineralization in Central Indian Tectonic Zone in the western part of Chotanagpur Naisik complex, Central India. This is a product of specialized thematic mapping program in GSI, State Unit Chhattisgarh, Raipur. And in next 10 minutes, I will be covering this brief outline, and that is geological setting, followed by mineralization details, then characterization of breccia, control of mineralization, quantitative analysis, and lastly, interpretation and conclusion. So, this Indian geological map is showing some, in the eastern part, the light brown part is CGC, Chotonagpur Gneissic Complex, and this small black square represents the study area. And in the study area, as you can see, there are two brecciated bodies. These are the brecciated bodies, actually. So, and this is the northwestern brecciated body, and this is the southeastern brecciated body. And the host rock is mostly the younger Monzo granite, which is sheared at many places. The blue dash line is showing the zone of shears. And in this area, ledging mineralization is mostly found along the D4 related southerly dipping brittle shear zone, and mineralization is mostly restricted in the southeastern brecciated body. So this is the brief geology here. So now the mineralization, and the actual mineralization length is 200 meter and width is 25 meter, and both vein and disseminated type of mineralization is there. And the vein type mineralization actually contains more ledging concentration, and mineral paragenesis is galena, sphalerite, then pyrrhotite, chalcopyrite, and bornite. And ledging shows negative correlation here, which is quite rare. This means that since zinc is mostly more soluble than lead, so the lead got precipitated earlier and zinc was still in solution, so that can be one reason for this negative correlation. And the mean value of lead is here 8%, which is somehow due to change of font or something, it has been hidden there. And zinc is 0.3%. So this is the microphotographs and photomicrographs basically. So this is bornite and pyrite and chalcopyrite, and this is galena, and these are the galena disseminations. So now the characterization of the breccia. You can see this is the breccia, and these red arrows indicate the amorphous dark colored patches which are pseudotachylite, and overall the breccia is of proto-cataclysite type. And wall rock fragments you can see, which is zoomed in here. This is a wall rock fragment of chlorite schist. Likewise, there are fragments of granite and amphibolite too. And as per the present scheme of classification of breccia, it is falling within the proto-cataclysite and cataclysite triangle here. And it confirmed that all these features actually confirms that it is a implosive breccia or proto-cataclysite. And now, how the mineralization got controlled there. See, this is one chlorite schist fragment. So in crustal domain, this chlorite schist must have formed within the ductile regime. And since it has become brecciated now, so it must move upslope along some discontinuity or something, and it has moved from point 1. This is probable positions from point 1 to point 2, and it forms the first stage of Brexia, that is Brexia 1, Brexia or cataclysite 1. And now if we concentrate on the point 3, we'll see this is the Brexia 1, and these are the fragments, and we are now in the brittle domain of deformation. And if we go in, look in detail, now we'll see that in this rock, this is subgrain, and this is another subgrain, and these serrated grain boundaries are called grain boundary migration. So it happens in the by the process of dynamic recrystallization, and due to this dynamic recrystallization process, it is only possible in the ductile regime of crust. So from the position 2, it has again moved downward through some normal fault activity to ductile domain, and that is why these ductile deformational features like SGR, GBM is overprinting, and ductile growth of grain has overprinted the cataclysite of first generation. Now, again, this whole ensemble got brachiated, and this is the second stage of Brexia, second generation of Brexia, and again the rock body has moved from point 3 to point 4 on the right schematic diagram. And we can see this galena concentration is there within the Brexia 1 and Brexia 2. Both are containing disseminations of galena. Now, if we look at this photomicrograph, then we'll see galena in quartz veins, this long galenas, curvilinear, and these are actually showing drag folds, and these are offset by microfaults. So this cataclysite 2 contains hydrothermal solutions, and in this way, this galena mineralization, galena mineralized quartz vein got dragged and faulted, and this is possible in brittle ductile transitional regime of earth crust. So this is the whole history of journey of the rock body or brachiated body from point 1 to 2, then move downward, point 3 to 4, then 5 in the brittle ductile transitional regime of the earth crust. Now, these all are observational and qualitative data. Since fault brexia is, you cannot measure with any pattern, but the fractal analysis can correlate this with some pattern, and we have done fractal analysis of grain size and fractal analysis of grain boundary roughness, and we have found that this log-log plot of frequency and cluster size and the grain boundary roughness fractal analysis, it has produced the result that these brexia of first generation is having very weak deformational trace, co-seismic brexia stress that is related to earthquake, and intense brachiation. Similarly, brexia 2 is showing traces of ductile deformation, co-seismic brachiation, transitional zone deformation, and intense brachiation. So more or less our qualitative observation matches with the quantitative result. Now we have taken the opportunity of calculating surface energy from the mean grain size. This is the lower limit and upper limit of grain size, and surface energy has been calculated in joule per meter cube, and then we calculated surface area energy. From that we calculated seismic moment, and from that we calculated the paleo earthquake magnitude in Richter scale. Though the brexia 1 we have used the same length and same width, so it is probably will give some not means erroneous result, but brexia 2 is certain, and it can be seen that a 5.32 to 6.04 magnitude earthquake, paleo earthquake, was there, which has generated such breccia. And now we tried to find, see, we have got some mineralization, traces of mineralization, but we have tried to draw some pattern. The crux of this knowledge, we want to apply other breccias also for calculating that mineral potential. So for that, from the 8 type of breccia, it falls within the corrosive wear dissolution breccia, and control of mineralization says that this cataclysite 2 is containing the lead galena disseminations and veins both, while the cataclysite 1 contains only disseminations, and this cataclysite 2 is actually containing the major mineralization part here. And again, the DR means roughness fractal value, and DS means grain size fractal value. This mutual plot is showing that corrosive wear nature of breccia is mostly fertile. So the conclusion is implosive breccia or cataclysite may be fertile. Second is that reactivated fault with multiple seismicity has also increased or added on something. And then corrosive wear type faulting with dissolution and hydrothermal solution has actually increased the fertility of this breccia or cataclysite for sulfide mineralization. Thank you.
Thank you, Abhishek, for a detailed structural study. We can have one question. Yeah, everyone is mesmerized, but I have one question. If you put it in the mineral system, you are focusing on the pathway and the trap. If I see the entire system as such, remember the lecture of Professor Sahu?
Yes, sir.
So where is that source of that metal?
Okay.
And how you bring out this metal to your fracture and then entrap it. So please think over it. It may not be.
Sir, the source is actually on those amphibolites that sulfides were there in amphibolites. So it was scavenging from there, as per, though it is very premature to, means this is just a hunch, and from that granitic system provides a good conduit, and with that that redox potential probably.
This is hypothesis. We need some more lab data.
Yes, sir. Without data, we cannot have any conclusive
Think
evidence.
Over it. Thank
yes,
you.
sir.
Thank you.
Thank you, sir.
Can we have Dr. V.V. Sheshashai here for critical mineral potential of new Proterozoic granites, pegmatites and associated rocks in this saucer metasedimentary belt?
Control.
So 10 minutes.
No, control. Where is the control? Good afternoon, everybody. Respected chairman, co-chairman, dignitaries, senior DDGs, directors, and officers, and all the participants. So I'll be presenting on this topic, critical mineral potentiality of the new Proterozoic granites and associated pegmatites and other rocks also. There are not only granites and pegmatites because it's a huge zone, saucer belt and adjoining area. So other associated rocks in the saucer belt of central India. So this is a regional mineral targeting project. This was the first regional mineral targeting project of State Unit Maharashtra, which I supervised. So there were a lot of objectives in this. So based on the mineral prospectivity maps, because saucer belt is one Proterozoic belt where a lot of work has been done. Lot of work has been done since last 50 years for manganese. Everybody knows about manganese. So apart from manganese, what can we find there? So there was a lot of data on NGCM data was there, mapping data was there, some STM data was there, some geophysical data was there. So my officers, they have integrated all these things, all the available data. Initially, they have carried out the integration work, geological, geochemical, and geophysical, and they have identified some zones where possibly we can find some potential areas for mineralization. So that was the background of the project. So everybody knows about this since morning, what are the critical minerals and all. I just want to to the youngsters, some of the critical minerals are elements which usually do not form minerals on their own. They are usually recovered as byproducts from other like copper and zinc extraction. Well, some of them, they form the minerals on their own. So this is the area, this is the target area, all of you know that there are three actually supracrustal belts in central India. One is the Mahakoshal belt, it is in the north, and the Betul belt, which is already presented, and the Saucer belt, which is in the southern part of the CITs, and along the contact of the CIS. Now, the Mahakoshal belt and the Betul belt are characterized by volcano-sedimentary sequences, whereas the Saucer belt is a meta-sedimentary sequence. Basically, Saucer belt has arenaceous units, very little of rudaceous. There is argillaceous, meta-argillaceous units, and carbonates. This is the Saucer male stratigraphy, and then there are intrusive granites in Saucer belt. The more important thing, there are neoproterozoic intrusive granites and extensive emplacement of pegmatites. So this is basically the geology of the Saucer belt. It does not have volcanic component in it. It's not a volcano sedimentary sequence. So that is a limitation also. So regional mineral targeting was carried out. So it was an area which was already worked a lot. 3,500 square kilometers was scanned, and then how we have identified some new potential areas, how we applied, and how we succeeded in identifying the potential areas for critical minerals, that is rare earth elements, rare metals, and copper also, copper base metal also along the southern contact of the Saucer belt. That I am going to explain. So this is a huge area covering about almost 3,500 square kilometers, falling in a number of topo sheets. So this is the rectangle which has been delineated. This is our area. This is the targeted area. You can see the here the southern part you have the Amgaon gneiss, and the Tirodi biotite gneiss is this side. And this is a Saucer belt. Most of it is Mansar here, and the yellowish patches are the Chorboli quartzites. The yellowish patches are the Chorboli quartzites, and in the upper part you can see that there is Lohangi, there is marble, the carbonate is the Lohangi marble, and there is a Bichwa marble. Rudaceous components are very less. So everybody knows that most of the manganese mineralization is confined to the Mansar, though manganese is also there in other units, but most of the economically viable manganese is in the Mansar schistose. And then you can see that from the west to east, there are a number of all these pinkish ones are all granites here. You can see that there is a granite here, Guxi granite. There are some granites here near Elusur. There is a granite here. There is granites near Ashti Nakurudungri area, Gobarwahi, Gobitola area, Chikla. So there are a number of granites, a chain of granites, neoproterozoic granites. They are all traversed along an east-west belt along the Saucer belt. And now associated with the granites, there are a lot of pegmatites also. So actually the regional mineral targeting started with an idea that, so one academic institution has reported on the basis of geophysical anomaly, on the geophysical survey, they have reported a possible very huge potential manganese area close to the Ramtek area. So based on that, there was scout drilling also. So to test that anomaly, drilling was done. And what we found is that actually the anomaly was close to the existing mines. So see, there's the old Satak mines here, Beladongri is a mine here. So this is the Kevlapur area where you can see some pegmatite emplacements also. So the first test borehole was done, a very short borehole, to ascertain the potentiality of the geophysical anomaly. So in that borehole, what we got is, we got a lot of pegmatite. we got a lot of pegmatite and the rock was nice actually. It was all soil covered area. Now these pegmatites were around 25 to 30 meters core. They are mica pegmatites. They had potash feldspar also, plagioclase also. And then quartz, they were showing graphic texture, some accessory minerals. So about 25 to 30 meters of pegmatite in 2 boreholes. Surface is all, it is agricultural land. There is virtually no outcrop of any, except the boulders of pegmatites on the surface. So then officers have done sampling. They have sampled the sea erosion and the regolith. So we thought that this is a pegmatite emplacement zone. So a concealed pegmatite emplacement zone. So regolith samples, sea erosion samples have given good results. And then subsequently this has given about, initially about 700 ppm only. And subsequently after this we have recommended for a G3 stage exploration program. So in the G3 stage exploration program they have got very good values. It turned out to be a resource bearing block. That Kevlapur turned out to be a resource bearing block with RERM. So and then you can see the lithologs also here. And similarly another area where already work was done on the pegmatite emplacement zone, along the western part of it, officers have collected the rubbles. Actually what happens if something is concealed, on the surface you get large, huge rubbles will be there, in situ rubbles will be there. And then based on that, they again sampled there, and this also turned up. Here we did, in these areas we did auger drilling. Auger drilling is from the top to the, just to the basement, maybe 10, 12 or maximum 15 meters. So they did the auger drilling. In the regional mineral targeting, it was only test drilling. They were all scout boreholes. So based on the results of the scout boreholes, some of the projects were upgraded to the G3 level, and they have successfully got the resources there. And then as part of our, because this is a regional mineral targeting, so already manganese has been scanned by GSI, MOIL, everybody did lot of work. Wherever we went, already work was done for manganese. So the second thing is, saucer belt has carbonates. There is Lohangi carbonates, there are Bichwa carbonates. And there are certain areas where the intrusive granites are with the contact of the carbonates. So wherever an intrusive granite, whenever it comes to the contact of a carbonate rock, there will be chance to, for a scan, development of a scan. So one particular such area, though we had very little outcrops, so on the surface, minor outcrops of the carbonate and granite contact, and indications of scan we have got. So we sampled there also, this is the Dobitola area. So there were also pegmatites there. So there's a possible scan there. Another test borehole was done there. So there also we have got reasonably good results, almost 915 ppm. And then we intersected a lot of altered zone in that. Quartz biotite rich zone. It appears megascopic, somebody sees that is granite, but actually it's all made of there was a lot of alteration, biotite alteration zone was there. So this because the results were not so encouraging. The previous two we have upgraded to G3 and they have got the resource bearing. This we have not upgraded because the results were almost 915 ppm. Scan was not, but scan is there, but it was not so potential. So now this is a map showing the granites here. You can see in the west there is a Guksi granite. There were some granites here, Asilpani, Gubarwahi, Asti granite, Dobitola granite. So granites, there's, I told you, a chain of granites from west to east, all along parallel to the. So now my next presentation will be again my officer of petrology division. She will be presenting more details about the petrogenetic aspects. Now everybody knows that fertile granites, they are rich in incompatible element, high field strength elements. So naturally the granite, if it is fertile, if it is enriched in high field strength elements, over a period of time the in situ regolith, sewerage and regolith is supposed to have much more enrichment of the RE from the parent granite over it. So here again all the granites we have sampled, the granite host granite and the regolith also. So host granites turned out to be fertile. And then, but the regolith developed over them. Good, in some granites, good regolith was there. So we found as a test, because this is a regional mineral targeting, we have tested the potentiality of one Chikla granite. It's a Chikla granite and we tested it. And then we have drilled 4 auger boreholes, 12 to 15 meters depth. and auger samples almost 0.45% of total RE. So that is another block which we have recommended for G3. So this is that map of the Chikla area. This is the Chikla granite. So how the this is how the we get the we do the auger drilling, and this is how we get the values at different levels. So just above the bedrock, over the sea horizon, the enrichment will be umpteen number of times more than the post granite, which itself is fertile. So 2 mica granite, naturally paraluminous 2 mica granite, muscoid biotite, and heavies were separated. We have the heavies also. Most predominant is the monazite. Xenotime was there, but xenotime was not so dominant. It has been dated also, 976 million years. Monazite dating we have done. Even academic institutions also have dated Neoproterozoic, but this granite we have dated because one of the objective was even geochronology also. So it was 976 million years, and this is a good project which we have recommended for the G3 stage. So another along the northern, almost in the northern part of the, because we have been scanning the saucer belt, and then based on certain basis is the integration of geology, geophysics and geochemistry. On that basis, areas are being scanned. So this is another area where we have got a arsenopyrite bearing zone, very good arsenopyrite bearing zone over 1.2 kilometer length. But however, associated with the arsenopyrite, we did not get much any other gold or any. We got values, but they were not so encouragement. So arsenopyrite, everybody know it indicates hypothermal conditions, but all the time it need not necessarily be associated with gold or any other mineralization. But we could successfully get the arsenopyrite zone. And this one is more important. Almost in the southern contact of the saucer belt with the CIS, Central Indian Shear. So there was a amphibolite. The amphibolite on the surface was highly altered, and then presence of certain sulfide minerals. So it has been sampled. Chalcopyrite was present, primary copper sulfide mineral. And then we got positive results. And then of course in selected areas we did geophysics also. Geophysics also indicated concealed IP anomaly. And then based on the occurrence of chalcopyrite and then occurrence of the positive analysis of copper and IP value, we tried to drill, but somehow the local villagers did not allow because of some other problem. They did not allow. But this is another potential area which we have recommended for. It will be taken up by the state unit again. So this is another finding. So this is the chalcopyrite. This is actually the alteration zone. Quartz carbonate veins were there. Primary chalcopyrite. The sheared amphibolite. Along the sheared amphibolite, there was quartz carbonate veins were there. This is the carbonate. You can see the carbonate here. This is the quartz. This is the chalcopyrite. You can see a photomicrograph of the zone there. So this is another finding. Yeah. So this is how regional mineral targeting was done. Actually, there were more recommendations. I am only showing 7. Out of 7, 2 projects were taken for G3, and both turned out to be resource-bearing reports. Maharashtra has already submitted, and then another 5 they will be taken for a G4. The point is, this is a first project in Maharashtra regional mineral targeting. Saucer belt, lot of work was done last 50 years. So based on the integrated studies, zones were identified, and then not for manganese, other minerals. So the target was the granites, intrusive granites, the pegmatites, and also the contact areas of the north and south of the saucer belt. So successfully we could get 7 recommendations we could get, and then further work is being already carried out. 2 G3s have been completed, and then another 4 they are going to take up for the G4 stage of investigation from regional mineral targeting. So this is a summary, sir. So thank you, sir. Thank you very much.
Thank you, Shashai sir. We'll take questions after presentation by Neelashri, because it is a follow-up. As you have mentioned, it is a
She will be presenting.
So we'll take questions together.
Okay, I'll answer.
Can we have Neelashri Roy Chaudhary here?
Thank you.
Thank you, sir. Neelashri will be presenting on RE bearing NYF8 type pegmatites from Proterozoic saucer fold belt, Central India. please go ahead.
A very good afternoon to one and all. Myself Nilashri Rai Chaudhary, Senior Geologist from GSICR Nagpur, and my topic of presentation is RE bearing NYF A type of pegmatites from Proterozoic saucer fold belt, Central India, implications for source and emplacement characteristics. In the previous presentation, Sheshasai sir has already mentioned that saucer fold belt has immense potentiality for RE-RM mineralization. My current study is an attempt towards the mineral system to study all the geological proxies to understand the RE-bearing pegmatite mineral systems within the saucer fold belt, which is an important tectonic segment within the CITZ. Precambrian crust of central region is comprising of at northern part Bundelkhand Craton and at the southern part the Basta Craton, which is stitched together along an zone of accretion named as CITZ, that is Central Indian Tectonic Zone. And at the northern part, the CITZ is delineated by Son Narmada North Fault, and at the southern part it is delineated by Central Indian Suture. From north to south, there are Mahakoshal, Betul and saucer group of supracrustal belts with different metamorphic grades are occurring within the gneissic basements, along with some syn kinematic and post kinematic intrusive plutons are seen in this region. And saucer mobile belt is occurring at the southern part of CITZ. Saucer fold belt or mobile belt is the ensemble of two lithotectonic assemblage. One is the basement Tirodi biotized gneiss and another is the metasediments of saucer group. Metasediments of saucer group has undergone polyphase deformation and metamorphism up to the great green schist to upper amphibolite facies. And TBGs are basically the gneissic complex with some mafic and felsic granulites. Two phases of granitic intrusion are also seen in the saucer fold belt, asyntectonic foliated granites and the post-tectonic massive granites. Both are those granites are dated Neo-Proterozoic 945 to 928 MA by Chattopadhyay et al. 2015. And as we see, these star marks are the locales of those pegmatites which are very near to the vicinity of those intrusive both massive and foliated granites. So foliated granites are showing the foliation parallel to the S2 regional foliation within the metasediments, and massive granites are massive, showing no clue of foliation, and at different localities it is also incorporating cutoff patches and xenoliths of TBGs and saucer group within it, showing its post-intrusive nature. Pegmatites, which is occurring at the northeastern part of the saucer fold belt within the foliated granites, which is known as the Lamta granite. Here the pegmatites are basically following the foliation trend of the granite as well as the trend of fracture planes. Both zoned and unzoned varieties are seen in this location. As we can see in this picture, the zoned pegmatites is milky quartz and sodic feldspar at the core, and surrounded by the tourmaline mica and sodic feldspar at the rim part. Whereas unzoned pegmatite varieties are showing random orientations of tourmaline, sodic feldspar, mica, quartz and garnet. And at the southern, now coming to the southwestern part of the saucer belt near the Deolapar area, it is again occurring within the foliated granite. Here the pegmatites are partially zoned, showing milky quartz at the core with beryl and garnets at the rim part. And at the central part, these pegmatites are again occurring within the foliated granite, showing feeble zoning pattern defined by the mineralogical assemblage K feldspar, sodic feldspar, mica books and tourmaline. And at the central part also, pegmatites are occurring within the TBG gneisses, where it is following the foliation trend of TBG gneisses, and it is a distinct zone pegmatites showing the upper wall zone and lower wall zone with a core. under microscope, foliated granites are showing the deformation evidences in the form of undulose extinction within the quartz and deformation bands. And whereas in the massive granites are basically showing the interlocking hipidiomorphic granular texture with no clue of and traces of foliations within it. TBGs are showing alternated mafic and felsic bands defining the definite foliation. And pegmatites under microscope is comprising of garnet, tourmaline, epidote, beryl. XRD result shows the garnet are of almandine composition and tourmaline are of scroll series. Both are defining that these are of magmatic, these are having magmatic hydrothermal source. Same results shows the elemental concentration of yttrium phosphate and cerium lanthanum neodymium phosphate. Further, EPMS study confirmed the presence of xenotime and monazite within the pegmatites. Geochemistry shows that the granites and host granites and pegmatites are both falling in the granite field, and host granites are having paraluminous, ferroan and calc-alkaline nature, and it is also saying that pegmatites are falling in the paraluminous field, that is defining that pegmatites are the derivative of those host granite. And in this plot, Na2O, K2O versus CaO versus SI2 plots show that pegmatites and granites are falling in the overlapping zone of A-type and S-type granites. And this is the plot for characterizing the anorogenic type of granites, which is proposed by Valen in 1987, show that all the granites and pegmatites falling in the anorogenic field, which is further corroborated by the tectonic discrimination diagram, which is showing that this A-type of granite with within plate and syn collisional tectonic setting. Geochemistry of pegmatite shows higher enrichment of LRE over HRE, negative europium anomaly, which is similar to the host granite also, and higher concentration of niobium over tantalum and higher concentration of beryllium also. Fluid inclusion studies shows that samples are from quartz within the pegmatites, which are showing two different types of fluid inclusions, aqueous biphase and monophase carbonic, and they are having homogenization temperature 225 to 300 degrees centigrade, implying that the evolution of those pegmatites from late stage hydrothermal fluid. Now come to the mineral system approach. Mineral system is basically to study different geological proxies to understand the mineralization processes. As I have mentioned in the previous at the beginning, that my current study is an attempt to study the mineral system of saucer mobile belt pegmatites, and in order to do that, the first component is the source component. As we all know that according to this tectonic model, Bastar Craton went down below the Bundelkhand Craton at around 2.2 to 1.8 GA after the model proposed by the Roy and Hanuma Prasad in 2003. And the pre-saucer sedimentation has started at around 1.8 GA, and the saucer orogeny ceased around 0.9 GA. So all the intrusive granites and pegmatites are intruded within the saucer fold belt during the period of 0.95 to later on. And this right hand side model is the schematic model showing that the rare earth element rich residual melts are generated from the pluton, A-type of pluton, undifferentiated A-type of pluton in an extensional anorogenic setting. Next is the two component, the active pathways and the trap. Foliation planes which are within the granites and gneisses and the metasediments within the saucer group, along with the major joint planes within the granites, are basically acting as the conduits to channelize the hydrothermal fluids within the crust. And if the trap component is concerned, elements like beryllium is trapped within the mineral phase of beryl, and xenotime is acting as trap for elements like yttrium, dysprosium, ytterbium, erythium, and monazite is acting as trap for cerium, lanthanum, neodymium, samarium and PR. So finally, the conclusion part, it can be collectively concluded that the NYFA nature of pegmatites within saucer mobile belt, and those pegmatites are originated from evolved residual mills of large differentiating A-type granitic plutons in an extensional tectonic setting. And this hydrothermal fluid enriched in incompatible elements are transported through the existing fracture system and the foliation planes within the granites, TBG, that is the basement gneisses, and the surrounding metasedimentary rocks of saucer group. So, thank you all very much for your patience listening.
Thank you, Neelashri. We can have a couple of questions because this is the study which tries to integrate to mineral system approach. Yeah. Can we have the mic over there, please? Sir.
Neelashri, it was a wonderful presentation. I just wanted to know one point. It's just an observation. The pegmatites have shown that there are, I think, replacement of when a quartz is in dominance in many of the pegmatites. I think they're zoned ones. And there are presence of muscovite mica, presence of over biotite. There are certain you showed. So are there any evidences of grisonization there?
Sorry, sir?
Grison zone, development of any kind of grisons, because these are the indications of grisonization in the pegmatites. And if there are any, then you can look for, I think, tantalum and I think tungsten mineralization will be very important in that aspect.
Yes, sir. Actually, this study is still going on. I'm in the second year of this project. So I will be looking after all the pegmatites, the remaining parts that are left. And definitely I will
Thank you.
Mike, idhar dijiye.
Yeah, presence of tourmaline is extensively presence of, yeah, these are there. See, definitely I will see that.
Mike dijiye idhar, please.
सोनकर साहब
ये वाला दे दो भाई.
मेरा एक सजेशन है एक्चुअली.
Yes, sir, please.
Meena Gupta has worked a lot on beryl-bearing pegmatites in Pench Valley.
Yes, sir.
And along with bearing pegmatites, there were pegmatites which were hosting tourmaline also. And they were found mostly parallel to each other. Though they were located at distances, there was quite a distance between two localities, but overall trend was same. And particularly these beryl-bearing pegmatites, they are hosting other minerals also, but the pegmatite itself is giving low value, whereas the nearby scree, regolith zone and weathered zone, they are giving higher values.
Yes, sir.
Okay. So this particular beryl-bearing pegmatite, not the pegmatite, but surrounding areas where there is regolith or weathered zone, there is one nala also passing by in between. So whatever is the transported material nearby, at least 100 meters or 500, 200 meters, that you should verify and have some analysis, systematic analysis of it, so that it will augment it to the overall RE pattern of that particular area. And maybe it will be afterwards useful for further detailed exploration in context of RE. Beryls are certainly there, and beryl is actually visible, and they are quite large cell. They are even means extractable by hand picking also.
Okay, sir.
Okay.
I will.
Thank you, sir. Thank you, Neelashri.
Thank you.
Now we move on to Eastern Dharwad Craton. Srimati Mrinalili Kond to present RE mineralization in quartz cyanite and associated rocks in Andhra Pradesh, EDC, southern India. No?
There is a sincere request from organizer side, with due respect to every presenter, please restrict yourself within 10 minutes because everybody knows that we are running short of time. So please restrict yourself, your presentations within 10 minutes. Thank you. Thank you very much.
Good afternoon, respected DG sir, our chair and co-chair, all the DDGs, all the senior officers and dignitaries from different organizations. Today I am going to present on the RE mineralization in the quartz cyanide and associated rock in Andepalli area in Andhra Pradesh from southern India. This is the outline of my today's talk. Introduction, then geology of the area and some few field descriptions. Afterwards, methodology, identification of mineralized zone, some highlights, and as we are all searching the RE minerals, so one model for mineral system for RE mineralization. As we all know, these RE and these critical minerals, we have a very gap in between demand and our supply. So in this content, for searching the RE mineralization, one attempt has been made by Geological Survey of India in Andepalli area of southern India. As we all know, the RE is associated with the carbonatite, alkaline rocks, secondary placers, and some iron absorption clay. So, in present study, the significant RE mineralization has been observed in the quartz cyanide, some pegmatites, and some cyanogranite, from the which intruded in the porphyritic granodiorite suit, and some significant RE minerals. RE-bearing minerals has been reported, allanite, monazite, apatite, thorite and rutile, basanite and some zircon. This is the study area which mainly is falling in the eastern part of the Ramagiri Penakacharla schist belt. In the study area, some older metamorphics of the Ramagiri schist belt has been exposed, and some and central part is the part of the PGC2 granite, and some alkali feldspar granite, cyanogranite, monzo granite, and some quartz cyanide and cyanide from the closed plate granite. On the basis of detailed investigation, this area has been identified for RE rich zone, and along with the large scale mapping, detailed mapping has also been carried out on 1:5,000 scale, and all the sample media has samples has been collected from the primary as well as the secondary media. These are the lithologies exposed in the study area, mainly the porphyritic granodiorite, and in this porphyritic granodiorite, pegmatite veins, quartz cyanide veins has been intruded, and intense potassic alteration has been observed in this area, in which the more preferred orientation of and clustering of allanite grains has been reported, and some epitode veins and fluorite also been reported within the porphyritic granite. As I told, along with the primary, the secondary RE to search the secondary dispersion of RE mineralization, different sampling media has been samples has been collected from the trench and soil sample in grid pattern, and out of the 17 PTS from this Andepalle area, maximum 1164 ppm RE, total RE has been reported from PTS, and from the 16 in situ soil regolith samples, 714.2 1100 ppm RE has been reported from regolith sample. These are some petrographic evidences of RE mineralization. Good allanite, big allanite crystals with some apatite zircons has been observed during the petrographic studies from Andepalle area. Along with the geological studies, this radiometric survey has also been carried out in this study area. And during this radiometric survey, we found this uranium and thorium zone is also observed in the Andepalle area. The uranium is around 21 ppm and thorium is nearly 63.84 ppm. During the radiometric survey, K percentage also calculated, and nearly 7% K percent has been observed during the radiometric survey, and which is very well correlated with our alkali feldspar alteration which we have carried out, this study carried out during our pre-field studies. During the same studies, this RE bearing mineral has been mineral phases has been identified. That is apatite, allanite, cesium, thorium, monazite grains, and basanasite veins also has been observed. During the EPMS studies, also the thorium, apatite, monazite, K feldspar alteration. Within the K feldspar alteration has been reported. On the basis of the geochemical characterization, these Andepalle granites are showing the calc-alkali and socionic affinity, and these are mainly ferron in nature and post-collision to late orogenic tectonic setting, and these are mainly the A2 type granites. Now coming to the mineralization, as I told, this area has also been mapped by detailed mapping has been carried out, and this mineralization has been reported within quartzite, and this allanite clustering of allanite has been reported in cyanate with very high potassic alteration. Same as is here, clustering of allanite also been reported from cyanogranite with potash feldspar alteration, and this clustering of the allanite means good allanite clusters has also been reported from the pegmatite zone from Andepalle area. And on the basis of this RE mineral total RE, the total RE is ranges from 0.09% to 60%, and LRE is up to 0.6%, 0.61%, and HRE is deficient, that is only 2 to 4 ppm up to. Now coming to the summary, the mineralized zone has been, RE mineralized zone has been identified within the quartzite, cyanide and pegmatite vein, which is intruded within the porphyritic granodiorite. And extensive potassic alteration and remobilization of RE mineralization has been reported. Apatite, allanite, monazite, thorite, rutile, basanite, these RE bearing mineral phases has been identified during the study. And on the basis of the intense some primary and secondary media sampling, the mineralized zone 1.2 kilometer width strike and width about 0.1 kilometer mineralized zone has been identified in this area. And this geophysical, aerogeophysical and radiometric data is also supporting the mineralized zone. And geochemical analysis of total RE, maximum high percentage of total RE has been reported, 0.63%. And in trench sample and soil sample also elevated RE was reported. And high zirconium value up to 0.73% in cyanogranite, and highest La value also has been reported. Along with this, the niobium up to 235 ppm has also been reported. And based on the field evidences, petrological evidences, geochemical and mineral chemistry, the significant RE zone has been delineated. This study is a typical exhibit of the example for the RE mineralization in the granitic rock from the southern India. Now coming to the mineral system, for Andebale area, in this area the post collision and extensional regions has been identified, and commonly these granites are A type and per-alkaline in intrusion, and the source for the this is the A type granite and per-alkaline granites, and some cyanides are the key host for this mineralization. And fractional crystallization concentrations, concentration RE is residual melt, which enhances the RE mobility in this area. An incompatible element like zircon, niobium and RE concentration is mainly late stage magma in this area. And hydrothermal alterations that I already told, potassic alteration, intense potassic alteration has been reported in this area. And fluid can be transported as a fluoride, chloride and carbonate complexes. And the host minerals are already told, allanite, monazite, fluoride, apatite, and some late accessory minerals also been identified, that basanite. And structural controls, mainly the fractures, joints and shear zones are the main conduit for this mineralization. And with this litho control, alteration zone, geochemistry and geophysical approach, we can generate a mineral prospectivity for different areas, what we have studied in this area. Thank you.
Thank you, madam. We can have one question, only one question from the audience. Okay, thank you, ma'am.
Thank you, sir. Thank you.
Can we have Mahesh Bhase over here for enrichment of critical elements stroke mineral within autochthonous laterite profiles of southern Maharashtra?
Good afternoon, the respected dignitaries present over here and my dear colleagues. I will be presenting the topic on which the enrichment of critical elements, minerals within the lateritic profiles, autochthonous lateritic profiles of southwestern Maharashtra, maybe the possibilities for future resource. First of all, the Deccan Volcanic Province, that is DVP, is hitherto known for being barren of economic minerals. Although PG mineralization and sulfide deposits are known from other similar volcanic provinces are yet to be discovered here. Laterite cappings developed over DVP are known to contain bauxite deposits as well as potential in low-grade iron ore. Southwestern part of Maharashtra is endowed with 4,000 800 square kilometer area of lateritic cover. Lateritic cappings developed over DVP are traditionally classified as highline laterites and lowline laterites. These terms also refer to two distinct laterization events. The plateaus of Western Ghat escarpment zone of southwestern Maharashtra this is the highland laterites, and these are referred as lowline laterites. These plateaus of Western Ghat escarpment zone as well as coastal regions, this part, this yellow dotted spots, that blue hues, they are well preserved and well developed over DVP and Precambrian rocks due to the extreme leaching of basaltic rocks and Precambrian rocks under tropical conditions. This is the status map of southwestern part of Maharashtra. You can clearly see the lateritic cappings developed over basalts, mostly in the northern part. In southern part, it is developed over Precambrian rocks like schists, shales, etc. Since 1960 to 2010, GSI carried out number of G4 to G2 stage of exploration projects exclusively for bauxite. Since 2019 onwards, GSI CR Pune carried out a number of G4 projects, not only for bauxite but also aim to focusing on the critical minerals like gallium, vanadium, chromium, cobalt, and Re, etc. Also, these laterites are regarded as iron and alumina rich residual rocks. Little is known about the distribution and enrichment pattern of these critical minerals like gallium, vanadium, Res, cobalt, and chromium. We have carried out in year 2020-24, GSI Pune has carried out one mission to a research project that is over to 2,400 square kilometer area. 100 profile sections were studied, 14 borers were also drilled, and based on the analytical results of these samples which were collected across the this vertical section, and based on that we are classified these lateritic rocks that present within the vertical section of lateritic profiles. Say for example, laterite residuum, which comprises aluminous laterite, ferruginous laterite, and bauxite, followed by the mottled zone, and the lower part, that is a softer zone, that is the clay zone, that is saprolitic zone, and below which it is a protolith, basically a basaltic rock. These three ferruginous laterite, bauxite, and aluminous laterite, that is grouped into lateritic residuum, that is the hard part. If you see in the field, the soft part is basically a clay zone, that is kaolinite clay zone, and the transition zone between the laterite residuum and mottled zone is a between the saprolite zone and the laterite residuum is a mottled zone. The critical elements are distributed from bottom to top, but they are enriched in a particular zone. This is the one go section of this lateritic profile. You can clearly see this is the query section of basalt, over which we can see the thick lateritic profile. This is the another section. Even lateritic queries also were sampled from lateritic queries where they have stopped querying at the soft zone, and this is the potential zone for gallium, chromium, cobalt, and vanadium. We have collected samples from road cut section also from the lateritic residuum, even from the open dugwell sections. This is the photograph of the ferruginous laterite, which is potential for cobalt, chromium, vanadium, gallium. This is the vermiform laterite, that is aluminous laterite. Again, this is the typical bauxite. Here you can, the enrichment of gallium is much more compared to the ferruginous laterite and aluminous laterite. This lithomarge zone, basically we do get the elevated concentration of Re. Suppose if it is 100 ppm in basalt, then we will get around 300 ppm in this saprolite zone, the lithomarge zone, the lower part of this lithomarge zone. This is the generalized section of the entire this Sindhudurg and Ratnagiri, where you can see the vertical section of the lateritic profile. They show the progression from the unaltered protolith to the indurated vermiform ferruginous laterite. You can clearly see the, I have shown here the enrichments of the particular minerals, say for example, cobalt, vanadium, chromium, and they are associated with the ferruginous laterite, and the in bauxite we do get enriched gallium compared to the other than this aluminous as well as in ferruginous laterite. Here the lower saprolite zone, that is rocky saprolite, the concentration of nickel is twice the concentration of basalt. Suppose it is 100 ppm in basalt, then we do get 225 to 250 ppm of nickel in lower part of saprolite zone. And Rs also we are getting Rs in the lower saprolite zone only. And in the upper part we are getting the enriched concentration of chromium, vanadium, cobalt and gallium. They are classified in ternary plots also. More it is intense bauxitized, lateritized, we are getting the encouraging values of these critical minerals. This is the average chemical composition based on around 700 to 800 these samples, analytical samples. You can clearly see the from bottom to top, from protolith to the altered zone, the vanadium concentration is much higher in the upper part. Gallium is much enriched within the bauxite compared to ferruginous laterite and aluminous laterite. Cobalt, we are getting cobalt that is associated with vanadium within ferruginous laterite. This is the again the generalized section after Widdowson. This is the lithologue of one of the borehole. You can clearly see in the drill hole also we are getting enriched concentration of vanadium in the upper part only, along with chromium and cobalt. And in bauxite we are getting enriched concentration of gallium. And you can see the nickel concentration, where in basalt it is 112 ppm and in saprolite zone it is 213 ppm. This is some photomicrographs. This is everybody knows this. This is the iron oxide, this goethite and hematite textures within laterite. This is the one same. We have carried out same EDX studies. In one sections, we got the concentration of vanadium in one of the spot analysis, that is 1%, along with iron and titanium. Actually, this is all about the RP. Then our objective was to classify the lateritic rocks and to identify the most prolific zones within the lateritic profiles. But कुछ कम लग रहा था कि हमने RP तो कर लिया, आगे क्या? Then we thought कि we formulate one project. In 2023, we formulated one G4 project based on the encouraging values of these critical minerals. And last year also, we proposed 7 G4 stage projects And this year we have proposed 10 G4 stage investigation projects. Altogether 20 projects we have formulated based on this RP atom. This is the output of this RP atom. These are the red boxes that we have proposed this year. This is the outcome of this RP atom.
Please sum up.
I would like to acknowledge Ganvir Sahab. He only insisted me to present this paper over here. And Bhiva sir, he for his continuous support and guidance during the course of field work. And Dr. M.S. Bodas, he was the person who thought this RP, he only formulated this RP atom. So we are thankful to him. And Sri A.K. Singh Saab, he has shown a belief in me to carry out this RP atom. Thank you.
Thank you. We can have one question. Sir, mic please. भाई कहाँ पे माइक वाले चले जाते हैं?
All this sampling you yourself have carried out, or these are previous data also?
I'm not getting, sir.
Whatever data you have presented here, is it a previous data or you have carried out the sampling?
This is based on the samplings which I have carried out, sir.
Yourself?
Yeah, yeah. Around 1,000 samples we have carried out. We have collected from these laterite sections as well as from the core samples.
So my suggestion is, no doubt maybe you might have covered it partly also. There is a GCM carried out in this area, Sindhudurg area and Ratnagiri area. And during the GCM we have found at least 4 to 5 quarters enriched in vanadium and enriched in PG. So you consider the GCM previous GCM map also of this area, 47 I think, I don't know, H or something, these are
47H, sir.
2 or 3 deposits are there. And that will add to your whatever present data is there, that will add to your overall data. And you can refine your further present interpretation.
Okay.
Thank you, sir. So I'll request Joshi sir to sum up. Thank you, Mahesh.
On hai. Good afternoon to all. The technical session 2 was basically for geological framework conducive of host critical mineral deposits and devoted to mineral system. Mineral system, as you know, is the whole guidance towards how to proceed for a mineral search. So in this section, 8 papers were presented and 1 keynote was there. In the keynote was given by Dr. P.R. Sahu. That was how to proceed for mineral exploration. He has very nicely presented it from where the mineral fluid comes, how the metallogeny takes place, how they migrate fluid, and how they ultimately deposit at the trap. So the whole gamut of geological exploration is from trap to source or from source to trap. Whichever is available with us, we go accordingly. So then we had discussion on tectonic setting, how they affect the RE concentration or any mineral concentration.
RE concentration or critical mineral concentration is a part of that mineral search. So we have to see those mineral systems which are responsible for critical mineral. At the same time, we search for other minerals too. So there were petrological studies in 3 cases. So that knowledge is ultimately to be converted into mineral exploration studies. So that is the whole thing. Towards the last 2 papers, it was the secondary enrichment that worked, that was presented in his paper. Mahesh Vaisya has narrated how the bauxite profile and which part of the laterite profile is fertile for search of gallium, vanadium, cobalt, chromium and Re. So this is all I want to say. Basic is we have to apply all these knowledges where the research has been done towards the mineral system development and their exploration. Thank you.
Thank you, Joshi sir. I just want to add on what Joshi sir has said. This concept of mineral system was first proposed in 1994. It was accepted around 2008, and scientists all over the world, especially the Australian scientists, they have started applying in 2010, and now they are finding 1 or 2 success story they have. They have an iron adsorbed deposit discovered in Western Australia. So in India also, probably we have taken a positive step towards having a conceptual model integrating all the data that we have, whether it is geophysics, petrology, structure, as has been discussed today. And I am very hopeful that with our scientists putting their best foot forward, we'll come up with better conceptual model, and that will help us in targeting critical minerals that will power our green energy transition by 2050 or 2070, so to say. Thank you.
Well, we have reached to the end of this technical session, and it's time to express our heartfelt gratitude towards our esteemed chairman, co-chairman, and the speakers. May I now take the privilege of inviting our patron, Shri Asit Saha, Director General, Geological Survey of India, to kindly come forward and felicitate our esteemed delegates. I also invite on dais Shri S.R. Bashir, DG and convener of the conference, to join us on the dais. First of all, I invite Shri Rajesh Joshi, DG GSI Central Region, to please come forward. Ladies and gentlemen, a big round of applause for the chairman of the session, Shri Rajesh Joshi, sir. Next, I invite our co-chairman, Dr. Bibas Sen sir, DG SU Maharashtra Pune. I expect again a big round of applause for Bibas Sen sir. Thank you so much. Thank you, sirs, for your presence here. The next, I invite on dais Dr. P.R. Sahu, our keynote speaker of the session. Ms. Shibani Kumari Naik, Geologist, GSI Bhopal. Dr. S.K. Dwivedi, Director, GSI Jaipur. Ms. Riya Ghosh, Assistant Professor, Durgapur. Shri Abhishek Ghosh, Senior Geologist, GSI Kolkata. तालियां थोड़ी कम पड़ रही है, मैं सभी से रिक्वेस्ट करती हूँ कि जोरदार तालियों से हमारे डेलीगेट स्पीकर्स का स्वागत कीजिए प्लीज. नेक्स्ट I invite on dais Dr. V.V. Seshasai, Director, GSA Nagpur. Sir, I think a tea break is very much needed. Ms. Nilashri Rai Chaudhary, Senior Geologist, GSI Nagpur. Ms. Mrinalini Khond, Senior Geologist, GSI Nagpur. Shri Mahesh Bhaise, Director, State Unit Maharashtra, Pune. Yes, sir. Yes, sir. The technical session 2 is over, and with this we'll take a short tea break of 10 minutes. I request all of you to reassemble in the conference hall at the earliest so that we can begin our next technical session 3. Thank you all.
ये उसका बैच में वो आना है.
Yes, you are
Sir,
audible.
am I audible and visible?
Yeah, audible and visible, very clear.
Okay, thank you, sir.
I request all the delegates to kindly be seated. We'll be starting the third session shortly. Once again, a very warm welcome to the distinguished gathering in the third and the last technical session of the conference, themed Geophysical Exploration Strategies Employed for Various Deposit Types. The integration of geophysical and geological data plays a critical role. Hello, is it okay? The integration of geophysical and geological data plays a critical role in predicting the mineralization prospect and at the same time substantially reduces the drilling cost, providing a new orientation and advancement to the exploration strategy for deeper concealed deposits. For more meaningful and detailed deliberations on this subject, we have an impressive lineup of researchers amongst us who will be sharing their research endeavors shortly. So now I would like to apprise the audience with the chairman and the co-chairman of this technical session. So please welcome with a big round of applause the chairman, Sri Lalit Mohan Singh Mora, Deputy Director General and Regional Mission Head 2, with additional charge of Regional Mission Head 3 also in GSI Western Region, Jaipur. Mora sir, after completion of his post-graduation from Kumaon University, Nainital, joined GSI in May 1994. For the past 3 decades, he has been engaged in geological mapping and mineral exploration, mainly for base metal and gold, during his tenure in State Unit Rajasthan, Sikkim, and Madhya Pradesh. Currently, he is overseeing nearly 93 geological and mineral investigation and research projects, including DSRT-MT survey in collaboration with NGRI. Now, this DSRT-MT survey is expected to have a significant implication for mineral resource mapping and potential extraction avenues in the states of Rajasthan and Madhya Pradesh. We welcome you, sir. Now, I request all of you to join your hands together and extend a cordial welcome to the co-chairman of the technical session, Shri Kalol Kumar Behra, Deputy Director General and RMH2, Geological Survey of India, Central Region, Nagpur. Behra sir is a postgraduate in geology from Utkal University, Bhubaneswar. After joining GSI in the year 2000, he has worked extensively in the Aravalis and the North Delhi Fault Belt with special emphasis on structure and base metal mineralization. He has reported a number of blocks with copper mineralization in Delhi supergroup of rocks, in Daribatoda, Neem Ka Thana areas of Sikar district, Rajasthan, wherein exploration for base metal has continued over a decade. During his posting at State Unit Orissa, Bhubaneswar, he steered finding a newly established Daspala graphite belt, a major graphite belt in the greenfield area in Eastern Ghats Mobile Belt, Orissa, and he was also instrumental in finding Nayagarh ultramafic alkaline carbonatite complex with RE association in the Eastern Ghats Mobile Belt, which is another greenfield prospect for RE. In both the areas, exploration is going on at present. I extend a gracious welcome to the chairman and the co-chairman of this session. So, as the keynote speaker of this technical session, we are privileged to have with us Professor Shaliwahan, Director, Indian Institute of Petroleum and Energy, Visakhapatnam. Now, he has not been able to make his presence physically in today's who is a brilliant mix of academic excellence with managerial capabilities. His research interests involve optimization of geophysical data sets using swarm intelligence, tectonics, mineral exploration, and petrophysics. Professor Shaliwahan has made a significant contribution in the interpretation of resistivity, induced polarization, self-potential, electromagnetic, magnetic, and gravity methods. His contributions in magnetotellurics characterizing the deeper crustal structure are examples of outstanding academic work. He has several national and international awards and honors to his credit. He was conferred the Boyce Cast Fellowship by the Department of Science and Technology. He is a National Geoscience Award recipient of the year 2010. He was also bestowed with Outstanding Educator Award in the year 2020 by the Society of Exploration Geophysicists USA. And also, he was a recipient of INSA Best Teacher Award in 2021. Again, he was also a visiting professor at Colorado School of Mines, USA in 2012. And some of the major assignments at national level include that he's an expert member at DST. He is a member of the APEX Exploration and Research Advisory Committee of AMD. He has also co-authored a book titled Geoelectric Methods, Theory and Applications. So, Sir will be enlightening us with his scientific findings, which are extremely relevant for the technical session 3, that is geophysical exploration strategies employed for various deposit types. Now over to Professor Shaliwahan for his keynote address. Sir, please.
से बोलता हूँ क्या अनम्यूट किया am I audible
Yes sir, you are audible. You can start now.
Professor Sullivan sir, we are audible now, please.
Hello?
I'm audible, sir.
Yes, yes, you are audible.
Sir, you are unmute. You are mute, sir.
Unmute करो यार इसको. You are audible, sir. Sullivan sir, you are audible.
Okay, again, thank you.
Okay, please go ahead.
So, good evening, my dear friends. Thank you, my friend Bashir, for giving me an opportunity to talk today. But unfortunately,
Hello, sir.
I could not be physically present.
Sir, there is a echo effect, sir.
The place.
Hello, Sullivan, sir. Sir, you have an echo effect, sir, in your sound. I don't know. Perhaps you have kept two systems over there.
Professor Salivan? Hello? Professor Salivan?
To wait for such a long time. So, I'll be talking on some three techniques, which is basically your magnetotelluric, seismic, and petrophysics. And I'll be talking with respect to VMS settings, graphite deposit, and all. So the magnetotelluric measurement which talks about is that it tries to measure the Earth's natural electric field and magnetic field, and then it is translated to impedance, and from there we try to get apparent resistivity and the true resistivity. It's used for, it's a natural source method for deep concealed deposits. It's really good and very sensitive to conductivity contrast. Seismic method, yes, provides high resolution information, lithological layering, structural traps and alteration zones, and then what happens that we try to integrate all the three, the magnetotelluric, seismic, and petrophysics is a new concept which is being used in mineral exploration, where one tries to measure the properties, physical properties on the course, and enhance subsurface characterization, reducing exploration risk, and improving targeting accuracy. So, I told that I'll be talking basically with respect to VMS deposits and graphite deposits. So, VMS, as everyone knows, host critical base metals and sometimes gold and all, which often classified strategic minerals. These are associated with hydrothermal systems that produce strong electrical conductive anomalies and are well imaged by magnetotellurics. VMS deposits often lie beneath conductive overburden or altered volcanic sequences. Even you can try to do seismic as well. Graphite is highly conducting zones, often parallel to metamorphic foliation and easily detected using magnetotellurics. Seismic imaging helps delineate thickness, continuity, and structural controls on graphite-bearing units. Both the VMS and the graphitic targets are not only mineral rich, but also offer indirect pathways to RE exploration. And what I will be talking about is, I will be trying to talk about some of the case studies which talks about VMS, which talks about petrophysics. This VMS and petrophysics, I'll be referring to the Hanjori and the Dharma volcanics results. I'll be talking about the unconformity deposit of uranium, Athabasca Basin, and then a case history over the RE with MT and seismic. So if you look at it, so Dharma volcanics is the plume-related tectonism, and probably that's the cause for VMS setting. And geophysically, if you look at it, there are 4 factors which contributes to these which can help in detecting this massive sulfide: a high conductivity, isolated from lithologic conductors, and to be of limited strike length, and a magnetic association. So for a VMS settings, you should have electrical signatures which is very effective. This could be of 20 orders, significant EM gravimetric and magnetic response, and a radiometric and seismic. So these contributes to the VMS settings. You can identify them. So I'm talking about this area of the Alma volcanics. So a part of this area had a gravity survey which talks about a high gravity anomaly over the Dharma volcanics. An empty survey was carried out over this transect right from Dhanbad to Badam Pahar, and then it talked about resistive upper crust, and from this we could identify some zones which I'll discuss now. Okay, this area has a high magnetic, this is aeromagnetic data, and this is an amplitude analytical signal, so this area has a high magnetic anomaly. So first of all, let me talk about the empty results. So basically we had taken a profile which was about 215 kilometers. I'm showing a part of this profile which crosses the Dharma wall. This is the Dharma volcanics, and there are some gold deposits in this area. So this is the transect which we are talking about. So this area showed about the 2D structure, and it talked about the geological strike of north 60 degree west. I'll only show you the results. If you talk about the results, of this area, what has happened basically that you can see that there are 3 conductors have been identified. This part goes to this Chota Nagpur gneissic complex, and this goes to Singhbhum granite. These 3 conductors are identified. And then we wanted to plot, we have plotted a sensitivity plot and tried to see that which is a very robust structure out of this C1, C2 and C3. Okay, this structure and these 2 we are not bothered as of now because probably this is at the edge and then maybe an artifact. So it's out of the C1, C2, C3, which are the structure which is quite robust. And if you try to see a sensitivity plot, it talks about this zone where it looks to be a more robust feature as compared to these 2. Why this has been done, I'll discuss later on. And also in this area, you can see a high Bouguer anomaly map. And why I discuss this feature which is more robust, because on this basis, we carried out a detailed magnetotelluric survey over this very conductor to see the extent of the conductor. It develops at what depth and up to what depth it goes. So this is the area which I'm talking about. The detailed survey was carried out here. You can see this is the conductor, we talked about it, and this was the data spacing and the profile length. About 30 soundings were taken in this area. And this area we had seen that when we carried out the geological strike, so this is okay, similar to the previous one, it was not 60 degree west, but there was local conductors were present which were showing a different orientation and which were aligned to the Dharma volcanics. And if you're trying to see the 2D inversion results along these various sections, what happens that you are getting the conductors, you are getting 4 different lithologs, basically. One is from 1 to 10 ohm meters, or less than 10 ohm meters, 1 to 10 ohm meters, 10 to 100 and 100 to 1000 ohm meters. And the 1000 ohm meters is basically talking more of intrusives. The mineralization is in the upper Dharma volcanics and so on. And if it, then we try to have a depth slices on this. And if you try to see this body starts developing very nicely at around 50 meters, the red is the conductor which you're talking about, and it is fairly developed at 100 meters, and then up to 200 meters or so you can think that it is fairly developed. So it extends from say about 50 meters to 200 meters or so. And we carried out from a pit, we took some samples and we carried out some ICPS studies which also talked about different forms of mineralization: gold, silver, uranium, copper, lead and zinc. So so depth slices shows from 10 meters to 50 meters. The body is well developed at 100 meters. All geological structures intrusives, upper Dharma groups, lower Dharma and Singhbhum metapolites are mapped. So the inference of the metallurgy is that all the 4 criteria for ideal massive sulfide target, such as the Pransky, it shows a high conductivity zone, isolated lithologic conductors, unlimited strike length, and then magnetic oscillation. So this is talking about a setting of massive sulfide. But this high gravity and high radiometry was also reported, which is also associated with this. So this zone has an impression of volcanologic massive sulfide or a volcano-hosted gold deposits. This is another results which I want to talk to you, which is petrophysical characterization. Basically what we do that we have a core sample and we try to measure the physical properties, talk about your density, talk about your susceptibility, talk about your chargeability, talk about the conductivity and all. And what we do basically that this is a standard density plot. We try to plot those data on these things. And if you try to see that what it talks about when there is a separation is there, so what happens? The density decreases and the susceptibility increases. When you talk about metamorphism, the density almost remains same, whereas the susceptibility increases. So amphibolites to granulite and the paramagnetic terrain goes to magnetic terrain for a separation. We try to plot these, and these are the results of the Danjori volcanics. And we are getting a low susceptibility and high density, talk about low-grade metamorphosis, which corresponds to the geological stratigraphy of the area. Host rocks, is we talk about low degree of serpentination, and this is similar to Abiti subprovince. Then what we did was we had a plot where we wanted to plot a percentage magnetite, percentage host rock, and density. So with the sample what we got, we plotted the value of the density and the susceptibility, and then this talked about that what could be the percentage of hematite plus sulfide or a magnetite or a barren host rock, and this comes out to be that the magnetite is very less, host rock is about 78%, whereas and the hematite plus sulfide is 20%. So this is the line of a 20% or so. So basically what it talks about, yes, you can talk about there is a melanation which is probably with hematite plus sulfide, but the problem here is that you cannot distinguish between whether it is hematite dominated or a sulfide dominated. And for this what we did, we went for your BGT plot. We went for a BGT plot which is bulk, grain and texture plot. And what it was done that on a ternary plot, susceptibility was plotted, chargeability was then done. We know that density is a bulk property, whereas susceptibility is a grain property and chargeability is a texture plus grain property. And when we plotted this, so now what is happening, we are able to distinguish between whether it is hematite dominated or a sulfide dominated, because chargeability is pretty high here. So basically this we talked about it as a high charge suggests that it is a disseminated sulfide. Now the gold bearing sulfide mineralization in the study area is controlled by texture and grain properties. Low susceptibility and high density suggests the study area to be low grade screen cyst metamorphic facies. And yes, we talked about Henkel plot, which talks about low degree of serpentination. So what we have seen basically that from geophysics you can get an idea about the VMS setting, and also if you measure the physical property of the cores, then you can talk about serpentination or which mineralization is dominated by texture or grain or whatever it may be. Let me take an example from uranium exploration, a case study from MacArthur, Saskatchewan, Canada. This is a paper published by Tunser and his group in 2006 in geophysics. This is a basement which is pretty resistive of 10,000 nanometer. A fault is there which is pretty conducting, and they call it a graphitic fault because of the conductor what it has. And this is basically an unconformity type uranium deposit in the, and here is the uranium ore deposit. If you try to see this is the fault which we are talking about, this P2 fault. This is the area where they are already having a map, mines, uranium mines, and there are a lot of data were taken perpendicular to this fault. And this from 271 to 276, if you try to see, this is basically an area where mining is being carried out. Okay, I'll come to this slide. This is very interesting. If you try to see this is a P2 fault, and if you try to see that this is at about 2 kilometers, and if you try, just a minute, if you try to see this, it starts developing at 550 meters or so. And if you try to see this, what's happening, it goes up to 2 kilometers and then it develops at 550 meters or so. Interesting part, what is to be seen here is that at this part, the conductor looks to be pretty low because this area is having a mining area. So the data quality was not that strong. But other thing which comes up is that you see there is another conductor developing here, which was not mapped earlier, right? Which was not mapped earlier. So this is what we're talking. The second stronger conductor could be another graphitic fault northwest of the main conductor T2 reverse fault. So this was the conductor which was not there mapped earlier, so which is being mapped, and here as you can see with your, what is that called, with MT you are able to map this uranite deposit, what's here. Okay, now coming to my last one, which is basically an audiometric view, and here I'm taking an example from China, where they have tried to take both the MT and the seismic. Now this is a regional MT line. This is a regional MT line, you can see this. And this is a regional seismic line. And this in small area, they have got some dense MT profile. These are 8 in number. If you try to see the results, okay, if you try to see the results, these are some of the results what they have mapped about it. And if you try to see this, interesting part, if you try to see this, some codes were available and they did the measurement on the codes, measure the petrophysical properties, and if you try to see this part, this K is basically the laterite layer which looks to be conducting. Then you have an RD, which is basically RE dominant dolomite, looks to be a bit resistive. Okay. Then you have a slate here, again conducting, again RD, and then you have a slate here. So if you try to see these, the results are pretty well matching with expected geological deposits. Similarly, that was done in another area, and you can again see here that this is pretty resistive, this is resistive, and this part is your slate, and this again resistive. Again, they did in the same area some different lines, and they wanted to show that this dolomite is pretty resistive, which has been mapped very nicely here. Now, if you try to see this area, entire area, it has been divided into 3 basic domains: D1, D2, and D3. D3, yes, looks to be pretty conducting. Okay, D1 is highly resistive, and D2 is also resistive, right? But here you see a very interesting thing, a slope in terms of the resistivity, right from an offset of 6,000 meters to about 8,000, 8,500 meters or so. You can just see this one. Highly variable resistive signatures it contains. The giant ore deposits, it is named a transition belt, which ends up ore-bearing geological unit. From south to north, the resistivity strata varies from high to low. You can just see this. This part is pretty resistive, and as you start moving this northern area, it becomes pretty conducting. So high resistive block float on the conducting one. Okay. A nearly upright, very low resistivity belt developed along offsets this part. If it, this is a plot which tries to see the trend from south to north, how it happens. This is the one. If you try to see this, these sections feature similar geological structures, more or less similar geological structures. The south portion is characterized as a resistive part, and the northern part looks to be conducting. And here, if you try to see, there is an intrusion is there of a resistive part. So from this line, if you try to go line 300, if you try to go to line from 300 to line 335, the resistive geological body goes up from deep to shallow and depth. From south to north, it goes down sharply. And this structure, what they name it, looks like a Y shape. It looks like a Y shape structure. So that is because they call it Y shape structure line 335. I will try to compare this with a seismic section. These are the last 2 slides. I'll try to compare with seismic section. If you try to see this, this is one reflector R1 within D2. And I'll take you back to D2. Just keep in mind this D2. D2 is highly conducting. Just keep in mind. D3 is highly resistive, and where you see a slope, D3 you see a slope, D1 is highly resistive. Now, they have picked up two very interesting reflectors. There are three reflectors. One is in D2, which is R1. In D3 also they have got R2, and D1 they have got R3. So the reflection R1 has a good correlation with the conducting layer. So this, you know that D2 is highly conducting, so you are getting a very good correlation. Reflection R2 is correlated with the highest resistivity portion. This one, right? And this was the slope which I'm talking about, okay, of L01 bottom boundary strata over body generated by previous geological activities. Now the results of this is what we call petrophysical, they call it rock physical study, that the quartzite and granite have very high resistivity and ore-bearing carbonate feature medium to high resistivity or even high resistivity. The bottom part of this resistive body is speculated as being quartzite. The upper part with medium to high resistivity is speculated as being ore-bearing carbonatite. The northern part of the section with alternating high and low is correlated with the alternating quartzite, limestone or slate. The high resistivity cliff dipping reflects the quartzite, dolomite and limestone. The low resistivity cliff dipping geological layer in the transition D3 is interpreted as there's a fault is there, which they talk of the Congo fault where you see the dipping happening. This is the last slide and a very interesting slide. This is basically the structure which we are talking about. You can just see in the C3. Right. This C3 coincides beautifully with the conductor C3, which is in the D3. You can just see this. Right. So the high resistivity RE1 at a depth, very depth, has a resistivity we have seen is about 1500 or so 1000 ohmmeters. Two resistivity anomalies, the C1 and C2 are developed, and then a very low and a large resistivity block is seen here. Okay, it's about 100 ohmmeters or so. Northern part two sections from the depth of center and offset from 1200 meter to north, and some medium to high resistivity anomalies have developed in the domain. The rest of the section has, and it is giving a Y-shaped anomaly. So you can see that the resistivity structure, what has happened, the resistivity structure, what you get here, is fairly matches well with the geological structure which is expected here, and the resistivity structure and the seismic structure matches pretty well. Okay, so based on both the AMT and the geological observations, the mineral system consists 3 domains. We have talked about the domains. In the northern domains come as slate and shale from the rift sedimentary sequence, and a Y-shaped structure is recognized as being the controlling structure for the mineral system, and the bottom portion is speculated as a potential mineral prospect. So these are the examples which I talked about having the MT, the seismic and the petrophysics, which can at least help in identifying the structures and some conducting zones which could later be proven with the geology and the drilling. Thank you.
Can we have some questions?
Yes, yes. Now it's open for discussion and we can have some questions.
एक माइक दे दीजिए सर.
Hello. Professor Salivan, this is Raja Mukhopadhyay from GSI Nagpur. You hear me? Hello.
सर उन तक आवाज नहीं जा रही है शायद अभी.
नहीं जा रहा है?
कनेक्ट कर रहे हैं.
Hello.
Just mute it first.
Hello. Professor Shalivan, you hear me? Hello. Hello.
Sullivan sir. Hello. नहीं, unmute ये है हमारे। सुनाई नहीं दे रहा।
ठीक है, छोड़ दो।
सर वो चैट में लिख देते हैं, नहीं तो चैट में लिख दीजिए।
आगे बढ़ते हैं।
हेलो सलीवन सर।
वहाँ आवाज नहीं जा रही।
नहीं,
नीचे से अनम्यूट भी तो नहीं।
ये तो पता से तो अनम्यूट नहीं दिखा रहा, कुछ क्या पता नहीं। हाँ अभी क्या है? हेलो हेलो।
का जरूरत नहीं है क्या?
हाँ अभी सर। Okay then, we'll move to the next presentation, that is geophysical exploration strategy employed for exploration of the Minjari copper block, Hindalco Industries. Sri Shubham Roy, please. नहीं है क्या?
So now is the time for the technical presentations by the academicians who have gathered here from various parts of India. So the first speaker is Shri Shubham Roy, Manager, Hindalco Industries Limited, and he will be presenting on geophysical exploration strategies employed for the exploration of the Minzari copper block, Hindalco Industries Limited. So please.
Thank you, ma'am. Good evening, all. So it's my honor, and I'm very much privileged to be present here today to discuss about our work regarding the geophysical exploration strategies.
Shubham, please restrict your talk within the given timeline.
Sure.
We are already
the geophysical exploration strategies, and to be specifically the drone magnetic survey for. Is it audible? For the Minjari copper block, and as many of you may be aware that Hindalco is India's leading producer of refined copper. We have a smelter in Birla Copper Dahej, which produces around 0.7 million ton of refined copper per year. And to sustain this production, we require at least 2 to 2.5 million ton of copper concentrate per year. So as of now, we are mainly sourcing these copper concentrates mainly from outside countries like Chile, Peru, Australia, and some other copper producing countries, and as well as from HCl. So, but in order to get raw material security in our long-term future, we have decided to acquire our own copper block and develop those copper assets. So in line with that, we have acquired the Minjari copper block through auction in 2023, and we have been granted the composite license in 2025 April. So this is the location of the block. It is in the Chandapur district of Maharashtra, and the nearest town is Sindewai, which is 6 kilometers northwestern side. So, and the composite license area of the block is 17.5 square kilometer. So in this area, earlier GSI had done exploration in G3 level in 2 square kilometer area, and mostly in the southern part of the block. So these were the instruments which were used in the drone magnetic survey. So firstly, the drone leader survey was conducted with DG1 M350 drone using DJ1 GenMuse L1 leader sensor, and the drone magnetic survey was conducted using Meagaro drone magnetic sensor of geometrics. So the leader data, in case of leader data, the overlapping was 70%, 20%, and flight speed was 10 meter per second, and flight height was approximately 40 meter above ground level. So pre-processing was done in DJ1 Terra, and post-processing was done in Cloud Compare, Global Mapper, and in QGIS software. So these are basically the survey lines and tie lines. So here you can see that there is a change in the direction of the line. It is basically to keep it perpendicular to the quartz vein, which hosts mineralization as per the previous report. So the line azimuth of the survey lines was 90 to 70 and 0 by 160 for cross tie lines, and total area was 17.5 square kilometer, and total 404 line kilometer survey was there. So this was the output of drone leader survey. First DSM was prepared, and after that, after removing the trees and bushes, the DTM was prepared, and the right hand side you can see the leader ortho image. So this is the mainly total magnetic anomaly and IGR corrected magnetic map. So after collecting the magnetic data, the visual inspection was done and spike removal was done, and after that the baseMAX station data was incorporated into the magnetic database. And after that, to account for the spatial and temporal correction, we have applied diurnal correction, and also we have applied the altitude correction. And also, in order to highlight the local anomalies and to reduce the effects of Earth's magnetic anomaly, we have applied IGRF correction on the total magnetic intensity map. And so finally, total magnetic anomaly data is equal to diurnally corrected data minus IGRF for the survey area. And after that, we have done the reduced to pole. After that, we have done the reduced to pole map. Total magnetic intensity values were corrected by reducing it to the pole intensity. And so here we can see that there is a east-west trending zone which is present at the northern side, and there is a north-south trending zone which is present at the central and southern side. So this corresponds. So this indicates that it might have undergone deformation. The low magnetic anomaly zone indicates it might have undergone deformation. So after the derivative maps were prepared, so first order derivative map were prepared to highlight the change in the magnetic intensity in 1 meter. And second order derivative map was prepared in order to reflect the magnetic intensity change per square kilometer. And after that, by superimposing both, we get the general derivative map. And here the white line denotes the sharp changes in the magnetic anomaly. So these are the major findings. So basically the central part low magnetic anomaly zone corresponds to the quartz vein which has been reported to host copper mineralization over there. So this quartz vein can be seen visually in the field, but in the northern part there is a low anomaly zone which is trending towards east-west, which is also due to the presence of quartz vein, but this cannot be found in surface. Basically, this is subsurface quartz vein, and we can also see that there are two magnetic high anomaly zones, which is zone number 5 and 6, which indicates the the presence of any potential seal or dike or iron rich bodies. So after that we have started drilling over there, and the geophysical anomaly map exactly coincides with the drilling results we are getting. So we are getting the mineralization in quartz vein and as well as in the dikes, which is the zone number 5 and 6. So currently we are doing exploration in the southern part of the block, exploration drilling in the southern part of the block, and followed by we will do the further drilling in northern part, and also we will incorporate IP resistivity here. So thank you.
We can take 1 or 2 questions maximum.
Hello.
Yes,
sir. I would like to know the boreholes which are selected over the high anomalies and the bore which you have selected over the low anomalies. What were the assay results, sir, on the basis of that?
Sir, assay results we did not get. We got the composite license in April 2025. We have done the drone magnetic survey in May. So currently we are doing the drilling. We have got analysis result of 2 boreholes. So this coincides with very much with the low magnetic values which we are getting in the quartz band zone. So
Means you are targeting the low anomaly zone, magnetic low anomaly zone, or high magnetic anomaly zone?
we are targeting our first target is low magnetic anomaly zone, because that is due to the presence of quartz, and in that area quartz hosts copper mineralization.
Okay, and at what, it's a vertical borehole or an inclined you are drilling?
It is inclined borehole. Actually, GSI had done borehole in the same section and in first two level, in 60 meter from vertical depth and in 120 meter vertical depth. So in that section, in the same section, we have done deep drilling. One borehole is of 180 meter vertical depth from the surface, and the second borehole is 280 meter vertical depth from the surface. Inclined depth is around 450 meter.
Okay, and everything is in the low anomaly zone?
Everything is in low anomaly zone. In another hole, we got the presence of dike, dolerite dike, which was showing the high anomaly here. So there we have also got copper of around 2 to 3 meters thickness.
Okay, sir. Thank you.
Thank you, sir.
Have you done any inversion or joint inversion?
Yes, we have done inversion. We have done pseudo gravity inversion, Euler correction, everything, but I have not shown it here.
So, do you have gravity data also with you?
No, we did not have. We don't have gravity data. We have done pseudo gravity anomaly. We have done.
Hello, I am Raja Mukhopadhyay.
Yes, sir.
Very nice presentation you have given. I am having some basic doubts. One thing is that you have shown that you have, with the first derivative and the second derivative map, you have combined them to make a generalized map. How you have done that?
Sir, first derivative map is the change to denote the change of magnetic anomaly with respect to change of 1 meter.
No, it is not 1 meter. It can be anything actually. It depends upon what you are using.
Yes,
but you are using first derivative as well as second derivative, and then you have combined the both, which is a little bit doubtful for me. This is the first thing. And second thing is that you have shown that RTP map, whether you have got anything from the RTP, any positive things, whether you have interpreted anything from RTP?
We have basically got, sir, two anomaly zones. One is low anomaly, which is due to presence of quartz, and another is high anomaly, which is due to presence of iron-rich bodies.
No, the thing is that when you are doing RTP in this particular area, wherever you are doing, I think that you don't have any idea about the susceptibility of the older susceptibility. So I think you are using that it is totally a induced one. All the magnetic parameters that is coming, totally induced one. There is no remnants presence over there. I presume you believe with
sorry
that
for
thing
interruption.
actually.
You can discuss individually with
Okay, sorry,
later on.
sorry, sir.
We can move to the next.
Yeah, thank you very much. We will discuss later.
Okay. Thank you.
We are immensely pleased to invite Shri Amardeep Singh, geophysicist, GSI Central Region Nagpur, and he will be delivering a talk on MT-Pros, an innovative Python-based GUI for streamlined 1D and 2D magnetotelluric data processing and inversion. Amardeep, please.
Good evening, everyone. Myself, Amardeep Singh, and the topic of my presentation is MT-Pros. It's a tool that we have developed for, it's a Python-based tool for streamlined 1D and 2D magnetotelluric data processing and inversion. Next slide, please. Yeah. So my co-authors are Priyabrata Mukherjee and Bodhisattva Saha. Next, please. Yeah, what is magnetotelluric method? It's a passive geophysical method that uses natural variations in the Earth's electromagnetic field. It uses natural variations in the Earth's electromagnetic fields and measures the EX, EY component of the electric field and all the three components of the magnetic field. So we generally do not measure the EZ because it's sensitive to noise and it's very weak in nature. That's why we avoid the Z component of the electromagnetic field, electric field. Actually, the impedance tensor is one of the most important thing, and we derive the other relative parts based on that, such as tipper, skew, and other parameters for the processing and interpretation of the magnetotelluric data. And impedance tensor is derived from the electric field and magnetic field vector. Yeah, it is, as I said, it's a passive source method, and it's a non-invasive deep imaging tool. It is effective for mapping subsurface structures, faults, and fluid pathways. It is sensitive to alteration zones associated with mineralization, and where there is high resistivity or conductivity contrast, this method comes into play. And it can, depending on the frequency, it can go very deeper. We use the frequency so as to our means to an end. For low frequency, it can go up to MOHO if we can place the sensors for like 15 to 30 days of observation. We can get the data for MOHO depth also. And it complements the other geophysical methods very well. Yeah. For mineral exploration, base metal exploration where there is sufficient resistivity contrast, as I've said earlier. A biggest example is the nickel copper exploration done by a company in and explored there in Sudbury, Ontario, Canada in the 90s, and it's a proof of concept model. And thereafter many countries and many companies and many organizations has adopted the model for the base metal exploration. And diamond exploration also, mineral MT can detect kimberlite pipes which are often associated with diamond deposits. And geothermal exploration at GSI, must be aware that GSI is also doing geothermal exploration based on MT survey. And hydrocarbon exploration, MT can also be used, as Professor Shalivan said earlier, have shown earlier, that MT and seismic can be combined in hydrocarbon exploration. And in the early stages of exploration, we can derive a model, and MT is much less costly than seismic methods, so that it can be a good preliminary stage exploration for hydrocarbon exploration. And then we can go for the much expensive seismic exploration, as usually the trend in foreign countries nowadays. Yeah, so MT methods can be divided into 3 basic frequency range. The high frequency range, it goes from 1 Hertz to 10,000. Actually, it goes beyond that. In GSI, we are using up to 13.5K, 13,500 Hertz, the instrument which we have got in the central region. And for shallow investigation, just like that I've mentioned earlier, used for geothermal studies and mineral exploration. And it detects the weathered zones, groundwater, and alteration halos. And for intermediate frequency, it lies between 0.01 Hertz to 1 Hertz. And for mid-crustal depth studies. And MT, one major application of MT method is, if we do go for the deeper surveys, we can it can aid in the tectonic settings. It can aid in the study of the tectonic settings of an area of interest, and we can locate major shear zones which are not observable in some areas. We can MT comes into play in that also, as it can go very deep. MT pros. So what our team has done, it's we have tried to develop a tool for processing and inversion of MT data, and what we the module which we have used to design the interface is PYQT, and the 6 is the version actually. And for the backend, we have used the libraries mtpy and scipy library. So it runs as a desktop application like any other. And what it does is a stepwise processing of empty data, and it leads up to the 2D resistivity model based on the 2D Occam's inversion. So it's yeah. So the input module, the input data is basically XYZ file which contains the date, time, and the 5 components, the 2 components of the electric field and 3 components of the magnetic field. Then the data pre-processing. Data pre-processing usually means what we apply some filters on the input file, and we smoothen out the input file, input waveforms of electric and magnetic field by using filtering technique, various filtering techniques. Then what we do, we use the forward fast Fourier transform to change the data into frequency domain from time domain. And with windowing and power and cross spectra, we can get the impedance sensor, tipper, resistivity, and phase, which is the main processing output of our raw data of MT. And the Occam's 2D inversion model gives the 2D resistivity model of the surface. And obviously there, let's go. This is the interface of the tool we have developed. As you can see on the left side, you can see the buttons: input data, data pre-processing, FFT and spectral analysis, the core output. EDI output we have developed, but we are unable to. We haven't done the association of the front and the back end till now, but we will do it in future. Occam's 2D inversion, as you can see on the right hand side, you can see 2 boxes in which you can see the input files and the output files generated. The input files you put and the output files it generates. Okay, the input, you just select the raw empty data series, and the file file contains the date, time, and the magnetic field and the electric field. And what it does, it gives the waveform of all the 5 components. And then we go to the data pre-processing. Data pre-processing, what it does, it detrends the input file, remove the spikes, bandpass filtering, and gives us the plot and also the CSV, the ASCII file of the clean data set or the filtered data sets. So which I already discussed. Rolling means detrending, and the spike removal, bandpass filtering, and you get all the components, pre-processed files. And the FFT and the spectral analysis, what it uses, the Hanning window and median scaling and auto and cross spectra of all the components, and then it computes the FFT to convert it into a time domain data, and it gives the plots and the CSV output files. As we can see, the FFT spectrum of all the components. Here it is auto and cross spectra. Auto and cross spectra means the auto power spectra means the self correlation between the components in the frequency domain, and the cross power spectra means the frequency domain correlation between 2 different signals. Such as for computation of impedance tensor, we do EX HX, EX HY, EY HX, and EY HY. And similarly, tipper is basically vertical magnetic field over horizontal, and therefore it has 2 components, the X direction and the Y direction. You can see here the auto and the cross spectras. It generates the files in PNG format. And the core output modules, it calculates the impedance tensor, tipper, apparent resistivity, and phase, and skew angle for dimensionality check. So it gives all the ASCII files and the plots. You can see the summary plots, which is used in many studies. You can see the tipper arrows for the real and imaginary parts, the phase and the apparent resistivities, the XY and the YX. So OCam's 2D. We have used this OCam's 2D inversion component of the MTPy library. So it is based on the principle that it prefers the simplest model that fits the data. And it is a regularized inversion approach that gives the smooth conductivity model consistent with the observed data. So the input what we gives are the apparent resistivity and phase, the station locations and periods and error estimates. Initial or prior model we set, and it truncates to a best fit model based on the iteration numbers we give. So, and this is the OCam's 2D model which we got with the, as you can see, the x-axis is the distance and y-axis is the elevation, or elevation is in negative, so we can say it's the depth actually, and we are seeing the resistivity model where we can see the two causative bodies of high conductivity or very low resistivity. Yeah. And currently we are also developing, developing empty data and empty data container module, which is a very important module as it can handles various data formats of all the instruments and convert it into a universal format which can be used for further processing and inversion. Thank you, everyone.
We can move to the next one. Any question? I think it's not a question. You have developed it yourself?
Yeah, me and my team.
This Pro, MT Pro?
Yes, sir.
This tool you have developed yourself?
Yes, yes, sir.
Okay, it is appreciable.
Thank you, thank
very
you,
good.
thank you very much.
Thank you. Welcome to the next person.
Proceeding towards the penultimate presentation of this session, I would like to extend the invitation to Shri Priyabrata Mukherjee, geophysicist, GSI Central Region Nagpur, who will be delving into the topic From Anomalies to Insights, Integrated 3D Geophysical Insights in the Thane-Vasna Shear Zone, Western Bastar Craton.
Good evening, everyone. I am Priyabrata Mukherjee, geophysicist from GSICR Nagpur, and we'll talk about From Anomalies to Insight, Integrated 3D Geophysical Insights in Thane-Vasna Shear Zone. Basically, in this work, we will discuss about how from the anomaly signature we can get that model in Thane-Vasna Shear Zone area. So this is the outline of my presentation. First, we will discuss about that the conventional method from that anomaly, how we can get some lineament and can predict that suspect body. And after that, we will correlate some geochemical anomaly, and finally we will perform 3D inversion, first gravity and magnetic individually, and then we will perform that integrated joint inversion using cross gradient method. So this is our study area in Chandrapur and Gadchiroli district, and which in the Thane-Vasna Shear Zone we can find in our inner study area, which basically comprises in Benpal gneiss and some sandstone geologically. So from NGDR side, we have downloaded some gravity and magnetic data which has been acquired in different FSPs by GSI. And from that gravity data, first we have plotted the Brugger gravity anomaly map, from which we can find the gravity anomaly is basically high on the Benpal gneiss and low on that sandstone. And after that, we have calculated the residual anomaly. From that, we can infer basically two parallel lineament. One is passing through Thane-Vasna Shear Zone, northwest southeast trending, and another is parallel to that just side. And after using these data, we have performed some derivative map. First we have calculate horizontal derivative map, and then we have calculate tilt derivative map. And both are passing through Thane-Vasna Shear Zone area. Interestingly, there is some black dot line where the Thane-Vasna Shear Zone is actually exposed. but we have get some continuation in north and south of this area, and later we will talk about it. We also have worked on the magnetic data, and there is 3 basic maps from the magnetic anomaly, and from that we also get 2 lineament, which is basically one is curvilinear and another is trending northwest southeast region, and the third figure is that analytic signal, which is basically exposed on that lineament, basically, which will say that extension of our body. For the magnetic also, we have calculated 2 derivative. One is horizontal and another is steel derivative map, and which are aligned on the Thane-Basna-Sayar zone area, and we can get some high values. And also interestingly, from that magnetic map, we can get some extension on north and south of the Thane-Basna-Sayar zone area. So it was that conventional method which we have done to get some lineament. Then we will done some spectral filtering. Based on that radially average power spectrum method, we can get the 3 section. One is depth around 800 meter, another is around 2 kilometer, and another is 7 kilometer. So 3 different physical parameter changes we can get in our study area. And based on that, we have applied bandpass filter on this area, and we have plotted 3 different sections based on that bandpass filter. One is for 800 meter, another is 2 kilometer, and another is 7 kilometer. So left side is basically presenting the gravity data, and right side is presenting the magnetic data. So from these 2 data, what we can get, the signature we can get on the surface. These are basically continuing in the shallow surface, and the signature in the gravity and magnetic anomaly, we can get that same northwest southeast trending lineament for both this section. This was that conventional method to get some idea about the depth from magnetic data. So for that, we have calculated SPI, that is source parameter imaging method, and from that, what we can get, that northwest southeast trending region, which is basically around the depth of 700 to 750 kilometer area, and the depth is basically minimum in the Thane-Basna-Sayar zone area, and it is somewhere higher on the region in Minjhari and Govindpur area. We also comprise some geochemical anomaly, which data are also available in NGDR portal, and we have plotted some major oxide as well as copper, zinc, and some other elements. And from that data, we also get some similarities with the geophysical maps. So after these things, we will perform some inversion and modeling for this whole region. So now let me take what inversion actually is. By that inversion, we can get some depth and structure of the causative bodies. And here we have performed it in 3D mode. By the gravity data, after inversion, we will get the density model, and after the magnetic data, we will get the susceptibility model. And further, we will combine this both data set to get some uniqueness and robust structure from both the data. And for this joint inversion, we have chosen the cross gradient method and use one Python-based algorithm to perform this. So this is the gravity 3D model after getting that inversion based on the Python, and for this model what we are getting, the main high dense zone are correlating with that lineament which we have get in our 2D map. And after that, we have performed that magnetic inversion, and from that inversion we model some susceptibility in this region, which are also correlating in northwest southeast region. And finally, from that cross gradient, we get 3 model. One is from the gravity data, what is density model, another is susceptibility model, which we get from the magnetic data, And another is that parameter, that is, which is basically the cross gradient, which we are getting from these two combined data sets. So both main lineaments are trending along, correlating with that Thane-Basna Share Zone area. And that cross gradient model is actually saying that extension of this region from the north to south. So this is the conclusive map that is in the exposed Thane-Basna Share Zone area. There is some northern extension as well as some southern extension. So northern part comprises the Govindpur, Minjhari, which have known mineralization. In southern part there is Thane-Basna zone, which have some known mineralization. So we think in between these two zones, which is basically also correlating with north and south, have some prospect mineralization from our studies. So that's all from my side. Thank you.
One or two questions we can take.
A small clarification on the area. Lot of work is done on the Thane-Basna shear zone.
Yes, sir.
With the drilling and the block established, and then it is auctioned. The Vedanta did bidding, and then I heard that they even started even mining operations also. What is this at this stage you are doing? Is it extension of the Thane-Basna blocks? Yeah, in the same area you are doing this gravity and magnetic studies.
So basically the aim of these studies is actually we want to say how geophysical anomalies is actually fitted with this lineament. And from these studies we are trying to make some algorithm which can perform 3D inversion, and it will map some subsurface bodies and its extension. So these from that what we have find, in the northern side there is some presence of bodies, high density and high susceptible body, and in the southern part there is also some high dense and high susceptible bodies. And that outcome of the inversion is that this body is basically continuing from south to north. So that means there may be some suspect of causative bodies in between these two zones.
Okay, it's like establishing the continuity.
Yes, sir.
You see, mineral commodity here is copper.
Yes.
Yes. What is the best geophysical survey you recommend for this picking up the copper mineralization?
First of all, we have to go for regional survey, which has been already done. Then for the further, we have to go for detailed survey, that is the IP resistivity. And it will be more suitable if we can cooperate with deeper IP, which will give our some deeper data as well as MT also.
Yeah, this is what I believe, that generally for base metals we prefer IP.
Yes, sir.
But since you went in combination with the gravity and IP, I am asking this question.
No, it is actually a qualitative studies. We have not studied this quantitatively, that which will mark our block or will provide exact depth. It's a qualitative studies to get some idea and extension of that body, how it's oriented.
Thank you. It's
Thank
very
you,
good job you have done.
Yes, sir.
Thank you.
Hello.
Geological evidence of that in the extension area of the shear zone?
So actually, sir, on the north there is some area named Palasgaon, and that quartz vein, some quartz bearing mineralization is present there, and that Palasgaon, Awalgaon, some areas are north of this Thane-Basna Share Zone. And these are some quartz vein bearing mineralization is there. So these are the geological evidence present in this zone.
One more question.
Yes, sir.
This Thane-Basna actually was done, lot of work was done by GSI, including geophysics also. Then it was purchased by the Vedanta in auction.
Yes, sir.
So your present study, how it is matching with previous GSI data as well as Vedanta's auction when they have auction in auction they have purchased it. They must have calculated something extension etc. Have you tried to correlate it with depth-wise extension and width-wise extension or continuity of it?
Further, I will correlate it with the borehole data, and will if we get some model and get some success, then I will proceed further for my studies. Till now, it's in qualitative stage, and I am only getting that extension. That's all.
Sir, if permitted, I just have a small observation.
Yes, sir.
Basically, Thane Basna mineralization, as I know, it's basically a quartz hosted granite within the granite.
Yes, yes.
But you say that geophysically you are having high density rocks, which contradicts with because normally granites do not have so much high density. So how you can clarify?
Sir, there is also some studies by Dora et al. That the Thane Basna is basically one of the famous IOCG deposit. And the property of the IOCG deposit is it will be high density as well as high susceptibilities, which is basically matching with our studies. So by these prospects, we can say if some high density or high susceptible body is present there.
Have you established any depth continuity?
No, till now I have not established any depth continuity. I just have studied is conventionally by that SPI and by that 3D inversion, both are matching. That's all.
Okay.
Thank you, sir.
So for the final presentation of this technical session, I would like to invite Shri S. Srinivas, Director Geophysics, GSI Central Region Nagpur, who shall be presenting on the topic Geophysical Mapping in the Delineation of Prospective Areas Favorable for Critical Minerals around the north of Korba, Chhattisgarh. So,
थोड़ा 2 मिनट ज़्यादा दीजिए because mine is the last lecture. Respected dignitaries, DGGSI, and the chairman of the conference, Sri Ganvir Saab, our ex-DGGSI, Kutumrao Saab, ladies and gentlemen, for the last session of this first day conference, I am presenting this geophysical mapping in delineation of prospective areas favorable for critical minerals around north of Korba, Chhattisgarh. This is the location map. Chhattisgarh, the block is located to the northeast of Chhattisgarh basin, where the work was carried out, significant work was carried out. This is the Google map. I have taken 6 topo sheets, 64 J by 2, 3, 6, 7, and 10 and 11. These diamond stars, these are the world workings and worked for critical minerals by State Unit Chhattisgarh in the last 10 years, from 2015 and 16 onwards. This is the Hasdevo Bango Reservoir, and this is the Hasdevo Bango Valley, and Khatgora area is here, and Korba comes somewhere here. The significance of this area is from critical mineral point of view. Way back in 1986, Natarajan has reported some occurrences of lepidolite, and based on this, in 2015-16, Nagaraju has taken the geochemical mapping of about 10 samples in 64 J by 10, in which 80 to 150 ppm of lithium is reported. Out of these 10 samples, 7 are from Katgora and 3 are from Sarbhanka and Tarmapahara areas. Afterwards, in 2018-19, one G4 investigation was taken up. In 2018-19, G4 stage item was taken up by state unit, in which lithium was reported up to 2000 ppm in leucogranite and up to 600 ppm in granitic pegmatites, and 27 samples of pegmatite has given up to 400 ppm. So the area is very promising for lithium, and subsequently the main advantage of this area is one block was submitted to the government of Chhattisgarh, and the block was successfully auctioned. That is the advantage of this area. And this year, 25-26, one G3 item is there and a G4 item is also there. The recent past in the last 2 to 3 years, during 23-24, one G4 item was taken up, and 22-23 STM item is also there, and 22-23 G3 item is there, that Rampur block which was auctioned. If we observe the values obtained in these investigations, this Raha area, Chindpahar, and pegmatite from Amagam, pegmatites from Mukwa area, and Kotmik Khurdi area, all these areas, they have given very positive values, not only for lithium, but niobium, tantalum, and RE in BRS pegmatites. So based on these results, it is the host rock for this lithium and RE mineralization is mainly granites, granitic pegmatite, and pegmatites. This is the geological quadrangle map of Bilaspur, 2016. So these are the blue color diamonds. These are the areas where work was carried out at G4, G3, and STM, and where we got some significant values for RE mineralization and lithium also. Broadly, the regional geology comprises of bottom one, these the Bilaspur, Raigad, and Sarguja belt, and in the eastern part, you have this lower Gondwanas. In southern, this southwestern corner, the periphery of the Chhattisgarh basin is Raipur group is exposed. So the rest of the area is completely granitic gneiss map in which these blocks were taken up. So this small inset picture, 3 blocks are there. Back. No, next one, madam. The inset picture where 3 blocks were there. This is the block which was auctioned, central block. The red block is the investigation which is taken for this 25-26, and the adjoining block is also already covered. The central block was auctioned, that green color one. Now coming to geophysical exploitation for critical minerals, mainly it depends upon the physical property contrast, structural features to be delineated, and integration of geological and geophysical data for selection of target areas. These are the features which we can derive from the geophysics, and in this case, NGPM data we have studied, gravity magnetic structural features, deep-seated structures, depth to the basement and mapping, delineation of intrusive granites and pegmatites. This is the data density map of NGPM, in which this category area is here, and this is the G4 item to be taken up this year. This is the Bruiser gravity anomaly map, in which this east-west high, gravity high is the Bilaspur, Raigad, Sarguja metamorphic belt, and the entire gradient zone, that green color one is the granite gneiss terrain. Within this granite gneiss, whatever low, whatever blue color is there, it is the intrusive granite. If we observe all these white diamonds, all are falling within this green color, and the contact of this granite gneiss with the metamorphic bed, and also in the low zone, which is the intrusive granite. So around 8 investigations were conducted from 2015-16 onwards. This is the residual map of the gravity anomaly, in which this bottommost one, this Bilaspur metamorphic belt, was clearly demarcated in the form of a gravity high in east-west direction, and in also one gravity high anomaly in the northern side also it was delineated in the northern part, topmost one. The area lying between the northern gravity high and the bottom southern gravity high, in between the area lying is granite gneiss, and low values, whatever low is there, northwest southeast low, that is the intrusive granite. In the eastern part of this Tuman area, some prominent small amplitude residual highs are there. They may be indicating some schistose rocks associated with the Chotanagpur gneissic complex. We have done the radially averaged power spectrum, in which we got 3 depths. 800 meters corresponds to the lower Gondwanas, and 1.8 kilometers, that is the granite gneiss. 3.8 kilometers is the deeper layer, which corresponds to the metamorphic belt. This is the low-pass filter map and the upward continuation. These two maps, what they are indicating is whatever anomalies we got, they all are of deep-seated anomalies. In the residual map, I have shown the extent of the shallow features up to a depth of 1 kilometer. These deep-seated anomalies, they are indicating up to a depth of about 3 to 4 kilometers. Now coming to the magnetic anomaly also clearly demarcated the bottommost Bilaspur, that Raigad metamorphic belt, very clearly from Pali to Jabal Pali, whereas in this particular topo sheet, it is in the form of a low only. And the northern part, whatever high I have told in the gravity, same high is reflected in magnetic also, indicating some sort of east-west mafic body or basement ridge with mafic mixture. The area lying in between these two things, two highs, number of lineaments we have drawn, and we can observe that these diamonds, wherever these old workings are there, this for the last 10 years, they are associated with the magnetic lineaments. So this much of area we are delineating for favorable for this RE mineralization, that is topo sheet number 2, 6 and 10. And these magnetic lineaments associated in different directions, both east-west and northwest-southeast. This is the analytical signal map, in which eastern side we are getting a prominent low anomaly, and the western side we are getting slightly high anomaly. These are the 3D deconvolution, different depths we got. This is the upward continuation map. In upward continuation map, after 1 kilometer, we got a very clear picture of this area, which is favorable for this lithium and RG mineralization, where these blocks are associated, and this Katkora high, where the block is auctioned, it is associated with the magnetic lineament in east-west direction. These are the, whatever there are, this area is the interesting area. Achha. These are the combined maps of geology, gravity, and the residual map. Bottommost one, magnetic anomaly, upward continuation, and analytic signal. So from these 6 maps, we can see we have identified a clear-cut area which is favorable for this lithium and RG mineralization, and the area is clearly demarcated like this. This is the low gravity and the gradient zone. These are important from gravity map. Residual map also indicated very clearly the prominent low anomaly in northwest-southeast direction, and this is the area. Similarly, in upward continuation of magnetic, we got a very clear area, and this is the area which we delineated. So this is the summary of the work. Total 8 geological investigations were conducted in this area. Out of this, 1 block is already auctioned, and remaining already I told. Internationally, if we look at the lithium and this RE exploration, lithium pegmatites are spatially associated with volatile-rich granite intrusions. So where pegmatite emplacement typically represents the final geological event in the respective districts, the magnetic lineaments which we identified in the form of shear and fracture zones, they are delineated within the granitenous terrain, and these inferred magnetic lineaments are significant for favorable mineralization, maybe hosting lithium pegmatites. Considering the importance of high priority of critical minerals, which is having impact on economic and national security, and also global competition and export restrictions, some of the countries, they are making priority top list. In priority top list, that particular country is not exporting this RE and lithium minerals for a particular period, and making the other countries' economy in a geopolitical situation, as well as energy transformation. These are the challenges of critical minerals which are forcing each and every country to search the critical minerals. For this, a critical mineral mission to be looked with research and assessment. Assessment means location of the deposit, quality of the deposit, quantity of the deposit, these things to be addressed clearly by high quality geophysical data, geological data, and geochemical data. Integration and delineation of the areas is the topmost priority of the day. Thank you, sir.
One question I want to ask. The different G4 stage works carried out for the lithium in this area, it was based on the geophysical work, the NGFM work we have carried out, and they are the spin of the NGFM work, or
No.
You interpret the already G4?
I have interpreted the data.
You interpreted the data in
Yes.
terms of that G4 investigation we have carried. Okay, thank you. Any questions from audience? Dear.
Srinivasa, a very good presentation, I would say, and a nice attempt in interpretation. Congratulations to you. There are no questions, but possibly one suggestion that you should share this data with the people who are working there already and discuss with them in detail about the geological interpretations and what is there on the ground. Because on one side, on the eastern part, you are comparing the Kadgora area in which the lithium is occurring within the granite, and on the western side, it is the pegmatites.
Intrusive granite.
Correct, included in the granite. So these are two different scenarios, the granite proton in the east and the pegmatites in the west. The granites don't match. Their petrography, their chemistry is entirely different. Both are definitely different plutons. So you should test your hypothesis or your interpretation of the geology of that area with the geologists who are working in Chhattisgarh, and you are most welcome to do that.
Thank you, sir. Definitely we will discuss, sir.
Any questions? Any more questions? I think that's all. No questions? Thank you, Srinivasan, sir.
Thank you, sir.
Madam, so we are coming to the end of the technical session 3. Now I would like to request our Maharaj to sum up the today's session.
We are very extended these sections. I think already it is 7:40. In these sessions, we had one keynote lecture by Professor Dr. Salivahan, and then there were other 4 presentations by different officers. Professor Salivahan, with the case studies and some examples, he tried to interpret 3 techniques of the MT survey, the seismic survey, and then the combination of this MT survey and gravity survey with the petrogeophysics. He tried to show the importance of this magnetic surveys for the searching of the minerals in different areas. He gave the global examples like the uranium, this Athabasca basins in Canada, where uranium deposits and mining is going on there. Then one example of Bayanovo RE deposit, China. And he also gave one example from India, that is the Dalma volcanics for the gold deposits. So this MT survey is really, in GSI also we are gaining some, it is important, and we are concentrating on this MT survey now since last field seasons. This MT survey we are concentrating, and I think we are going to soon for this MT survey based projects in different regions. And then the second lecture was given by Subham Roy, manager Hindalco Industry Limited. He gave delivered the lecture on the geophysical exploration for the Minjari copper belts, and this is the drone-based new technology, drone-based survey for the magnetic survey, as well as for this LIDAR survey for this topographic survey. And as we all know, it is a quick techniques where the ground geophysical survey took lot of time, but this drone-based geophysical survey, we can complete these surveys in a quick time, and it is the need of the hour. GSI has also adopted this drone-based survey techniques. And then the third lecture was on given by the Amandeep Singh on this new Python-based MT-Pros tool for prospecting and interpretation of the MT data. And it is appreciable that they have developed this tool for themselves for interpreting the data along with the other software available in geophysics divisions. And the next lecture given by the Priyabrata Mukherjee regarding integrated 3D geophysical insights in the Thane-Vasna shear zones, which is well known for the copper mineralizations. And he tried to interpret the Booger gravity anomaly and magnetic anomaly, and try to establish the extensions in the northwest and southeast directions of this. And it generated a lot of interest among our distinguished guests present over here. But due to time constraints, we could not go for more questions and answers in this case. And in the last, Srinivasan Saab has given integrated and interpretation, this delineation of prospecting areas which are favorable for the critical minerals such as the lithium mineralization in the Korba, Chhattisgarh area based on the National Geophysical Mapping carried out with the help of this seismic data and the gravity data, and some new areas we can find out. And this geophysics today is very important because as surface evidences of mineralization are almost exhausted. We have already carried out investigations with the help of these. So geophysics become a very important tool, but what I feel still we are lacking in the properly interpreting the geophysical anomalies or the geophysical data we receive from the different methods. There is a need of the hour to get the trained our geologists or our geophysicists in the data processing and interpretation of the geophysical data in terms of for the mineral exploration works. I think with this we can conclude this session.
Thank you so much, Mora sir and Bera sir. We were privileged to have you both for chairing this technical session. So now I would like to make an important announcement that tomorrow the 4th technical session will start at 9:30 a.m. sharp. So it is a request to please be on time so that we can start timely. So now for the formal conclusion of this session, wherein we were a witness to this interesting deliberations, may I now request the guardian of GSI Central Region and chairman of this conference, Shri D.V. Ganveer, Sir, ADG and HOD Central Region, to please felicitate with a memento as a token of gratitude to the chairman and co-chairman of this session, and also to the learned speakers for their enriching and insightful presentations. I request Shri LMS Mora sir, DDG and RMH2 Western Region and chairman of this session to please come on the stage. I now request Shri K.K. Bera sir, DDG and RMH2, please give a big round of applause. Now I request the learned speakers to please come on the stage one by one, and I request the audience to please enhance the energy of this hall. It's lacking right now. Shri Shubham Roy, Manager, Hindalco Industries Limited. Shri Amardeep Singh, Geophysicist, GSI Central Region, Nagpur. अमरदीप, हौसला अफजाई के लिए तालियां नहीं रुकनी चाहिए. श्री प्रियव्रत मुखर्जी, जियोफिजिसिस्ट, GSI Central Region, Nagpur. Please join your hands together and give a big round of applause to Priyavrata. Now I request Shri S. Srinivas, Director Geophysics, GSI Central Region, Nagpur. Thank you so much, Ganveer sir, for doing the honors. Ladies and gentlemen, with that we conclude the third and the last session of the first day of the conference. Thank you all for your cooperation, Looking forward to see you all tomorrow morning at 9:30 a.m. sharp. Have a great evening and a pleasant stay at Jabalpur. Thank you. Thank you so much. Oh yes, one more announcement, please. So all concerned speakers are requested to please hand over your presentations to the IT team well in advance. They can do it tomorrow morning. Aji? Okay. It is a request to all the speakers to please share your presentations today itself. Ninth.